Good morning, everyone. It is absolutely fantastic to be with you here at RustConf. This year has certainly been the year of things not going the way we expected them to, but I'm excited to welcome you to the very first virtual RustConf. I'm Nell Shemmerl Harrington, and I'm the lead editor of This Week in Rust, as well as a member of several of the Rust org teams, including the infrastructure team, Async Foundations, Community, and a few others. If my voice sounds familiar to you, it's likely because I am also the host of the This Week in Rust podcast on the Rust Station. Please check out both the newsletter and the podcast to keep up to date with all the amazing things going on in the Rust community. First, let's talk some conference logistics. We will be having a series of talks. All of our speakers have been working on these talks for weeks, and I think you're really going to like them. We will also be taking a few breaks for announcements and some content for our junior Rust stations. If you are a parent, you have likely been under a very heavy load trying to be a full-time parent and teacher and get your work done. To help with this, we have a few sessions specifically for small children and everyone who is young at heart. Please see the schedule for information about when those sessions are and for some simple toys your kids may want to snag now to bring along when it's time. If you have a RustConf ticket, you have access to two very important places to pay attention to throughout this conference. The first is the official RustConf Discord server. You should have received a link to this in your email. But if you are having trouble accessing it, feel free to tweet at the RustConf account on Twitter and we'll get you set up. If you take a look at the channels, you will see channels for each of the talks, for our top sponsors, and some hallway chat channels. These are great places to connect with your fellow Rustations throughout this conference. The second thing you'll want to pay attention to today is the companion app. Those of you who bought a ticket to the conference should have received a link to this app in your email, but just in case you can't find it, go ahead and ask a moderator in Discord and someone will look up your personal link. At the beginning of each talk, we will put some relevant links in the companion app, including the talk slides, a full transcript of the talk, and any other links the speaker may have asked us to include. Please note that these resources will go away after the talk is finished so we can show the resources for the next talk. If you miss something, go ahead and ask in Discord and someone will share the material with you. At the end of each talk, we will ask you to provide some constructive feedback on it. You'll be rating various aspects of it on a numerical scale. The reason we do this is so we can give this data to our speakers. I can say firsthand that they have put so much work into these talks, and the reason we collect the ratings and feedback is to help them iterate and improve on them if they want to give these talks again elsewhere. Finally, let's talk about my favorite part of the app, the ability to share photos. This is a way to express yourself throughout this conference. Since we're all at home, I'd like us to take an opportunity to snap a photo of our workstations, mine is already in the app, and share them with each other. Feel free to share photos of your kids, especially during the kids content. Share photos of your pets, of your reactions throughout the conference, and much more. And yes, the photos, like every part of this conference, must be in compliance with our code of conduct. Speaking of the code of conduct, it is available on the RustConf website. Check out Discord for the link. To quote the first part of the code of conduct, RustConf is intended to be an inclusive, welcoming conference for everyone. In particular, we do not tolerate harassment of conference participants in any form. Conference participants who are violating these rules may be sanctioned or expelled from the conference at the discretion of the conference organizers. We take our code of conduct very seriously. Please make sure to read it and comply with it at all times throughout RustConf. This includes in the Discord, in the companion app, in any spontaneous Zoom calls you might like to set up during the breaks, and everywhere you might find yourself. This is a great opportunity for us not only to set an example for each other, but also for the open source community as a whole. The Rust community is one where we value empathy and personal maturity as much, if not more, than technical excellence. Let's show the rest of the world how wonderful this community is. And of course, RustConf would not be possible without our wonderful sponsors. You'll be hearing from them both in Discord and occasionally in announcements. In particular, I'd like to call out our diamond sponsors, including Mozilla, Google, and Solana. In your own way, please give them a round of applause. Finally, if you bought your RustConf ticket recently, you may have noticed that we had sold out of swag. For those of you who still want to buy RustConf swag or want a different size t-shirt, please see our limited time swag store today or tomorrow. You can check out Discord or the companion app for the link. And with that, thank you so much again for coming to RustConf, and let's start out by hearing from the Rust core team.
Welcome to the RustConf 2020 core team keynote. I'm Manish from the Rust core team, and I'll be giving a quick foreword. First, a brief note. This talk was recorded before any of the recent events relating to Mozilla. Since then, we've put out this initial response on Twitter, as well as a post you can visit on the main Rust blog at blog.rustlang.org. This talk will be given by 5 members of the core team who will introduce you to. They'll be speaking in the following order. Nico is co-lead of the compiler and language teams. He works at Mozilla. Mark is lead of the release team and is the main maintainer behind perf.rustlang.org. He studies computer science as an undergraduate at Georgia Tech. Aiden is code lead of the infrastructure team and works with Rust at Hadean. Ashley has been involved in the crates.io community and infrastructure teams. She works at Apollo GraphQL building Rust and WebAssembly tooling. Nick is a Rust engineer at PingCap and has been involved in the compiler, language, and DevTools teams.
So hello, this marks the 5th birthday of Rust. That is, this year, 2020 marks the 5th birthday of Rust. And what do I mean by the 5th birthday? I mean that 5 years ago, we announced Rust 1.0 to the world. Right? We basically said, Rust is open for business, ready for use, and we're not going to break your software anymore. If you were using Rust before 1.0, you know that we broke your software a lot. We don't speak of those days. Actually, that's not true. We talk about those days all the time, at least I do. But anyway, the point is, 1.0 release 5 years ago, very exciting. And in the time since, we've seen a lot of people using Rust. More and more people, it seems like, using Rust for more and more things. Kind of more things than I ever imagined. I guess, okay, that's not true either. I can imagine quite a bit of usage, but more than I dared hope for sure. And it's been really exciting. And we figured that now with Rust kind of growing in use, this was a good time to step back, reflect on the last 5 years and the values that took Rust from where it is, where it was, that is, to where it is now, and hopefully that will see us into the future as well. And it turns out that when we were coming up with the current Rust slogan, we actually put quite a lot of thought into it, into what was a slogan that really captured what Rust was about. And this is the slogan we wound up with, and I've highlighted 2 words, empowering everyone, because I think those are the 2 crucial words that have been the through line for Rust from its first inception to its current incarnation. Let me explain, because I think we've come to understand those words even better over time. Right? Initially, we did think about empowering because we thought about empowering C++ programmers. We knew that we had existing systems programming experts, like the ones who were working in Mozilla, that were maintaining million-line code bases, and they were struggling. It's a lot of work. There's a lot of bugs to track down, a lot of subtle bugs with segmentation faults and irreproducible problems. And we knew that if we wanted to take those code bases to the next level, like if we wanted to extend Firefox with full parallel programming features and so on, doing it in C++ was probably beyond our resources. It was just more than we could muster. But if we could find a new language that would solve automatically a lot of those problems and let us focus on the things we actually wanted to do, then we could do it. And that's what Rust was all about. Right? And of course, you do see a lot of usage of Rust in Firefox today, and ever more every year, and that's super exciting. But along the way, this initial goal of empowering C++ programmers turned out to have a side effect that we didn't anticipate. And I first kind of learned about it watching this talk from Yehuda Katz in 2014, talking to Ruby programmers. And what Yehuda was saying here was, hey, Rust is a new language. A lot of you have problems that were well suited kind of to systems programming. Like you need to make this bit of code more efficient. And before, it may not have made sense to use a C or C++ extension because the maintenance hassle wasn't worth it. But Rust changes the calculus and opens the door. It makes it a lot more accessible. And so that began this really cool blend that I think we've seen to this day of programmers from a bunch of different backgrounds coming together to work in the same language and in the same community and bringing these different experiences. And I think that has been really great for Rust. And one of the key things that you can see even in this first example is that while we often think of programming communities as different, we think of like C++ programmers and Ruby programmers, that's already a bit silly, right? Because many of us love to use more than one language. We're not like distinct things, but also that the problems and the experiences from one community can really help the other. They're not separated at all. And we saw that with Rust, right? The goal here, we were targeting the problems of systems programmers, but it turned out we were opening doors and solving problems for other communities too. This is some slides from Julia Evans' 2016 keynote, which I love. And we were, by making improbable programs possible, as she says, we were empowering lots of people from lots of different communities. And that first time, I think it kind of happened by accident, right? But after that, we started to take this approach more deliberately of looking for problems that affect one group and trying to solve them in a way that benefits the whole community. Let me give you a few examples. First one is going to be cargo and crates.io. So I have a confession. When I first started working on Rust around 2011 or so, people were talking about adding a build system to wrap the Rust compiler. And I kind of thought, I don't know if we should try to do this. It seems too hard. We're probably just going to end up recreating makefiles, but worse. It seems like not a good use of our time. Now, why did I think that? Well, I thought makefiles were good enough, but I hadn't used systems like RubyGems, and I hadn't used NPM. I didn't really know what software reuse could really feel like. Luckily, there were a lot of people who had and who did, and luckily we did build Cargo, and we also built Crates.io, right? This repository that now lets you upload your packages and download and reuse, and now I totally get it. It's a really powerful tool to be able to just add one line of code and use somebody's package. And a key part of Rust's kind of empowerment story, a key part of making Rust programming productive. By the way, I'd like to give a shout out to the Crates.io team that tirelessly manages this website. And Sean, one of the team leads, will be talking later today, although not here, about Crates.io. I'm sure it'll be really cool. It's closing Keynote. Check it out. Anyway, so yeah, and in fact, I'm really, it's great that we did, because if you look at messages about what people love about Rust or about their first experience with Rust or something like that, what you're going to notice is time after time again, cargo comes up every time. Maybe not every time, most times. It's really cool. And I mean, look, there's some quotes I scraped off of Reddit and so forth, but this person, they hate everything about Rust. They hate the module system. They hate how verbose it is. They think it's ugly. They wish it were JavaScript. They wish it were C++. I don't know. But they love cargo, right? I think that kind of tells you everything you need to know. Another page I thought was interesting was this one. This talks about if you're coming to Rust from different backgrounds, what to expect. And it says when you're coming from C++, it may take you some time to get used to the type system, to get used to lifetimes. But in the meantime, you can enjoy using cargo, right? And you'll get hooked on that, and then you'll figure out the rest. And I think that kind of tells you what you need to know. That a lot of times, you might be thinking like, there's existing systems programmers, they're the experienced folks, they should be the ones leading the way. That's not always true. Sometimes it's people from other communities who have solved this problem. And it's often those experienced people who were kind of trying to tell you that's not a problem we're solving that benefit the most from the solution. And I can say personally that I have benefited, right? Hacking on Rust, we used to have this makefile to build Rust. It was an interesting makefile. I learned a lot about make from this makefile. I like how it starts with greeting adventurer. It had lines like this one. Let me just blow that up for you a little closer in case you can't read it. There's 6 distinct $signs there. Each one is like one level of escaping or something. Luckily, I've forgotten all of how this worked. We have replaced this since with cargo. It's a much better experience. Crates and cargo and Crates.io are great tools. They're one tool of a large family of tools, and I think that's a key part of the Rust experience too, that we really tried to keep our tooling and our accessible and fill the needs that people have to be productive and enjoy using Rust. But let's look at another example, error messages. So Rust error messages around the 1.0 time period, they were functional, right? They usually told you the line of code that caused your problem, and they tried to tell you why, but they didn't necessarily do a very good job. And I think most of us, since you got experience with Rust, you learn not to read the error message and just to jump to the line of code and look around and figure out what was going on. Now that all changed around 2016 when we started doing this big push on new error messages led by Jonathan Turner. The idea here was that we want to, well, this was part of, I should say, a bigger push to improve new users' experience with Rust. Right? And one of the key things that new users like to do when they want to learn Rust is run the compiler on some code, and they're going to get errors. And so if we can make those errors better and help them understand the problem, they're more likely to stick with Rust. That was the idea. And that's what led us to these awesome error messages we have today. It's also kind of what, we were taking some inspiration from Elm and from some other packages, and Elm is, I don't know about Elm, there's now like some of this friendly competition where people are really fighting to have the best error messages and copying ideas from one another. And I think that's awesome, right? I love that. And I'm glad that Rust is in that, is part of that movement. And in these error messages, we've really focused on bringing your code to the front and actually explaining the problem, giving you suggestions on how to fix it. And it was not, I should say, just one person's work. It was a lot of people who participated in this. It was a real community effort. We had to go through every one of the old error messages, and there are hundreds and hundreds, and convert them to the new format. And as part of that, we brought in a bunch of new people, including Esteban, who has since kind of taken up the lead of the diagnostics effort in the compiler. And I love this tweet where he talks about his goal of, can we make it so that you don't even need the Rust book? You just get all the information you need right from the error message. I don't know if we'll ever get there, but I think we're getting closer and closer, right? It's really cool. Esteban also is talking later in RustConf. Check that out. Now, all of this stuff was focused on helping new users learn Rust, improving the experience when people first start with Rust. But is it only new users that benefit from good error messages? No, everybody benefits, right? Even people who've been using Rust a long time. And in fact, we're all just kind of accustomed now to actually getting useful information out of our errors. So it's been something that really worked for the whole community, even if it came out of focusing on the needs of new users. And one last example is the code of conduct. I think most of you know, it should come as no surprise, that the internet can be a hostile place. There are a bunch of jerks. They like to say things. They're not often that constructive. And that kind of gave rise to a movement amongst software packages and open source communities and just communities in general to establish codes of conduct, right? And Rust is one of those projects. We've had a code of conduct from the very beginning. Our code of conduct says you shall not use harassing language, demeaning language, and so forth. But it also says things like you should appreciate that there are design trade-offs, that not every design has a single best answer, and you can have disagreement about which one is the best. And the goal of a code of conduct, part of it is to make the language a more inclusive space, to help get more people in. And you might think then that that's really what the audience is for, people who aren't currently part of the community, trying to make their experience more pleasant when they first join. That's true. But interestingly, if you look at what motivated Graydon, he's the founder of Rust, initial person who started the project and who insisted on the code of conduct at that time, why did he do it? It's not that it wasn't for other people, but it was also for himself, right? Because he had been a part of many different open source projects in the past and language projects. And he found that, if he was going to work in this space, he wanted to work with people who are respecting these precepts. And so I think it's a good case of focusing on the needs of sort of newcomers to the community who might be turned off by the kind of style of discourse that had been happening, actually makes the life for everyone who's participating much, much better. So I do say, when we talk about code of conduct, another key part of having a code of conduct is having an enforcement mechanism, which implies moderation. And we all owe a big thank you to the moderation team that does a very difficult job. If you'd like to appreciate how difficult it is, I can't recommend enough this comment by Burnt Sushi. The URL is there, it's unread. I've pulled out one particularly interesting quote, but it's a much longer comment, and all of it's worth reading, about how hard it can be to have to try to stand in a conversation and draw the line of what is acceptable and what is not. So thank you to them. Now, I've given 3 examples, but there's so many more, right? Once you start looking for empowerment as this theme, and especially this idea of kind of newcomers or learning from newcomers to benefit the whole community and learning from different communities to benefit one another and so forth, you start to see it everywhere. It goes from the language design via things like the ergonomics initiative to the way that we run our project, right? Focusing on efforts like the Rusty Dev Guide or having RFCs and teams, to the tools that we use to run the project like GitHub and so forth. They're all oriented at empowering people to participate, empowering people to use Rust and to learn. So I think it's really this central story of Rust itself. But I'd like to hand it over now to Mark, who's going to give us another look at the history of Rust, this time from a more numerical perspective.
The key element in making Rust the language it is the people who participate in our community. The Rust team also tries to automate what we can to keep our human population happy. While we currently have 305 team members, there are many more people discussing and contributing to Rust on GitHub and our forums. We are also seeing hundreds of people joining conversations for the first time just this year. Not only are people joining conversations on GitHub and the users forum, but we are also seeing much more issue traffic. Over 2,000 issues are being filed each month. We can also see that ever since 1.0, we have been steadily accumulating issues across the organization. More issues are being opened than closed. This is one of the reasons the language compiler and library teams are looking at restructuring their interfaces to the wider community. We don't yet know if the ideas we've identified will work out, but experiments are ongoing. GitHub contributions are great, but aren't the only way to participate in the community. We've had more people publish crates in 2020 than commit to our GitHub organization. Crates.io is not only seeing thousands of publishers, but we are also seeing many new versions being published. And of those versions, over time, we're increasingly moving towards stability. Around 20% of the versions published in the last 6 months are 1.0 or greater. Having taken a look at all of these statistics, it is clear that Rust is growing rapidly.
And growth means change. And although things can feel permanent when you join a project, the people that you're working with, the structure that you're working within will last forever, that's not the case. People will leave, join new projects, new people will join, and this is okay. In fact, evolution can be a good thing. It means the project is adapting to growth and changes. And as an example of this, the teams within Rust didn't exist when the project first started. It was as a response to the growth and the emerging responsibilities. And RFCs are another example of an evolution in Rust. But change can be disruptive. And you may have encountered cynical takes on this, such as talking about the good old days or referencing something called the Eternal September, which is an event where a large influx of new users into a community overwhelmed that community's ability to induct those users and introduce them to the culture and norms. And this is important for us because it's a consensus-based project. There's no benevolent dictator for life, as you may have seen in other projects. We have to deal with this by coming to an agreement around what the routes forward. And the way that we can overcome disruption here is with a set of shared values and alignment around the things that we believe are important for the project. Know that values aren't optional. Not having a set of values is in itself a value choice. And in order to choose a set of values, we need to consider what's core to the culture of Rust. What do we want to preserve about it? And the answer is people. The Rust project focuses its values on people. And I'm going to go through 3 different kind of concrete manifestations of this, where you can see this hopefully more clearly. So the first is in eliminating things that don't need to be hard. So one of the core promises around Rust, which Nico touched on earlier, was around making it feasible to write applications of a particular kind. And part of this is about reliability. One of the key promises of Rust, that it just eliminates certain classes of bugs at compile time. You don't have to think about them. It doesn't need to be a hard thing to do. Another example of this is the module system. And this is something that the Rust project iterated on. So the language team, as part of a project to identify the things that people found difficult to understand or work with, observed that the module system that was released in Rust 1.0 was confusing. And so actually created a set of RFCs to discuss and design a solution for this, which was eventually landed and is now available in Rust 2018. So if you download Rust today, you're actually benefiting from this redesign and this desire to eliminate confusing or difficult things. The next example is educating on things that are hard. So we recognize that we're not going to be able to get rid of everything that's difficult, but we can try and help people when they encounter them. So one example is errors, which was covered earlier on by Nico, which has had a lot of effort put into it. And this user has, in years of using Rust, encountered an unhelpful error message for the first time. And as it happens, this was improved shortly afterwards. And it kind of demonstrates the success of errors, that this is the first one in those years. The other example of this education is around the focus that Rust puts on docs. So Rust has a standard for creating documentation, RustDoc, that's distributed with the compiler. It has high quality documentation for the standard library, and it has automatically built documentation for every version of every crate that gets uploaded to the package registry. And this is an incredibly impactful thing when you're trying to start on a project, trying to figure out how to use it. You know that there will be some documentation available for you to use. The final example is providing access to spaces and power within the project. So the most obvious example of this is in the RFCs process, which is the way in which decisions are made in the Rust project to post a proposal in a public forum, let anyone comment on it, discuss it, and then have the team come to one of the Rust teams come to a decision on it. And it's a very open process where anyone can have their say. Another example of this is the code of conduct, which Nico covered earlier as being a way to provide spaces within the project for people to participate. Finally, the team structure. So the creation of teams is something that gives people power within the project to have their say, to contribute. And this is something that is we've been talking about for a while. So this is a slide from the 2018 RustConf core team keynote, and talks about making a space for people to step into to help out in the project. And ultimately, the reason we center our values around people is because technology is by people for people. And so focusing your values on people and caring about people actually makes great technology.
Thanks, Aidan. So we've just heard that, great technology is built both for and by people, and that is a critical value involved in building great technology. But I do think that the term great technology can be somewhat kind of ambiguous, or at least vague, maybe to the point of meaninglessness. And so I'd really like to bring definition to that term by centering it around this concept of impact. And so I think one can say that great technology is technology that has impact. And I think that begs the question then of what does it mean for a programming language to have impact? And this can feel like a very philosophical question, which maybe coming from me is unsurprising to many, but I actually think this is a question that Rust has been asking itself since very, very early on. And I think it has, centered a lot of the conversations and questions and decisions that the project has made over time. And hopefully you've seen a fair amount of that from what my other presenters have talked to you about today. But I think one of the moments where we became most explicit about the type of impact we as a programming language, Rust, wanted to have was during the release of the 2018 edition, which certainly had its bumps. It was a really, I think, emotional but critical time for the project. But one of the biggest portions of it was, at least to me, releasing a new website for the project and also a new slogan. And so the slogan that, after some hard conversations with the community, that we eventually came up with was this: a programming language empowering everyone to build reliable and efficient software. And so this was not something that I had originally chosen, though I had originally included the language of empowering everyone. And that's the part that I really think is by far the most interesting, but also the most critical as we think about the type of impact that Rust wants to have. So what do we mean when we say empowering and empowering everyone? So Rust wants to be empowering. I think this is really central to a lot of the reasons why people like working on Rust. I also think that the concept of empowerment is central to a lot of Rust's ability to be incredibly successful. But I think the term empowering hides within it a lot of interesting and really poignant complexity. So it's not a talk, right, if we don't look something up in the dictionary, and we're going to do that for a while in this section. But the term empower here is a verb meaning to give someone the authority or power to do something. And I don't think that should blow anyone's mind, but something that I think is really critical in here is that at the center of the word empowering is the word power. And power is a really, really interesting and really important concept. So here, what I've done is kind of an inverse lookup, but I've looked up the term politics, which now people might be going, Ashley, what are you doing? This is a talk about programming languages, and now you're bringing politics in it. Don't be that person. But what I want to say is, by bringing up our slogan that we seek to empower everyone, we've already brought politics into it. Because what is politics? So the first half of this definition says activities associated with governance of a country. And so that's probably what most people think of the term politics when they originally think of it. But I think this second portion is the part that is significantly more interesting. So here it says, especially the debate or conflict among individuals or parties having or hoping to achieve power. And if you recall, we have this key word, empowering, inside of our slogan. So the idea of politics, which I would just define as systems of power, right? Because Rust seeks to be empowering, we are already seeking to be political, right? Rust wants to be political. And this may be a controversial thing to say. I could imagine that there are people who are frustrated by this, but at the end of the day, I think it is by far one of the most core and foundational concepts in Rust, to the point where it's not just that we want to be political, it's that we always have been political. And that's something that we think is really important. Now, this also isn't terribly surprising, right? It's true that Rust is trying to be explicitly political, but all technology is political because technology fundamentally gives certain sets of people power and the ability to achieve all sorts of things, the way we've seen software completely changing our society and our world, right? So technology is political, whether it wants to be or not. And I think it's great that Rust really wants to explicitly be political. Howard Zinn, and I think many other people have said something to this effect, have kind of said, you know, you can't stand still on a moving train, right? Technology is political. So we can choose to say, oh, Rust, it's just a programming language, it can't be political. Or we can embrace that and try and do our best to be as deliberate and focused on our political aspects as we possibly can. So what I think when I think about our slogan of Rust wanting to empower everyone, to empower people, is that our fundamental relation to power is that we're really interested in redistributing it, which is an incredibly, powerful idea, no pun intended, right? So what does this mean? So we've talked about how the Rust project focuses its values on people. And I don't think that many people would think that that is terribly controversial. But I think it starts getting really interesting when we acknowledge that while we want to help everyone and we want to empower everyone, at some point, when we think about things, we need to choose certain people. And so while in our previous conversations, we've referenced the idea that there's false dichotomies, that like a C++ developer and a Ruby developer still aren't really all that different. And I genuinely believe that to be true. I think that that can be true while at the same time acknowledging that as we seek to be a project with impact, we cannot be everything to everyone. And so we have to make choices about the types of people we focus and center on in the project. So in the Rust 2018 keynote, I made this Captain Planet slide where I talked about all the different audiences that we see in the Rust community. You know, we have like the Rust diehards that have always been Rust, always forever. We've got folks from academia. We've got folks coming from lower level languages like C, C++, assembly. We've got some higher level scripting language people, JavaScript, Python, Ruby. We've got people who have never programmed before who come to Rust wanting to be programmers, so brand new folks. And this is part of the like really vibrant diversity that I think makes Rust really, really amazing. But we cannot, all of these different audiences have very different needs. They are very, very different types of people. And we want to embrace all of them at the same time, but focusing on all of their needs equally at all times is not something that any project is capable of doing. And it makes it incredibly hard to focus. And so we've heard this slogan, right? Like a rising tide lifts all ships. And what's interesting about this, I looked up this Wikipedia page for this slogan. Y'all should check it out because it's not nearly maybe what I think the Rust ideology has kind of adopted this slogan to mean. But in here, there's like a hidden judgment, right? I think, and the judgment is something that I think we can all agree on, which is, so we say a rising tide lifts all ships. The judgment here is that a rising tide should lift all ships. And that's something that we really want to be the case. But now this is an aspirational slogan, right? And then if we really think about it, we say a rising tide should lift all ships. You know, it often doesn't. And that's something that we don't think is acceptable, right? Like we think that a rising tide should lift all ships. So as I said before, focusing on the needs of everyone all at once can be incredibly difficult. And I think for a project that's largely built of volunteers, our focus and our attention is by far our greatest resource. And it's certainly the resource from which we can derive the absolute most value. And so the real question here is, as we focus ourselves on people as a project that values like the humanity of technology, like what should we focus on? Where should our focus be? And so what we've settled on is we really genuinely believe that we should center on people who have the most need. So these are people who, you know, have the least amount of resources, the least amount of ability to help themselves. We think that those are the folks who need the most help, and as a result are the ones who deserve our focus. And the awesome thing about this that we've heard from Nico is that when we focus and center on the people with the most need, the things that we're able to produce actually end up helping everybody, sometimes in really surprising ways. But at the core of this is our political choice, that we want to center the folks with the most need. So as we look at this slogan, a language empowering everyone to build reliable and efficient software, I don't want you to think that we've thrown this everyone out. However, I think that this is true, but there's a core of it that is truer, which is we are a language empowering everyone, but especially folks who didn't think that systems programming was for them. There was a big argument about whether or not we should include the term systems programming in our slogan. And we ended up taking it out largely because it's been such a gatekeeping term. It's kept people away because so many people self-identify as someone who could never be a systems programmer. And while it's not in our slogan, because that sentiment around the gatekeeperness of the idea of systems programming is 100% true, at the core, we still want to take that concept of systems programming and break it free from that sense, because we want it to become something that is accessible to everyone. And in that sense, we're trying to redistribute the power of systems programming. And that redistribution is our impact. And it is fundamentally political, whether or not you find that distasteful. And it's something that I think the Rust project is incredibly excited about. And so we've done a lot of really interesting things. There's things where we've been able to see this today. So this is Rebecca. Rebecca is one of the speakers today here at RustConf. And she had tweeted that it kind of owns that more than 50% of the RustConf speakers are trans this year. And I gotta say, like, that is so friggin' cool. I have never been to a conference where that is true. And I am really proud that that conference that I get to experience that at is RustConf, and I also don't think it's a coincidence. I do not think it's by mistake, and it's really, really exciting to me. But simply because we have wins like this, like, doesn't mean that we can just like fly the mission accomplished flag, right? We have done some amazing things, but there's so much more that the Rust project wants to do. If we really want to achieve that ambition of redistributing the power of systems programming, we've got a lot of work to do, right? And if there's anything you hear from me today, it's that Rust has some pretty amazing ambitions. And these ambitions are what motivate me to work on Rust. And that's fucking awesome. But our ambitions right now are currently greater than our capacity. We've got dreams of doing some pretty big things, but we want to do them right. And doing them right means that we need to create more capacity for ourselves to be able to achieve those goals. I was talking with my friend Jen Schiffer recently, and we were talking about these concepts of accountability and aspiration. I think I've covered pretty seriously that we have some pretty huge aspirations here at the Rust project. But what we really need now is accountability. And I think that we know what we want to do, and we now need to build the organization that's going to get us there. And to do that, we're going to need all of your help. So it's time for us to grow. And everybody who's in this audience today, who's watching this at home, we really need you to get involved. And so if these ambitions and these aspirations that I've shared about haven't scared you, have excited you, describe a future that you want, we need you to come help us get that done. And here's Nick, who's gonna tell you a little bit more about how to do that.
So we've got to grow to achieve the things we want to achieve, but we've got to grow sustainably. You've probably all seen that Rust, for the 5th year running, was the most loved programming language, according to the Stack Overflow survey. I want to look back in another 5 years and see us getting that spot, for the 10th year running. And I want to look back and see Rust getting better and better. I don't want to look back and think, well, that was a project with amazing potential, and it's such a shame that it burnt itself out. So how are we going to achieve that? There's a well-known proverb in New Zealand, he aha te me nui o te ao, he tangata, he tangata, he tangata. And it means, what is the most important thing in the world? The people, the people, the people. This holds, I think, for every project and every organization, very much including Rust. We have to look after our people in order to have a sustainable project. So how can we look after each other? Let's start by having a look at some of the concrete things we're going to be doing over the next year or so with this goal in mind. The first thing I want to talk about is the 2021 edition, and for some of you who were part of the 2018 edition, then this might seem like the absolute opposite of looking after each other. If you look at RFC 2966 and the way that that lays out how we'd like to run the 2021 edition, the idea is that we're going to have editions on a regular cadence, much like our 6 weekly releases that ride their trains. The edition are going to ride their own trains. It's just going to take 3 years to come. So that means that there should be no high pressure deadlines to get stuff finished for the edition, and hopefully that will make it a much less stressful experience. We are intending to continue to improve our governance and organizational structures. And now's a good time. We'd like to say thank you to the governance working group. They've been active for the last year roughly, and they've done some really great work looking into the various governance structures that we have and ways that we could make them better. We're also actively exploring starting a Rust Foundation. The primary motivation for that is financial, and that's an important part of looking after each other in the capitalist societies in which we live. We talked about RFCs earlier in this talk, and RFCs are a really important way that we keep the evolution of Rust open, but they can also be hard work. We're looking at a whole bunch of ways that we can improve the RFC process. The compiler and language teams are experimenting with some of those changes already. We are trying to make what the core team does more transparent. Now, some of the work that we do necessarily has to remain private, but a lot of it doesn't. And we have a large part of our weekly meetings are public. Pietro announced back in July that we're experimenting with a way to open up the public part of the core team agenda so that everyone can follow. I also want to go over some of the concrete ways we hope to continue to empower our users. On the language side of things, we're going to continue to focus on ergonomics and on usability. And I think the development of async await is a great example of that. Async programming is difficult, but async await certainly makes that much easier. And as we go forward, hopefully we're going to have to make it easier still and to have a more complete solution. Cargo Clippy is a great tool. It's really helpful for beginners to learn what idiomatic Rust looks like, and it can be useful even for experienced users to avoid some of the possible foot guns. Cargo Clippy is getting a fix feature so that it can actually fix your code as well as just tell you what's wrong. IDE support is really important to Rust. It's something that is asked for, or for better support every year in our surveys. And I think, again, like as a learning tool and as a tool for improving the effectiveness of programmers, IDE support is a really empowering technology. Rust Analyzer is an alternate IDE backend that is not based on the Rust compiler. And because it's purpose-built, it's faster and more responsive than the RLS. And RFC 2912 lays out the path for making Rust Analyzer the default for Rust IDE support. And Rust Analyzer is available right now on RustUp, and the VS Code plugin supports both the RLS and Rust Analyzer. We want to empower users to become contributors to the Rust project. And the Rust Forge and the Rust C Dev Guide are two great resources that have been really developed over the last year or so for exactly that purpose. The infra team have also done great work to make our infrastructure easier to contribute to. It's hard to think of anything more important for building a sustainable community than safe, inclusive spaces. And I'd like to say thank you to the mod team at this point, because they're a big part of that and they do a really difficult job. So thank you. As far as maintaining our inclusive spaces, I think that the Rust project started really strong. We've had moderation, code of conduct, and then an official mod team from very early on. As the communities got bigger, maintaining these spaces has become harder. And a lot of the work that the core team has been doing, but we can't really talk about in public, has been dealing with a lot of these issues. And I think that the work we've done over the last year should help us much more effectively to maintain the inclusive spaces we have going forward. We believe that having a diverse community is really important. And to be honest, this is somewhere where we haven't done as well as we would have liked. There have been some good bits, some highlights, RustBridge, increasing Rust reach, just to name a couple. But overall, this is not somewhere I think that we've excelled. We need to do better, and we will. Over the coming year and into the future, we're going to make building a diverse community one of the highest priorities for the Rust project. So that all reflects our strategy, but culture eats strategy for breakfast, apparently. Let's have a look at how we'd like the culture of the Rust community to look. First of all, please look after yourselves. It's tough times around the world in lots of different ways and for different people. Don't let yourself get burnt out. That added stress makes burning out so much easier. If it's helpful for you to do less work, please do less work. Be kind to yourself. We don't kind of need heroes to be a sustainable project, but we do need people who are going to be around for the long term. And please look after each other. Again, when times are tough, we just need to treat each other with a little bit more kindness than usual. A really important part of that is mentoring and community building. It's really essential work to do if we're going to have a sustainable project and a sustainable community. And I think Rust really does have one of the best tech communities around, but we can always do better. And as it grows, we've got to keep doing this work in order to keep it good and to keep it getting better. I just want to shout out to the awesome Rust Mentors website, which was put together by Jane Lusby. This is a great website which simply connects mentors with mentees to help facilitate mentoring. We talk about empathy in the Rust project, probably more than most tech projects do, but I think it's really important. Empathy is how you understand the needs of another group, and being empathic to our users is how we've developed the language into being a good language, frankly. And being empathic towards each other is really important for having productive and enjoyable discussion rather than horrible, stressful arguments online. I think to prioritize empathy is a great ask to finish on. That's all from us. I hope you recognize the community you're part of in this talk, and hopefully it's something to think about how we can keep it awesome as we grow and as the language matures. We'd like to finish by saying some thank yous. We'd like to thank the RustConf organizers. Leia and Skylight have basically made everything work, including the transition to an online conference. Nell is the chair of the program committee and has also done a lot of the organizational work. And everyone on the program committee, they have done a great job putting together a really good program that we hope everyone enjoys. And of course, our sponsors for coughing up the cold hard cash needed to make something like this happen. That's all. We hope you enjoy the rest of the conference.
Hello, everyone. I'd like to introduce you to Miss Lucy, one of my 3 pet bunnies. She's feeling a little shy, but we're looking forward to enjoying the kids' content together very soon. So if you are a parent, get ready to grab your kids and put them in front of the screen in about 30 minutes right after this next session. If you like, go ahead and tell them to bring a laundry basket or other large lightweight basket of some kind, a sock, and a couple of their favorite stuffed animals. We'll be using them in this session, and we'll see you soon.
Hello, and welcome to my talk. Error handling isn't all about errors. Let me start by introducing myself. My name is Jane Lusby, and my pronouns are she, her. On the internet, I go by Ya or Ya-C, and I've been writing Rust for about 2.5 years now, though I was only recently hired to do so professionally by the Zcash Foundation. Now, quick shameless plug, I also maintain Awesome Rust Mentors. Awesome Rust Mentors is a list of projects and people who are willing to provide mentorship to anyone who asks. If you're interested in finding a mentor, finding a project to get involved in, being a mentor, or getting people involved in your project, you should check it out. Also, to be clear, there are more than just these 2 mentors, so please check out the website. Moving on. So, why error handling? I actually got into error handling on accident. It started as a yak shave when I wanted to open source a library that I wrote for work, but I wasn't happy with the error handling, so I decided to fix it up first. That yak shave ended with me writing error. Error is a fork of anyhow with support for customized error reports via a global hook, similar to a panic hook. I also ended up writing color error. Color error is a library which provides a custom panic report hook and a custom error report hook for error. With these libraries, I'm now able to construct error reports that look like this. Here we can see the basic usage example. In it, we have an error section, followed by a span trace section, and if you're not familiar with tracing, this is an extremely cool backtrace-like type of tracing spans. Then after that, we have a suggestion section, followed finally by an omitted backtrace section. I can also enable backtrace capture. So here we now have a backtrace section, and we can control the formatting of this backtrace section. Here we've just pretty printed it in the style of color backtrace, which hides irrelevant frames. In this case, it's hidden 5 frames before read file and 10 frames after main. We can also take this further though by applying custom filters. Here you can see we've got 11 frames hidden after read config instead of 10 frames hidden after main, because I've configured it to hide the main frame. We can apply this custom filtering consistently to all of our error reports. So here you can see we have the same report format for panics as we did for our errors. And with our error report hook, we can also bundle arbitrary data with our error reports. And we can use this to implement things like custom sections in our error reports. Here you can see that in addition to the error section, we also have a command section showing which command we tried to run, and a stood error section showing the output of the command when it failed. We'll dig into this example more later, so please look forward to that. Finally though, we can also add errors as sections, which we can use to aggregate multiple errors into a single report and format them all consistently. Now, I'm not giving this talk to talk about error or color error. I'm giving this talk to share what I learned in that yak shave to fix the error handling in my library and how the process has changed how I look at error handling and error reporting. So, what is error handling? Error handling is a lot of things when you zoom in up close. Error handling is defining errors. It's propagating errors and gathering context. And by context, I mean stuff like the path you tried to open or backtrace showing where your error came from. It's also reacting to specific errors and discarding errors, doing so intentionally and visibly. Finally, it's also reporting errors and their gathered context. Now, this breakdown gets to the goal of my talk. I have a theory that error handling is made more confusing by people trying to simplify it, because among other things, error handling is kind of annoying. I worry that the fuzziness between the different responsibilities makes it hard for people to infer what tools they should be using when handling errors. And my hope is that by breaking error handling into its component parts, we can make it easier to understand and explain. So let's start with the fundamentals. Note that this first bit was taken almost word for word from the Rust books chapter on error handling. The Rust model for errors distinguishes between 2 classes of errors, recoverable and non-recoverable errors. Recoverable errors are errors that can reasonably be reacted to or reported when encountered. These are errors like file not found or connection closed. Non-recoverable errors are errors that cannot reasonably be reacted to, only reported before exiting the thread or program. These errors are usually caused by bugs, such as index out of bounds or integer overflow. Now, most languages don't distinguish between these kinds of errors. For example, C++ has historically used exceptions for both. But Rust doesn't have exceptions. Instead, Rust has panic for recoverable errors and result for non-recoverable errors and result for recoverable errors. Sorry. So panic. Non-recoverable errors in Rust are created via the panic macro. Here we can see an example of an index out of bounds error. The only input for the panic macro is an error message and optionally some context to include in that error message. Reporting and default context gathering is done by the panic hook. And by default context gathering, I mean capturing the caller location or capturing the backtrace if it's enabled. And once that panic hook is done printing the report, the panic handler takes over and cleans up, either by unwinding the thread stack or boarding the application altogether. Next, we have result. For recoverable errors in Rust, we modeled them with the enum result TE. This enum has 2 variants, OK, which contains the value of an operation when it completes successfully, and error, which contains the error value of an operation when it could not be completed successfully. We use result to combine 2 return types into one and assign meaning to each possibility. In addition to this, Rust has marked the result enum as must use, which makes the compiler emit a warning whenever the result is discarded implicitly, prompting us to discard it explicitly or otherwise handle it. This helps us avoid ignoring errors accidentally and makes discarded errors visible to later readers. The big advantage of using enums for recoverable errors is that we must react to all errors. Here you can see we have to use match, or anything equivalent to match, to access the values inside of either variant. With an enum, we can't access the inner values without first accounting for all the variants that enum could possibly be. Next, we have the try trait and the try operator. The currently unstable try trait is used to model fallible return types in Rust. Indeed, result is a type that implements the try trait, as does option and some other combinations thereof. With the try trait, Rust is able to abstract the propagation of errors with the try operator. Here we can see two equivalent code snippets. The first manually propagates the error using match and return. The second does the same by simply using the try operator to propagate the error. Finally, we have the error trait. The error trait fills three roles in Rust. First, it lets us represent an open set of errors by converting any type that implements the error trait into an error trait object. This is important for composing errors, and it is what lets us expose our source errors via the error trait, regardless of their actual type. Second, the error trait lets us react to these specific errors by trying to downcast them back to their original type, safely, rather than using match as we would with enums. Finally, the error trait provides an interface for reporters. Now, I'll get to this last bit some more in a minute, but first, let's review. So, by now we've covered fundamentals, and you know all the tools the language and the standard library gives you to work with the different kinds of errors. So let's see how these fit into our original breakdown of the parts of error handling, starting with recoverable errors. So we define recoverable errors with types and traits, propagate them with the try operator. For matching and reacting, we do that with match or downcast, depending on how it's represented. We discard them with drop or unwrap if we want to promote a recoverable error to an unrecoverable one. And for reporting, we use the error trait. For non-recoverable errors, we define them with the panic macro. We propagate them. Well, we don't. It's built into the language, actually, so you don't have to worry about it. For matching and reacting, please don't. This is the whole point of this split between recoverable and non-recoverable errors. Like, you don't do this one thing for non-recoverable errors. For discarding, you can use catch unwind, though I advise you to use caution before reaching for this. And finally, for reporting, we use the panic hook. Okay, so now we know all the fundamental tools built into the language and where they fit into error handling. Next, I'd like to dig into the more complex ways you can compose these tools to write some fancy error reporting. But first, let's set straight some terminology. In the context of error reporting, an error is a description of why an operation failed, whereas context is any information relevant to an error or an error report that is not itself an error. And an error report is the printed representation of an error in all of its associated contexts. Now, the concept of error reports and error reporters isn't a concept that is common in the Rust ecosystem today, or any language's error handling ecosystem as far as I know. However, it is a vocabulary that I find particularly compelling in the context of Rust error reporting, and this is largely because of how Rust has defined its error trait. Here's a simplified version of the error trait. Here you can see we've got two super traits, debug and display, which we must implement to implement the error trait. Then below that, we have two functions, source and backtrace, both with default implementations that we can override when needed. Next, let's look at a simple error. Here we've got a type with no members. We derive debug on it, and then we implement display, where we just write our error message. And finally, we just implement the error trait. Now, we don't have a source or a backtrace, so we don't need to override any functions here, which is why the block on the trait implementation is empty. If we did have a source, though, we would need to override source function in order to return a reference to our source as an error trait object. Finally, let's take a look at a simple error reporter. Here we've implemented our reporter as a short free function. This function takes an error and then prints that error and all of its sources, followed by a backtrace if our error captured one. A more complex error reporter might also try to check all errors for a backtrace, or if it were a type and it was storing its own context in addition to the error, it might print that as well. Now, in other languages, there is no distinction between errors and reporters, and this is largely due to a lack of the equivalent of the error trait. The error trait equivalent in other languages is often quite simple, just a single function to grab the error message. These interfaces force you to either include your source error, your backtrace, and any other information you care about in your error message, or to avoid using the provided interface altogether. In Rust, we don't have to combine our messages all into one. In fact, you're encouraged not to. Including a source's error message in your display implementation and returning it as your source via the error trait is essentially a bug, as it forces reporters to duplicate information when they print out the chain of error messages. By separating the source and the error message, we move responsibility of formatting away from the errors themselves, making it possible to get fancy. In Rust, we can have the same error print to a log as one line, but to the terminal as many. This wouldn't be possible if the error trait didn't separate error message from other contexts, such as the source error. However, despite the fact that the error trait in Rust is more flexible than most other languages, it is still restricted in some ways. The error trait can only represent errors with a single source. If you've ever written a parser, you might have run into this one, where you have multiple syntax errors at once. The error trait can only represent a chain of errors as a singly linked list, and so it doesn't work well for domains like parsers, where error causes end up looking more like a tree. In addition, you can only access 3 forms of context via the error trait: the error message, the source, and the backtrace. We can't return types like span trace or location without using hacks based on downcast to work around the error trait. This prevents us from having things like error return traces. Now, I dream of a Rust where we can access things like the location an error was constructed, HTTP status codes, custom report sections, and more. If we could access these generic forms of context in error reporters, we could implement error return traces generically and much more. Now, I do have plans for how we can fix these problems though, so in the future, this may no longer be an issue. Okay, so I think y'all have a vague idea of what an error reporter is now, so let's dig into an example on how to use one by recreating the custom section example from the beginning of the talk. So we're going to create a customized version of the command output function with a nicer to use interface. Instead of returning an output type with the stood error and stood out as vex of bytes and exit status, let's just return a string for stood out if the command succeeds, and return an error report if the command fails. So we start by implementing a trait. We have to do this because we can't implement methods on foreign types. Then we're going to implement this trait for stood process command. And the first thing we're going to do is call the original output function. Then we're going to convert the standard output to a string. And if the output was a success, we are going to return that string. Otherwise, we're going to return an error indicating what went wrong. So let's run this and see what happens. Error, command exited unsuccessfully. Cool, we got our error report, but also not very helpful. I didn't even show you the main function or tell you what command I was running. So let's figure that out next. With an added color error, and they all just work with any types that implement display. So let's see how this changes things. Error, command exited unsuccessfully, command get cat. Okay, so we can see why the command failed. Cat isn't a real get command. I wish it was, but it's not. Now, this error isn't very descriptive. Sure, it describes what went wrong, but is far too generic. So let's go ahead and find a new error message with a more descriptive, or let's just go ahead and define a new error with a more descriptive error message to wrap our source error. So here's our main function where we call color error install, which just sets up our panic and our error hooks. And then we create a command to run getCat and use our output2 function to run it. To wrap the error this returns, we're going to call this wrap error function, which is provided by error. This function takes a result and an argument that implements the display trait. And if the result is the error variant, it creates a new error using the arg as the error message and the old error as the source. And it then returns this new error instead of the original one as an error report. So let's go ahead and run this, and we can see error. The cat could not be got because the command exited unsuccessfully and the command was get cat. Cool. This is pretty helpful. It's not quite there yet. We're still missing the std error output that the original example had. So let's go ahead and add that finally. So we're going to convert std error to a string, just like we did with std out. And here we're going to shove both std out and std error as sections into the final error report. Let's go ahead and see what we get. Error, cat cannot got, command exit unsuccessfully, commands get cat, and cat isn't a get command. Here's the suggestions for what we could run instead. Perfect. We finally have an error report including all the information we need. With it, we can pinpoint what went wrong, why it went wrong, and as an added bonus, how we can fix it. So hopefully this example makes it a bit more clear how beneficial just a little context can be for error reports, and help you understand why I think error reporting is such an important concept. And this is just a small example of what error can do. This is just what I've configured the hooks for color error to support. You can do much more if you take the time to write your own hooks. Though I don't have the time to go into details on how to customize error as part of this talk, so if you're interested in learning how to customize error, please check out my blog. Okay, so before we go on, I've got some tips related to error reporters that I think are useful to know. So first of all, error reporters almost always implement from E for all error types. Now, this is because error reporters exist to generically format any error, and they're built on the error trait. So it makes sense that we'd want an interface to create one from any error that implements the error trait. But as a consequence of this, error reporters cannot implement the error trait themselves. This is true for all types that implement from E for all errors, including anyhow error, error report, and box dyn error. Implementing both of these traits ends up violating the overlap rule, in that there would be two from implements to choose from when converting a reporter to itself. So thanks to the fact that they can't implement the error trait, they also don't compose very well with other errors. This is just one of the many reasons reporters aren't great to use in library APIs, because your users will have to jump through extra hoops to use them as sources for other errors, and they might not understand why. So by now, you should know all the tools built into the language, how they fit into the various pieces of error handling, and have an understanding of how they can be combined to write error reports. So finally, I'd like to take a look at the ecosystem at large to see what open source libraries we can use to help us with our 5 parts of error handling. So quick reminder, here's our breakdown. Now I'm going to introduce these libraries by how they fit into the error handling breakdown. Not every part will have a library to help, and some will be disproportionately represented. So I'd first like to start with this error for defining errors. This error is an error derive macro, and it exists to reduce boilerplate by implementing commonly used traits for you, such as error and display and from. To use it, we start by adding the macro's identifier to our derive attribute. Next, we can implement display with this error via error attributes. We can have a simple attribute, which contains only a string literal. We can also include variables in our error messages with this error's custom format syntax for both unnamed and named members. This error can also handle implementing our source and backtrace functions for us. Any member with the name source or backtrace will automatically be returned from the appropriate function, or this can also be done explicitly using the source attribute. This error can also implement from with the from attribute, and note that this also implies the source attribute when used. This isn't all this error can do, so please check out the documentation for more details. Next, I'd like to introduce displayDoc. DisplayDoc is a fork of this error that provides only the display derived portion of this error, but uses doc comments instead of custom attributes to input the format strings. I find this is great for simple error types, and that often error messages make for great documentation. Now I'd like to move on to snafu. Snafu is another error derived macro, much like this error. We use it the same way. We add the macro to our derive attribute, and we use some custom attributes to implement display. The main difference is that snafu also has a special helper function called context to further reduce boilerplate when capturing context for error messages. The context function takes a result and a context selector struct, which is auto-generated by the derive macro. You may notice that the source member is missing here. This is because the context function implicitly passes along contexts like the source and the backtrace, making it so you only have to capture additional context that is unique to your error variant. It then internally creates the correct wrapping error variant from your enum, and you can think of this as syntax sugar for map error. Anyhow and error also have helpers for defining new errors. However, these functions don't actually help you define new error types. Instead, they use their own private types to create the new errors, and then immediately convert those errors to their error reporting types. This is useful when you want to create an error exclusively to report them, a common need when writing applications. Though these crates do also provide some helpers for then later reacting to these ad hoc error types. Now, before we continue, there are some things I'd like to share that I think are useful to know when defining errors. First, with API stability, there's an easy pitfall to run into as a library author. If you just create a public enum for your error type, adding a new variant or even a new member to an existing variant is a breaking change and will make you implement your major version. This can be avoided simply by adding non-exhaustive to error enums where you think you may wish to add new variants in the future, or to specific variants where you think you may wish to add new members in the future. I think it's also important to consider stack size when handling errors. With the result, the size of your return type is the larger of the two variants. If your error types are large, all functions returning your errors will require more stack space, and this can negatively impact your performance of your program, even when no errors are encountered. The solution here is to allocate your errors on the heap when they're too large, either with a box or a reporting type like error anyhow, which is designed to occupy as little stack space as possible. However, when boxing your errors, remember to use the original error type, not dyn error. The box still implements the error trait. Okay, enough of the tips. Let's move on to propagation and gathering context, starting with Feller. Feller is a library that adds support for throwing functions to Rust through procedural macros. Functions annotated with throws return a result where the OK type is the apparent return type of the function, and the error type is the type listed in the throws attribute. Feller then does implicit OK wrapping for return types and provides a throws macro for returning errors. If you're missing throws syntax in Rust, this is the library for you. Next, for gathering context, I'd like to introduce tracing error. Tracing error is a tracing instrumentation library that exposes the span trace type. This library also has some cool helpers for wrapping errors with span traces and then later extracting them through dyn error trait objects, working around the restrictions of the error trait. Here we use incurrent span to wrap an error with our instrumented error type. Then below that, we convert that error immediately to a trait object and then extract the span trace from that error using some clever hacks. Another useful library for gathering context is extract error. Extract error is an abstraction of the helpers written in tracing error for span traces. Instead, extract error exposes a bundle type for bundling arbitrary types with errors, which can then be extracted later through dyn error trait objects. Here is an example of bundled being used to bundle a backtrace -rs backtrace with an error instead of a stood backtrace, emulating the backtrace function on the error trait in a way that works on stable today. Next, for matching and reacting, I mentioned this earlier, but anyhow and error also have some helpers for handling their own ad hoc created errors. Errors created with the error macro or with wrap error can be downcast back to the original type used to create the error message. Here you can see a type that just implements display, which we use to construct a wrapping error type as the error message. And then we can later downcast through the report, and you specifically have to do it through the report. You can't get a reference to the internal error, but we can downcast that report back to the message type that was used when creating that wrapping error. Now, for discarding errors, I don't know of any open source libraries that help, but if you do know of any, please let me know. For reporting though, you're already familiar with anyhow and error, given that they're the stars of this talk. These libraries expose error reporters that, as far as I can tell, are strictly superior versions of box dyn error. For customizing these reporters though, there are a couple of hook libraries I've written. Color error, you're already familiar with. Stable error provides identical features to the default error hook provided in error, but using backtrace -rs backtrace instead of the standard libraries backtrace, so it works on stable. Jane error is just a re-export of color error, but I think it's worth mentioning just for the fun, given that it's the reason I named my library error. And color anyhow isn't usable yet, but the PR to add the error reporting hooks to Anyhow has already been written and looks likely to merge as soon as I've gathered enough evidence to prove the design. So please look forward to using that in the future if you're already using Anyhow. So that's it. That's everything I wanted to tell you. But before we go, I'd like to try applying this breakdown of error handling idea to a question I see all the time in the Rust community. What library do I use when writing errors? The common answer to this question that you'll see time and again is to use Anyhow if you're writing an application and use this error for libraries. Now, I agree that this is usually correct, but it's not universally true. And we can come up with a better rule of thumb if we ask ourselves, what kinds of error handling do we need for libraries versus applications? Now, for libraries, we don't generally know how our users will handle our errors. They could report, react, rapid propagate them, or discard them. So we need error types that are maximally flexible. This means we need to implement the error traits so they can compose with other errors and be reported. And we want our errors to be an enum so they can be reacted to easily. We also want our API to be stable, so we should use non-exhaustive so we can add new variants in the future. All of this pushes us to use error-defining libraries like derive macros, or to just implement the associated traits by hand. For applications, on the other hand, we know which errors we're going to handle versus report, and we usually handle errors close to where they're returned. We will need to create new errors, but usually this is only for errors that we wish to report. And when we need to be able to report arbitrary errors because applications usually work with errors from many sources. All of this pushes us to use error reporting libraries like error and Anyhow. And that's it, for real this time. That's the entire talk. Thank you.
I'm a musicist and I run a program called Music Together Beaverton. And I'm here in the Portland, Oregon area. And today we're going to do some music together. Okay. So if your kids are nearby, go grab them. Now's the time that you can have them with you. And we're going to need a laundry basket today. So if you have a laundry basket nearby, grab that. We're going to be using a sock, so a fun sock of some sort, and a stuffed animal. If you have a stuffed animal nearby, go grab that. And we're going to have some music time for the next little bit. Okay. So glad to see you too. Hello to the armadillo. So glad to see you. Hello, everybody. We're so glad to see you. All right, you have your stuffed animal. If you want quickly to sing hello to the stuffed animal. So glad to see you. I brought my friend Jack today. This is Jack. Do you have your friend Jack too? Can you put Jack in a box? Like this. Okay. Jack in the box, still as a mouse, deep down inside his little dark house. Jack in the box, resting so still. Will you come out? Yes, I will. Hey, Jack. Did your Jack come out of the box too? Let's put him right back in. Ready? Jack in the box, still as a mouse, deep down inside his little dark house. Jack in the box, resting so still. Will you come out? Yes, I will. Okay, So grab that sock. Did you get a sock from earlier? We're gonna put Jack in a sock. Okay, here's Jack. Let's put him in. Are you ready? Jack in the sock, still as a mouse, deep down inside his little dark house. Jack in the sock, resting so still. Will you come out? Yes, I will. Fine, let's do it one more time, okay? Put that sock on, Jack. Here we go. Jack in the box, still as a mouse, deep down inside his little dark house. Jack in the sock, resting so still. Let's ask him, will you come out? Yes, I will. So you can make music out of anything, really, in your house. And a sock is one of them. A laundry basket is another one of them. So now you are going to become Jack. I'm going to become Jack too, okay? We're going to put Jack in a box. Do you have him ready? Jack in the box, still as a mouse, deep down inside his little dark house. Jack in the box, resting so still. Will you come out? Yes, I will. Can we try it one more time? Okay, put yourself back in the box, because we are now Jack. Jack in the box, still as a mouse, deep down inside his little dark house. Jack in the box, resting so still. Will you come out? Yes, I will. Now, parents, grown-ups, I'm sure you know that laundry baskets can be used for all sorts of things, musical and non-musical things at your house. So that may be getting a lot of use in the coming days and weeks. So get your little one on your lap. We're going to go for a ride in the car, okay? I'm going to take one of my friends and take him for a ride in the car too, okay? That sounds like a good note. Okay. Do you have them on your lap? Okay. So the first thing we do when we get in our cars is we buckle our seatbelts. Okay. My seatbelt looks like this. Click. Okay. Your kids' seatbelt might look like this. Click, 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 click. Okay. Are we all ready? Get your keys or your button, however you turn on your car. Okay. Vroom. Zoom, zoom, right in the car. Here we go, here we go, here we go, here we go. Zoom, zoom, right in the car. We're going out today. Vroom, vroom, driving in the car. Here we go, here we go, here we go, here we go. Vroom, vroom, driving in the car. We're going out today. Turn, turn, turn in the car. Hold on, hold on, hold on. Turn, turn, turning in the car. You better hold on today. Whoa, turn, turn, turning in the car. Hold on, hold on, hold on. Turn, turn, turning in the car. You better hold on today. Screech, stopping in the car. Watch out, watch out, watch out, watch out. Screech, stopping in the car. You better watch out today. Screech, stopping in the car. Watch out, watch out, watch out, watch out. Screech, stopping in the car. You better watch out today. A beep, beep, a beep, 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 a beep, 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 a beep, 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 a beep, 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 beep. Honk, 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 honk. What else do we like to do in the car? I like to sing in the car. Okay, should we sing in the car? Sing, sing, singing in the car. La, 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 la. Sing, sing, singing in the car. La, 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 la. What else do you like to do in the car? Eat, take a nap. Let's do eating, okay? Here we go. Eat, eat, eating in the car. Yum, 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 yum. Eat, eat, eating in the car. Yum, 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 yum. Oh, sleep too ready. Sleep, sleep, sleeping in the car. Ah, sleep, sleep, sleeping in the car. We're going home today. Wake up, beep, 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 beep. Wake up, wake up. Ah. Thanks for going for a ride in the car with me today. Okay, we're going to do one more song today for our time together. And it's one that I'm sure you all know, okay? Let me get my note. And all you need is your fingers for this one, okay? So get your fingers ready. The eensy weensy spider went up the water spout. Down came the rain and washed the spider out. Out came the sun and dried up all the rain. And the eensy weensy spider went up the spout again. Now I'm going to put a little music together touch on it, okay? This is how we do it in our classes here. The eensy weensy spider went up the water spout. Down came the rain and washed the spider out. Out came the sun and dried up all the rain. And the eensy weensy spider went up the spout again. Now let's make it a different type of a spider, okay? What if we made it a great big spider, okay? What would that look like? The great big spider went up the water spout. Ready? Down came the rain and washed the great spider out. Out came the sun and dried up all the rain. And the great big spider went up the spout again. How about this one? The silly, silly spider went up the water spout. Down came the rain and washed the silly spider out. Out came the sun and dried up all the rain. And the silly, silly spider went up the spout again. The sad, sad spider went up the water spout. Ready? Down came the rain and washed the spider out. Ooh. Out came the sun and dried up all the rain. And the silly, silly spider went up the spout again. The happy, happy spider went up the water spout. La 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 la. Down came the rain and washed the spider out. Out came the sun and dried up all the rain. And the happy, happy spider went up the spout again. La 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 la. So we can use songs that we already know, right? And make them into anything that is going on in your day, anything that you want to have happen, anything that is happening, anything that you want your child to do. Music really brings us together in lots of different ways. Did you know that serotonin and oxytocin, those are two chemicals that are released in our bodies. They're like the happy chemicals. It happens when mommies nurse babies. It happens when we eat our favorite food. And it also happens when we make music. So literally making music is good for your health, okay? So keep doing that. Make music with your babies. Hold them close and dance with them. With your toddler, have a dance party with them. With your big kid, make up new words to songs that you already know, okay? And then you're releasing oxytocin into your body, okay? I'll see you next time, and we'll make music together again. Bye.
Hi everyone, Informal Systems is excited to be sponsoring this year's Rust conference. At Informal, we're big fans of Rust. We love the strength of the open source community and the strength of the type system. We're using Rust and formal verification tools to build open source, fault-tolerant distributed systems, like the Tendermint Byzantine fault-tolerant consensus engine and the inter-blockchain communication protocol. We're cooperatively owned and governed by our employees, and we have offices in Toronto, Berlin, Vienna, and Lausanne. In fact, a few other folks at Informal would love to say hello.
Hello.
Hello world.
Hi. Hi everyone.
Hello.
Hey everyone.
Hello.
Hi.
Hey everyone.
We're hiring Rust engineers to work with us at Informal Systems. If you're interested in distributed systems, formal verification, and blockchain technology, we'd love to meet you. You can learn more about us, check out our work, and contribute online at github.com/informalsystems. We hope you enjoy the conference.
Hi, I'm Harrison Backrack. I typically say I'm a software engineer during introductions, but chances are high that you're a software engineer too. So I guess I bake, but I guess everyone is baking right now. So to clarify it, I bake challah. Here's some challah before it's edible, and here's some challah while it's edible. If you haven't heard of challah, it's like that scene at the end of Tangled where all the kids get together and braid Rapunzel's hair so it's not dragging everywhere. But unlike hair, it's not gluten-free. I actually had a frame from Tangled in here, but I was worried about the stream being taken down. So that's why you have some generic stock footage. So if you're like me, you've probably gotten really passionate about programming at some point for some reason and wanted to do a side project. Cool, me too. It happens to me all the time. And things always kind of fall apart, right? First, you have an idea. A lot of us are spending a lot of time indoors all of a sudden. So what if you were to start an indoor plant collection? Except if you're like me, you forget to water these things or forget which plant needs what sort of light. And all of a sudden you go from this to this. Don't think anyone needs this kind of vibe in their home right now. So can software help? I mean, let's be real, probably not. Software can be pretty bad, but hey, maybe. You know, I've been looking to make something in my spare time. I'm primarily a front-end developer, but I've been hearing about Rust web server projects like Actix and Rocket. Maybe I can make a web app or something. Yeah. You'll be able to upload pictures of your plants over time. You'll be able to give them names. It'll tell you when they need to be watered, which soil type they need, and where to find that soil. Tons of features. Great. So you get started and work on it until 3 a.m. and you get it to the point where you can create a plant and you deploy it to Heroku and the automated tests run on push, and some time passes. And now that thing that was so much fun for an evening is a stub of a program and you've lost all interest or enthusiasm. So I feel like this is probably a familiar experience for a lot of you. It's a very familiar experience for me. So what happened? We're going to come back to that at the end of this talk, but first, let's talk a little bit about Rust. I forget how I found out about Rust, but I was intrigued as soon as I got the pitch. I really like powerful static type systems, which is funny because all of the languages I use daily are dynamically typed. Though maybe I've just been burned too many times by my own silly mistakes. Who knows? So I'd read the Rust book a few times before, off and on, but I'd never really made anything with it, partly because I didn't know how to start, and partly because I was intimidated. But eventually I saw how easy it was to make command line applications, and that got me working on my first Rust program, Root. Side note, thanks to all the people who made this section of the site about what to make with Rust. I went to the homepage for the first time about a year after initially being introduced to Rust, not knowing what to actually build, and I found this information super useful in getting up and running on my first project. Right, so this is about solo projects. So let's talk about the solo project of mine that actually worked. Root, or if you want to call it Rut, is a pretty straightforward program. Think of it like tree, but instead of directories and files, it works on data. For example, you can input some JSON that you might be using to represent a tree of some sort. Here we have a root node with the name cool, a single child node with the name beans, and a single grandchild node with the name man. But that's kind of hard to see. So root takes that JSON and converts it into a diagram like this: cool, beans, man. The reason I'm talking about root is that it took almost 2 months to get it into its current state. If you're thinking that's a long time to make a program to do that, I think you're right. I'm very much a beginner when it comes to Rust, and it's very possible that many of you could get this done in a single evening. Now, I've done small one-night projects before. I made a widget for making digital flowers to send to people. I made a dumb two-headed version of Snake with terrible controls. And while both were fun, they fall into the same issues that come up with their gardening app from earlier. I never came back to them. So after working on Root for weeks and weeks, I started asking myself, why did this project turn out differently? What was different? Well, it became a habit. For a lot of us, side projects are something that we want to do in the abstract, but have trouble doing in the moment. If you've ever come up with New Year's resolutions and almost inevitably failed those resolutions, that concept might be familiar to you. And that's probably most of you, assuming you had any. So what goes into a successful habit? Firstly, you have to do it. Of course, that's a lot easier said than done. Now, we're about to step into a big vat of psychology research, and I want to give a huge disclaimer that I'm a software engineer, not a psychologist or a mental health professional. I'm also not a doctor nor a lawyer, and it's kind of a bummer because both of those careers are much easier to explain to your parents. So, in prepping for this talk, I read this paper called Promoting Habit Formation, and in it, I found this super academic sounding quote. Intentions to act are significant precursors of initiation of behavior, but intention translation is imperfect. What the heck does that mean? Well, just because you want to do something and you know that thing that and you know that you want that thing to be done doesn't mean that you'll actually do it when the opportunity arrives. There are a lot of reasons why people abandon projects, but a major one is not feeling satisfied. Now, this may seem silly to say out loud, but how satisfied you feel by working on a project is a big factor in whether or not you'll stick with it. If building your project isn't satisfying, you might want to reflect on that for a bit. Why did you think it would be satisfying? If it was satisfying before, what changed? Not every minute is going to be super fun, of course, but if it feels really dull for a while, it may make sense to step back and consider how to address that or how to move on to something that might be more satisfying for you. One thing to note here is that you can encourage your satisfaction. You may not think about how much you improve on a skill while working on a project, but that reflection can be super uplifting and help you see value in the work that you've already done. Now, it all starts with a good goal. What do you want to do? You'll often come up with a simple goal at first when starting on a project. You might write it down or just have it in your head. But the work between you and your goal may grow. This is often how things get unsatisfying. It no longer feels like the work that you're doing is actually progressing you towards that goal, which is the thing that got you into the first place. Coming up with unrealistic goals is really easy. For example, aiming to catch all Pokemon is a ludicrous goal to start out with. Now, I feel bad for making fun of a child, but Ash Ketchum is an absolute fool. Do you know how many kinds of Pokemon there are? Almost 900. So let's say we have some realistic goal. How do we make sure we actually do the work? One common idea in habit formation is something called automaticity, which is basically the act of doing something automatically, without meaning to do it or even being aware of it. For example, for some of you, flossing your teeth is often an automatic action that you don't actively plan out or think about. Now, you probably can't write code as unconsciously as you can floss your teeth, but you can start that way. That is, you can't write a test without thinking about it, but you can sit down in front of your computer and open up your editor pretty automatically. So when should you work on your project? It's very common to pick a fixed time to start working on something. For example, I will go to the computer at 7 p.m. But fixed times aren't really how we structure a lot of our day. Instead, our day is broken up by events into periods of activity. You take a shower, you clean up the table, you finish eating dinner. The gaps between these periods are really significant and tend to stick in your mind much better. These are the times to schedule working on your project. But when those events happen, what do you do? Even when you remember to work on a project, starting can be daunting. In order to make a habit, having a plan helps a lot. The research is pretty clear here. There's one type of plan that's super helpful called implementation intentions. However, that name is a pain to say, so I'm just going to call them if-then plans. They have a form like this. If I encounter X, then I will do Y in order to reach goal Z. Let's say you want to start a habit of drinking more water. An if-then plan that might help is, if I get out of the bed in the morning, then I will fill my water bottle and put it on my desk. The idea is to get simple tasks into your routine so that the harder tasks, like remembering to drink throughout the day, get easier. For software projects, getting your environment set up, like opening up your editor and project tracker, can make starting work a lot less scary. Now, in working on your habit, there are likely going to be some struggles, whether it's difficulty in building the habit in the first place, frustration when writing code, or uncertainty on how to make important architectural decisions. You can create what are called coping plans on how to deal with these issues when they crop up. Research has found that coping plans, when applied to physical exercise, had a dramatic effect on the endurance of those habits. Of those in the study that made specific plans on when, where, and how to exercise, 2 months later, around 44% were still performing at least an hour and a half of exercise per week. However, for those who had made coping plans, 71% were still working out that much. Forming concrete plans on how to deal with these roadblocks is super valuable for success, but also for mental health. There very well may be times when working on your project where you feel really useless or stupid, but these are neither accurate nor helpful thoughts. Programming can be a really demoralizing hobby. Imposter syndrome is rife within our industry, and those feelings are often compounded for underrepresented engineers. I wasn't able to find much research on coping plans that might apply to side projects, but in my experience, these were super helpful. First, talk with people. Talking with people, engineers and non-engineers alike, can be a huge relief and put things in perspective. And of course, it's fun. I think we could all use a little bit of fun right now. Secondly, find some nice communities online. In addition to being a great place to ask questions, people working on similar things can often understand your frustrations in a deeply validating way. I've had a bunch of super great interactions on the Rust Discord, for example. That said, there are a lot of not nice communities online. I remember I asked a question on tree traversal on Stack Overflow, and the first comment was, "Stop doing this in Rust." Number 3, just step away from the computer. Oftentimes, all you need is a bit of distance from what you're working on to help clear your mind and relax you. Not only that, but I found that most of the time, I figure out a tricky problem when I'm washing dishes or about to fall asleep. Now, with all these suggestions, there's one thing that I'll advise against, and that is setting external rewards for yourself. Say, for a little extra dessert if you work a little bit longer. These have actually been shown to reduce intrinsic motivation. The risk is that the rewards can often become the goal in and of themselves, or that the rewards mean less and less over time. The rewards also tend to have less of an effect if you have a very high awareness of them, and we're talking about solo projects here, so that seems very likely. Now, there's a very common acronym SMART that is referenced a lot in articles on successful habit building and goal setting. It was initially introduced by this guy named George T. Doran, a consultant and director at the Washington Water Power Company, in an article intended for managers on how to set corporate objectives. But since its introduction, the ideas have gone through a few changes that better align with personal goal setting for individuals. While they weren't derived from academic research, they are still a very useful tool that align with many of the conclusions from various studies on habit formation. Anyway, what are SMART goals? A SMART goal is specific. It's very clear what the problem is, and if your project is intended to solve a problem. It's very clear what needs to get done or what you need to build. A SMART goal is measurable, meaning it should be clear what's required for it to be workable, or how close it is to becoming workable. Notice I didn't say done, more on that later. A SMART goal is achievable. It's something that isn't too far outside the realm of possibility. I'd love to build a laptop from scratch, for example, but for me, that's not exactly realistic. A SMART goal is relevant to you. It needs to be something that you care about, something that motivates you. It's something that's hard. It's really hard to put a lot of time into something that is not directly meaningful to you. Lastly, a SMART goal is time-bound. Now, in most invocations of SMART, this refers to a sort of due date, but that often doesn't apply to side projects. It may never be truly done. Additionally, due dates often create unnecessary stress, and this is something that should be enjoyable. Instead, I'd like to think of time-bound as referring to your engagement with the project on a day-to-day level. Limit your habitual time instead of your total time. So let's see how SMART connects to root. First, the initial goal was just to write a program that made drawing those tree diagrams from an easy-to-type input. The project expanded beyond that afterwards, of course, but the initial idea was very focused. As I went through adding features to root, I really only thought about everything one small step at a time. This meant that as I wrote more code, the progress felt really real and was directly measurable. I could literally count the number of things that I had added. So this sort of measurement elegantly translates to filing issues, creating tickets, or however you like to do task tracking. This can be as simple as a list of a piece of paper, which is what I used, or it can be as sophisticated as an integration with like GitHub issues or a Clubhouse project. Another natural way to measure progress is with semantic versioning, or whatever versioning scheme you might elect to use. Each release is a concrete indication of progress, whether it is a feature addition, a bug fix, or something else entirely. Both ticket tracking and semantic versioning serve as reminders to recognize achievements that you made along the way, which is very easy to forget, especially when the intermediate product of your project doesn't feel very impressive. When I started planning root, I kept scope small. I wasn't going to have any command line options. It would do one thing and only one thing. And even that was too hard. Starting in Rust was so difficult that I had to make an initial prototype in Ruby, my primary language. Root as a project felt very useful to me. It came out of the very real issue that communicating the specifics of tree data structures is super hard. I deal with trees a lot at work, and talking about various corner cases with specific tree structures was always super challenging. In addition to the problem domain, Root gave me the opportunity to learn about parsers as well as Rust, both of which I had been partially exposed to, but hadn't really been able to sink my teeth into. That prototype from earlier also aided the motivation on continuing with Rust, as it showed that switching to Rust dropped the execution time from 200 milliseconds to 5 milliseconds. The static type system also caught a number of bugs that would have been a real pain later on. So when working on Root, I would really only spend a few hours a night and only 2 to 3 nights a week. When I got stuck or frustrated on a problem, I would give it a solid attempt, but if that wasn't enough, I would take a break or stop on it for the day. Typically, I would continue thinking about the problem in the back of my mind, and when I came back to it, my frustration was replaced with excitement, and I would end up solving it very quickly, most of the time anyway. In addition to the smart attributes I just mentioned, I found a few other things really, really helpful. Showing what I was working on to other people was very encouraging, even when they weren't super impressed. It still made what I had made more real to me. Celebrating victories also made the work more fun. For example, I tracked downloads on Crates.io, and I still very vividly remember passing 50 downloads and being wowed that anyone else might find what I had made useful. So we're equipped to look at what happened earlier now with our gardening project. Firstly, the scope of the project just ballooned. What started as a way to track caring for plants became something much bigger. Learning Rust is also a big challenge, and creating a web application is no small feat. In addition to learning Rust, we also needed to create an authentication system. We needed to set up how to handle assets. We needed to deploy to some server. All of that takes time before we can get up and running. Working for all those hours sure was fun, but it's not sustainable. You end up exhausted the next day and associating all of that exhaustion with all the work that kept you up. Also, one thing missing from the story is anyone else. No talking with friends to bounce ideas off of, no chatting online when running into roadblocks. Working alone is certainly possible, but it's a tough path to follow. All of this is well and good, but I do need to point out a bunch of things because, well, I don't want people to yell at me. I fear being yelled at so much I even named my now abandoned ultra depressing comic series, Please Stop Yelling Online. Really? Anyway, asterisks. Firstly, don't feel like after watching this talk that you ought to do a programming side project. It's not for everyone. It's not even for me a lot of the time. That's okay. You can have other hobbies. I imagine a good deal of you write software for your job. If you don't want to bring that home, then don't. Another thing, right now we're living through a historic global pandemic that has dramatically impacted most of our lives. Not only that, but people are becoming even more aware of the very present problem of police brutality against Black people in America. As a result, you might feel demotivated to work on a side project right now. Even if you have tons and tons of free time, that's okay. Side projects are optional. Also, you might follow this advice, start a project, and abandon it. That's okay. This stuff isn't a silver bullet. No study about any of this stuff has 100% written anywhere. That doesn't say anything about you. Stuff happens. Lastly, again, please don't yell at me. I am very weak and I will be super sad. So, in conclusion, make a plan, not a schedule. Build something that you care about. Think small and be kind to yourself. I want to thank everyone that was involved in setting up RustConf. I also want to thank my parents as well as my partner, Anne-Marie. Everyone has been super helpful in getting this talk to this stage. If you want to follow me online, my website is holoscript.com. That's with a CH. And my Twitter is HarryB. So thank you.
Ever wonder why it feels like the ads online know you a little too well? It's because they do. You're being watched, but how? And more importantly, why? It's called tracking. Trackers follow you around the web, collecting information to sell to advertisers who want to target you. Trackers from over 1,000 companies live everywhere online. They embed code into your browser to remember things about you later. Some help sites remember your password or keep your shopping cart intact. But some, like cross-site trackers, invite other companies to follow you from site to site, collecting personal information. That'd be like thousands of strangers following your every move in real life. No thanks. No one should profit off your personal information without consent. Firefox blocks those cross-site tracking cookies by default. In fact, we block over 10 billion trackers every day. To see how many trackers we're blocking for you on any given day, you can check out your protection report. Take control of your privacy today at firefox.com/privacy.
Hello, everyone. Earlier today, you met my bunny named Lucy. Now I'd like you to meet her sister, Miss Leia, or Princess Leia, as we like to call her. The two of us are getting ready for the kids' content, and if you are a parent, get ready to grab your kids and put them in front of the screen in about 30 minutes right after this next session. Your kids could use a few optional things for the kids' time session. Check out Discord for the full list and maybe give it to them as a short scavenger hunt. We will also be hosting a music together session. If you would prefer not to stick around or music together after this talk, you'll head straight into your lunch break. Just be sure to return at 2 p.m. Pacific when we will be back with even more talks. If you are having lunch in front of your computer, consider starting up a Zoom room and invite a few of your fellow attendees in Discord to chat over lunch. Enjoy the next session and music together time, and we'll see you back here soon.
Hello and welcome to RustConf 2020. My name is Samuel Lim. I'm a developer and computational biologist as I perform research in computational biology, and I develop software systems to help automate and optimize it. And we'll be looking at fast and safe Rust for biology and computational biology. As a note, computational biology and bioinformatics is very broad, and the scope of biology is actually even broader. So to keep focus, we'll be looking at computational biology from the angle of RNA sequencing and RNA sequencing analysis, aka RNA-seq, and we'll see how Rust can play into that. As a crash course into RNA-seq, what in the world is RNA sequencing anyways? In one way to phrase it, RNA sequencing is one way to sequence the qualities, the presence, and the quantities of RNA in a sample, in your fragments, and in your reads, in comparison to reference data like a transcriptome. Now, these are quite a few different terms, so we'll define them incrementally. We'll start from RNA, and then we'll see why sequencing is important, and we'll talk a little bit about alignment along the way. As a working definition of RNA, you've probably heard of DNA first, and you've probably heard of it more often. It's the stuff that makes the replication of your entire genetic sequence possible. And you wouldn't be wrong to relate RNA to DNA in this sense. Both RNA and DNA are mediums for genetic information, although they do come in slightly different forms. But their purposes can be different. In biology, we have something called the central dogma, which dictates how RNA comes to be and what it can be used for. Originally, we start with the DNA in the human cell's case in the nucleus, and we read through that DNA base by base, A, C, G, T, sequence by sequence, and then we translate it from one character to the next, and then we transcribe it, meaning that we take the DNA and we take those individual bases and we find its complement in RNA. This becomes A, C, G, and U in new characters. Now this RNA then matures into what we call messenger RNA, which gets sent out to all different parts of the cell. And this is what we get as the communication source for synthesis of proteins for different factories of the cell. In general, the original source information, the genetic sequence and the sum of all DNA found in the cell and in the nucleus, is what we call a genome. And from that genome, we can find that there are many different kinds of RNA produced and used, whether it be messenger RNA, tRNA, rRNA, and so on. And they can exhibit information from the genomes, as we've stated, and we can compare them and see how similar they are by aligning them. They can serve as communication between genes and protein factories so that we can actually get from the static source of our genetic sequence to the active source of cell interaction. And we can describe the expressions of these genes based on those interactions. And we can actually define behaviors and subcellular processes by understanding how RNA works. And if RNA can describe the expressions of genes within a cell, that means the cell can have an identical genetic sequence, an identical genome, but as it's changing and as it's producing different proteins and as it's going to different factories and as it's communicating differently, the cell can display different behavior, even with the same genetics. So the collection of all this dynamic, defined and transcribed RNA in these cells is collectively what we call a transcriptome from transcription. And because it's dynamic and serves as a bridge between our DNA and our proteins, RNA can help us to investigate the differences between individual cells as single cell RNA analysis, or in groups of cells or communities, as we would see in bulk RNA. We can look at specific expressions of genes or sets of genes and interrogate them by themselves and look at how their sequences can compare. And finally, we can look at how interactions from RNA, we can actually profile different objects and different characters in the microscopic world, whether they be cells in our human body, bacteria, viruses, and fungi. And as a note, as many of you have probably been affected by COVID-19, COVID-19 is an RNA virus, which means that the virus's entire genetic sequence is contained in a capsule, and its format, its information format, is RNA. So we've looked a little bit about how RNA comes to be, why it's important, and how sequencing can play into that a little bit. But how does that relate to computing? It comes to computing where we actually need to process the information that we've gathered. RNA-seq processing is how we can quantify, compute, and analyze the data that we've taken after we've left the wet lab. And after we've done our isolation of of different samples, of different reads, and different fragments, everything from our information to more information and inferences we want to gather can go digital. And the Rust and the applications in Rust are coming soon, I promise. From this basic understanding of the mechanisms of RNA and RNA-seq, there's a simple methodology that we can take. And that's we read the information from the files and the experimental samples that we've taken and turn them into data streams that we can manipulate. We map and align these data streams to reference data where they're applicable. So we can take the information that we have, we can position them, and we can compare them, see the similarities and the differences, and categorize them. And we can finally analyze the output, depending on whether we want to quantify the categories and the expressions of different genes or different sequences. And we can send these results we have for further processing in other pipelines or other programs. Now, RNA-seq tools are a broad spread. They can be focused on many different analyses or different methods to achieve analysis. And to name a few, some of them may be worried about the quantification, the categorization, and the analysis of expression of different genes and different RNA sequences within our data stream. And each have its own uses and advantages, but most are largely disjoint in terms of their programmatic tooling. We needed something that could actually bring the exposed functionality, so the command arguments, the positional arguments, and the general command line interface of these many different tools with many different functions together into one unified surface. And I needed a language that could do that. And that's where Rust comes in. With no need for further introduction, Rust is usually used for safety in the sense of both memory safety with the Rust borrow checker and type safety within its entire type system. We look at performance at the level of systems programming, and we look at concurrency both in its primitives and in the ecosystem surrounding them. And all of these are helpful in this regard, but how would that apply to a biologist or a computational biologist in that sense? And the first thing that we can actually look at is building ergonomic abstractions and layers to this. Now, due to the fact that we had multiple tools to work with, the initial starting point of our translation was about 3,000 lines of logic, configuration, and command line parsing. And some of it was easier than other areas, and all of it was generally not trivial to translate. And projects grow in size, and as with this one, so did the size of what needed translation. What originally started as about 3,000 lines of CLI parsing with a few tools, growing from about 3 to 4 to 5 to 6 to 10 different tools, began to add more arguments and began to add more configuration. And so what originally started as about 3,000 lines of code at the beginning then became more than 10,000 lines of code to migrate over and translate and unify in the end. Thankfully, though, many of the options that we can translate at the level of Rust have both high-level structures and primitives that are generally synonymous. And when they aren't, and when we want to configure further, we have macros, which enable us. This is one example of a direct translation where we take not only basic configuration values like verbosity, and we have flags for that, and we can take subcommands and other options. And if something is not relevant to the functionality that we want to define right now, in the abstraction we want to define right now, we can skip it. So thankfully to crates like struct_up and pico args, what was collectively about 10,000 lines of mixed logic, configuration, and options ended up condensing by about 6 times, plus more for documentation. And in the end, what we got was quite a sizable difference. As you can see, to proportion, this is what would have been the size before and what would have been the size after in screenshots. But we don't just want an abstraction layer. We want to be able to interact with the tools that have already existed and the tools that have already been made around us. And for that, we need interoperability. By the end of our initial abstraction and the command line layer, the resulting project looks a little bit like Rust on top with bindings to C++ and scripts almost all the way down. And thankfully to a few crates as CMake or CXX by David Tolnay, we're able to actually build a very systematic and almost self-contained structure for interacting with our files. We can take in the files, we can parse them, and we can send them off for processing, whether it be C, C++, Python, Makefile, Perl, and other analytic languages. And we can finally destructure or serialize that data and bring it into further analysis for other pipelines. And many times we should leave the abstraction layer as it is. There is no reason to go further unless we have precedent. And sometimes that precedent is very large. To scale, there are easily 10 to the 16th to 10 to the 17th bases in some of the more popular public databases for RNA-seq and its associated data. That's more than 100 petabytes, or several 100,000 terabytes, or several 100 million gigabytes, or several 100 billion megabytes. And it's continuing to grow over time. When data can not only grow over time, but can grow orders of magnitude in size just from the process of a single step in the pipeline, performance does matter. So in a way, we can actually think about sequencing and the general process of analysis in 3 distinct steps, where we read the information, we parse the data, we map and align, and we parallelize operations. We analyze, and we export the data that we need for further analysis. As for parsing, Rust has a very strong track history of parsing, whether it comes to crates like nom, lexers like logos or pest, and so on. We can see that Rust actually has the ability to handle not only long strings and sequences, but bigger structures as well. And structured data is sometimes the thing that we most need. If sequence data were the simplest we could possibly conceive, we would have a continuous stream of fragments of bases joined together continuously. And realistically, we require more than just a continuous string. We require more information than that, and we require structure around it. Now, how does that structure look? One example would be the FASTQ format, where we take in not only the sequence information, which is crucial to our analysis, but also the identifier, which is the identification of what sequence we're looking at, the quality scores, so we know how well this is actually sequenced, or how erroneous this is actually sequenced. And we can continue to process it further. And this is not the only format that is viable for computational biology and bioinformatics in RNA sequencing. We actually have quite a few, whether it's FASTA for genome and transcriptome, FASTQ for our experimental fragments, GTF for our annotations or bed, or files that can contain the alignments that we have calculated or processed. And parsing in Rust is not just a general feat. We actually do need some specific features to biological file formats sometimes. And we can actually measure this information. Thankfully to a professor, Heng Li, at Harvard, we have been able to quantify some of these basic benchmarks for common analyses and parsing. Here we actually see the actual times it takes, where first and foremost, Rust comes in, and we can actually count the amount of sequences and the quality thereof that's contained in these FASTQ files. And if we actually take a closer look at how we can use this information, we can see that it's not that different from very simple or normal Rust code by the time it reaches the biologist. What we have is a reader and a record, and once we take in the buffered file, we can continue to loop over it and continue to print different sequence data and quality data. And in the same vein, for the fastest benchmark, another version is very similar, where we parse from our file and we continue to take in new record information until we finish all the sequence. And once we've parsed all these files, we need to do basic processing to them, which includes mapping and alignment, the basis of most bioinformatics pipelines. And not all mapping and alignment is created equally. Some are better at expression analysis, some are better at quantifying different parts of RNA, some have better accuracy, and some are very, very fast. In one example that we could find from a paper for Callisto in near-optimal RNA-seq quantification, we can actually see the variance in the level of speed, that is the performance, of different methods and different levels of analysis. And sometimes it can, on a normal machine, it can take as little as 15 minutes. And sometimes it can take several days of computation. In a more personal test, we tested with at least 64 gigabytes of RAM, sometimes 128, at least 30 million reads over multiple files, and we had enough computing power to feed a room equivalent to a lab full of ThinkPads. And in the end, the tools with builds focused on fast heuristics gave us actual reasonable answers in less than half an hour, some of them even within 10 minutes. But others, which relied purely on accuracy or purely on speed, which were made more accurate, went out of memory as we actually tried to get a proper answer out of it, even with these large computing constraints. So the commonality between these tools is that parallelism and efficiency is actually no longer optional in RNA-seq processing. It's an assumption of the field. And so in some of the rewrites of these tools, we had to defer expertise to designers of Rust systems and the community more at large. So the commonality between these different tools is actually that parallelism and efficiency with our time and our memory is no longer optional with RNA-seq processing. Most computers nowadays, even personal computers, let alone compute clusters, have more than one core. And it's a general assumption of the field in current years. So to actually work with these tools and to incrementally translate them into a language like Rust, I had to call in the experts. So we defer expertise to the designers of these Rust systems who can actually optimize and work with these systems at a very fundamental level. And the response included the standard library, actually. Standard library is cohesive and extensive to the point where we can get comics, threading, and streams together in a fashion that's actually accessible, both in its documentation and in its resolution with other parts of the Rust ecosystem within crates. And beyond that, we also had actual data parallelism libraries, such as Rayon, where we could take normally sequential data and we could place them into iterators and place them into transformations where we could parallelize the operations naturally and easily. And in the end, the data that we process, no matter how fast, no matter how much we parse, needs to go somewhere. It needs to be analyzed further. And sometimes Rust is not the only answer to a problem. There's a diverse ecosystem of languages and tools out there, whether it goes to scripting, whether it's for systems, and whether it's for pipelines. And in the end, it boils down to the fact that biologists are not software engineers. We certainly don't want to rewrite the world in Rust. And there's actually a lot out there to gain from. What kind of language do we want to work with is less of a question of what do I want to stick to, but what can I connect and what can I interoperate? And classics of bioinformatics and computational biology, especially for RNA sequencing, include C, C++, Fortran-powered systems, and other languages such as Java, Perl, and analysis in R. And newer languages are also cropping up, such as Python, Julia, Go, JavaScript, general scripting, and some languages you may have never heard of before, such as Futhark or Seek. So while there's certainly overlap between biologists and software engineers, the end goal is different. Biologists write software to best enable biology, and the tools that are existing and the tools that we can connect are the tools that we're going to use. So what biologists and scientists more generally can take away from good quality software is reusability, composability, and interoperability. And really, all three interact in a way where we can actually get stable software that doesn't need to change, that we can build upon and that we can extend, and that we can interact with at the level of different languages, such as scripting languages or systems languages. And lessons we can take away from Rust and biology in the face of both parsing, parallelization, sequencing, processing, and analysis is that there is actually a very kind and extensive ecosystem, both with the tools that Rust gives and the communities that Rust has enveloped. And this includes Cargo, where we have an actual build tool similar to pip, similar to snake-make, CMake, all brought together and cohesive in the sense that you can test, that you can make, that you can build, that you can run, that you can compile, all these different things and all these different tools and all these different crates together. And we have a crates ecosystem where if we know the Rust code compiles, we know that it will compile everywhere that Rust is. And in that sense, we can continue to build upon different crates and different tools and different libraries based on the assumption that we know it works abroad and across. And when something is not available in this ecosystem, and when something is so domain specific that we really need a tool from somewhere else, we not only have FFI, we not only have communication with the language at a fundamental level, but we have tools and we have different crates to actually abstract over this and to get a safe layer of ergonomic code that we can seamlessly transition between. So what becomes the next step for Rust and biology together? Well, the impact of Rust in the biological ecosystem is that we get a bridging at the level of languages. As we've seen before in different benchmarks and different tools and different toolkits, we have a plethora of languages at our disposal. Some of them scripting, some of them web languages, some of them systems languages. And Rust really sits at the heart of the ability to take initial information, not only at the level of simple CFFI and C bindings, but also at the level of safe abstractions to interpreters, to different compile targets, and to different information flow. And we can work with the community at large to continue to build these tools. Not only does Rust enable languages and different language tools, it enables the community to build tools around it, to reuse, to extend, and to interact with Rust and languages around Rust at an equal and bilateral level. And so we can actually act with different software in Rust, not only insofar as the software itself, but also at the level of exchange from one software engineer to another, from one scientist to another, and build another community of mentorship for both science and software, and build a larger picture. The biggest asset of the Rust programming language going forward may not just be the language itself, but also its community. And the community mentorship model is what biologists can continue to take and learn from Rust beyond the language, even as they go further. Thank you for joining into this talk. I hope you enjoyed it. I will make further information available. And if you'd like to read more both on biology, how Rust plays in, or computational biology and different methods and algorithms to work with it, feel free to contact me and feel free to look at the slides. Okay, thank you.
Hi again, guys. I'm Kayla, and I'm here to make music together with you guys, okay? So for this section of music making time, we're gonna need some blocks or some train tracks. I brought some wooden train tracks with me. Like this, we're gonna need them a little bit later. And your stuffed animals again, okay? Also, if you have different color pieces of paper, I have certain ones that fit into our song, but if you have different colors, you can grab those too, and we're gonna use those in a song, okay? Ready? Now, you might remember last time we sang hello to each other, we sang hello to the dragon. His name is actually Toothless, right? You probably know this. And the armadillo, he has a special name too. His name is Arnie, okay? So when we sing, we're gonna sing hello to those guys, okay? Hello, everybody. So glad to see you. Hello, everybody. We're so glad to see you too. Hello, to Toothless. So glad to see you. Hello, to Teddy Bear. So glad to see you too. Hello, Elephant. To Elephant. So glad to see you. Hello, to Arnie. So glad to see you too. Hello, to Mozilla. So glad to see you too. Hello to all the kids. So glad to see you. Hello to all the grown-ups. So glad to see you too. Hello, everybody. So glad to see you. Hello, everybody. We're so glad to see you. I'm glad to be with you guys today. I want to teach you another new song, okay? It's about a frog. Ribbit, ribbit, ribbit. Let's make him small, actually. Ribbit, 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 ribbit. I had a little frog. His name was Tiny Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Excuse me. Excuse me. Let's put him back here. Ribbit, 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 ribbit. I had a little frog. His name was Tiny Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Ribbit, ribbit, ribbit. One more time. I had a little frog. His name was Tiny Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Excuse me. Now, what if we made our Tim teeny, teeny, tiny Tim, okay? He'd be like this, ready? And he'd probably have a little voice like this. So make your voice really tiny. Ribbit, ribbit. I had a teeny frog. His name was Tiny Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Excuse me. Excuse me. Now, what if our Tim was great big Tim, okay? He probably would look like more like this. Ribbit, ribbit. And he'd probably have a big, deep voice like this. I had a big frog. His name was Big Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Excuse me. Excuse me. All right, let's make Tim regular size again. I had a little frog. His name was Tiny Tim. I put him in the bathtub to see if he could swim. He drank up all the water. He ate up all the soap, and then he burped last night from a bubble in his throat. Excuse me. Excuse me. He's a very polite frog, though. At least he says excuse me every time he has a hiccup or a burp, right? And that's what we need to do. All right. I have my helper over here. We're going to bring some train tracks over, okay? So maybe our friends can move around a little bit too. Yep. So if you have, these are train tracks from my house that my kids still play with. We've been playing with for years, and you can have a couple of them. You can have a whole bunch of them. I just brought like a handful from home, okay? And some trains too. I forgot that these stick together. So we're gonna sing a song about a train, okay? Here we go. This train is bound for glory. This train is bound for glory. This train is bound for glory. Children, get on board. This train is bound for glory. This train is bound for glory. This train is bound for glory. Children, get on board. This train is bound for glory. This train is bound for glory. This train is bound for glory. Children, get on board. Sing it with me. This train is bound for glory. This train is bound for glory. This train is bound for glory. Children, get on board. Choo, 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 choo. This train is, can we have the tunnel that I had over there? This train is going through a tunnel. This train is going through a tunnel. This train is going through a tunnel. Children, get on board. This train is going under a bridge. This train, here we go. It's going under a bridge. He fits. This train is going under a bridge. Children, get on board. You guys, this train is going over the bridge. This train is going over the bridge. This train is going over the bridge. You see the water right here? And he's going to land right in the water. So, again, you can use the things that you already have at home to make music together, okay? You can use a song that you already know, or you can use a new song like one of these songs that we're doing. All the songs that we're doing today actually are on what we call our Hello Everybody app, okay? We have a Music Together app. It's a free app if you want to grab that app. And most of the songs that we're doing today together are on in that welcome app, and it has a list of welcome songs that you can use. This train is one of them, and then the song that we're going to do next is also one of them, okay? Oh, this is so fun. I bet we could do this all day with the trains, huh? I love these train tracks. Ooh, I'm gonna break it up now though. Thanks, H. Can you take my trains and then clean them up while I get these ready? So remember the pieces of paper that I mentioned at the beginning? We're gonna sing a song that uses all the colors. I'm gonna do it this way. I did need a piece of gray paper, but I did not have a piece of gray paper. So I used a little gray piece of fabric that I had. Yellow, pink, white, green, okay? I think we need to scoot them back because I want you to be able to see them. Can you guys see that? Okay, thank you for letting me know. Okay, Arnie, my stuffed animals, they can play too, okay? All right. So get your basket of seashells ready right here. It's full of seashells. We need to lay them out. She sells seashells by the seashore. 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 Brown and gray and blue, yellow, pink, white, green. Brown and gray and blue, yellow, pink, white, green. Birds in the sky singing songs, flying high, wild. Get your basket back. She sells seashells by the seashore. She sells seashells by the seashore. Let's point out those colors again. Brown and gray and blue, yellow, pink, white, green. Brown and gray and blue, yellow, pink, white, green. Birds in the sky singing songs, flying high, wild. Now let's pick up all of our shells and put them back in. She sells seashells by the seashore. Get them all. She sells seashells by the seashore. Almost there. She sells seashells by the seashore. She sells seashells by the seashore. Now you could do this song with just imaginative play, right? With your seashells in your basket. Or you can make it all about the colors too, okay? Like I said, you can use whatever colors you want, or you could use these colors that are already in the song and just mix them up. So what if I were to mix them up and then sing about them, okay? Let's see. We'll try it. Pink and yellow, gray, green and blue, white, brown. Pink and yellow, gray, green, blue, white, brown. It's a brain exercise, huh? So try that at home too, okay? Now, last thing I want to tell you about is my kazoo that I made at home, okay? You can make one too. You just need a like a paper towel roll, empty paper towel roll or toilet paper roll. I put some wax paper over the top of this and sealed it with a rubber band, okay? You can even decorate yours with marker, with paper, with stickers, okay? And you can have your own instrument. So go and make one of those. We might be using it in one of our future music times together, okay? All right, for now, I will say goodbye and I'll see you later.
Welcome back, everyone. I hope you had some fantastic discussions over lunch. I'd like to take a moment to remind you about both our Discord server, where we have channels dedicated to each of the sessions, some of the sponsors, as well as a hallway track channel. Make sure you're in there to talk with your fellow Rustations. Also, make sure you are in the companion app. I posted photos of all 3 of my bunnies, whom you've now met, and I'd love to see some photos of your pets there as well. So go ahead and post them. Before we start our next session, let's take a moment to hear from some of our sponsors.
Hey Rustations, I'm Greg, co-founder at Solano. I just wanted to say how thrilled we are to be attending RustConf for our 3rd year. Back in 2018, we decided to implement a performance-oriented blockchain from the ground up in Rust. And we've had no regrets with our choice to use Rust. Now, just over 2 years later, we've completed our public launch, and our blockchain outperforms everyone in the industry by every performance metric from latency to raw transaction throughput. Now, in coming years, our blockchain is going to change the way the financial industry operates. A big reason that things played out so well is because we chose Rust. We don't lose time troubleshooting seg faults. And when our code compiles, and after we pass the borrow checker, it oftentimes just works and performs exceptionally well without any additional analysis or optimization. We just feel so grateful for everything here, the language, the developer ecosystem, and this thriving, inclusive open source community. We're a proud sponsor here today. And yes, we're hiring. Check out solana.com/careers. We're remote friendly. We work from all around the world, and we love all things Rust. Thanks everyone, and enjoy the conference.
Hi, I'm Esteban Cuber, a software engineer at Commure, and a member of the Rust compiler team. I will be talking about what Rust can do to improve its learnability beyond changing the language itself. But first, I want to address the name of the talk. I chose it late last year before our current situation, and because I'm a bit slow, I didn't realize how topical it had become until after it had been accepted and published. It will become clearer why I chose it originally later in the talk. Secondly, while I was expanding the outline of this talk into a draft, I realized that the topics I was talking about were way more general than just Rust. Because of these two things, if I were to change the title of this talk, it would be closer to, so you want to make a programming language that people use. I also want to point out that this talk will address not the how Rust does some things, but instead what and why. And finally, I want to acknowledge that I'm not a language designer and I'm not speaking in any official capacity as a member of the compiler team. With that out of the way, let's talk about migration. An experience that a lot of you may have had is moving to a new city, a new state, or a country. When going through something like that, you have to relearn how and where to do things that you were already used to doing. You will rely on one of, broadly speaking, 3 tools and strategies. First, you will have access to a map, which is a simplified graphical representation of a physical space. It lets you get your bearings, find where important places are, and help you get there. With it, you can know that the firefighter station is 450 meters away from your house as the crow flies, but it won't tell you that the sidewalk in front of it is broken, so you have to watch your step around there. Second, you will also explore, either intentionally or not, as you go about your day, and slowly create and expand a mental map of the area. You may come across a pizza place and think to yourself, it looks reasonably priced, I need to check it out. It's 2 blocks down the street next to the Roadhouse. And finally, you may check out a travel guide or talk to a neighbor or friend that already knows the city. They may let you know about things that would otherwise take you a long time to find out about, like telling you, if you go 3 blocks the other way, there is a pizza place that is more expensive, but it's the best pizza in town. Or they will let you know about things in advance that would be annoying or inconvenient to find out yourself, like, in order to take the bus, you need to already have a travel card, or you need the exact change. What they are doing is using their lived experience, extrapolate what they know about you and your lived experience, and cut to the chase to discuss the areas that are different from what you may be used to, instead of starting from scratch and explaining what a street is. The experience of learning a programming language can be very similar. You will have a map of the land in the shape of the reference documentation, which will be detailed in the language's and library's arcane behaviors. Some people like to go through the documentation from cover to cover, and only then, once they have an idea of what's available, will they venture to write their first line of code. Other people are more hands-on, particularly people that already know one or more other languages already. They may need a brief introduction and then start trying things out. Through this trial and error, they will be building a mental map of the language, identifying where their previous knowledge applies and where it diverges in the new language. When moving from a language to another that follows the same particular programming paradigm, this process can be quite smooth. When going from one paradigm to another, the process can be more arduous. For example, somebody familiar only with Pascal, moving to Java will require a slight change in their method model. Same for someone moving from Java to Haskell. Finally, some people will seek out help. This can be in the shape of a book targeted at people learning the language, in some cases aimed at people from very specific backgrounds, or through the reliance on online communities, or even hiring a teacher to teach you the language. When doing this, regardless of medium, the people on the other side will try to identify what your current level of familiarity with the subject is, what you already know, in order to minimize the time needed to get you up to speed and productive. This includes succinctly pointing out things that will work out the same to what you're already used to, and particularly pointing out where that is not the case. I will be referring to this whole category of learning approach under the word tutor. When designing a programming language, you will have a list of priorities or objectives you want to accomplish. You can't prioritize all things equally, which means that some will have a higher weight than others, and some will even restrict or preclude others. You may want to prioritize runtime and design flexibility, but this priority will almost assuredly restrict how performant your language could be. You could decide to prioritize final execution speed, but that may require you to sacrifice compilation speed or restrict how dynamic your software can easily be made at runtime. A different priority may be compilation speed, but this will certainly affect what features the language can have in order to avoid potentially exponential evaluation in the language or how ergonomic the language can be. An example from Rust could be that the smallest compilation unit is the crate and not the file like in other languages. This permits the existence of circular imports in the language. For example, splitting an IDT definition and its implementation throughout multiple files, as long as they all belong to the same crate. This is good for the ergonomics of the language to help you keep your code clean, but it means that currently Rust-C cannot compile multiple files from the same crate in parallel. This is not a strong technical restriction, mind you. There are changes that could be made to make this possible, but they are hard to implement. If the language design had gone with a more restrictive module system, it would be less ergonomic, but it would have allowed to simplify the implementation of the compiler and made it easier to make this particular part of it faster. One reason I'm very happy to see the explosion of new languages in the past couple of decades is that there is no wrong answer on what the priorities should be. And even if there were, having a swarm attack in the problem space helps everybody. We can learn from each other, see what works, what doesn't. Languages share and steal from each other all the time, and that is a great thing. Rust, for example, has very few original ideas. An always implied priority in language design is to make the language as easy to pick up as possible. Very rarely someone goes out of their way to make their product harder to use. Beyond the objectives of the language, there are different parts of what makes a language. First and most visibly, you have the chosen syntax and grammar of the language, which is what you can write, what the code looks like. A lot of conversations go on at length about syntax as if it were the most important part of any language. I strongly disagree. Cue a sync await syntax conversation in the comments. I consider parsing and syntax to be the least interesting part of any language, as it is mostly a solved problem that requires little effort in both design and implementation, modulo things like malformed code recovery. Particularly when put in contrast with the rest of the compiler's functions and the language design space. Using square brackets instead of less than, more than for generics, to give an example, has little impact on the experience of writing the language, although it can have huge implications on the compiler's implementation and error recovery. Cue Turbofish conversation in the comments. Secondly, you will also have the semantics of the syntax. How the code actually behaves when written a certain way. This is where small differences can surprise people when moving from language to language. This includes behaviors such as what happens behind the scenes when you call a method, or where in memory your data lives and how it is accessed. Finally, you have features, what you can, and almost as important, cannot do with the language. Language design is a lot of the time saying no, removing things that have been tried before that can lead people to make avoidable mistakes or that don't fit the rest of the language. If you have used Rust, you have already noticed that this is very much part of its design, from the row checker through the non-representability of null to immutability by default. When it comes down to it, features are sometimes foundational stuff common to all or most languages, like being able to bind a local variable or while loops, or formalizing existing patterns into the language, like message passing or first-class functions. Regardless, anyone learning your new language and in our case Rust, will have to internalize rules from those three buckets. If they come tabula rasa, you can ignore prior art and do anything you think will be best for them. But in reality, a lot of people will be coming from other already existing languages, and there are so many languages out there that you can learn a lot from, or steal if you prefer, with the benefit of hindsight. For all the complaints about the breakneck change in Rust, I believe it is a boring language. All of its features, with a single exception of the borrow checker, already exist in other languages. People more eloquent than me have described this as your language strangeness budget. Try to say that 3 times in a row. The further you stray from the beaten path, the harder it will be for people to walk with you. Consider human languages, for instance. There are lots of languages across this earth of ours, and a lot of them have common roots. Somebody who speaks Spanish, for example, will have a relatively easy time learning Portuguese. There is no one-to-one mapping for every grammatical construct and rule, but due to their shared heritage, applying rules from Spanish to Portuguese will be correct more often than not. Picture instead if a Japanese person wanted to learn Norwegian. As beautiful as Norwegian may be, due to those two languages sharing no common root, this person will be having to start from scratch, which can be a much more frustrating experience. Quick aside, I have the unsubstantiated theory that experienced developers have a harder time than less experienced developers when learning Rust. They need to forget a lot of constructs that work well enough in languages they already know, because they introduce things that go against the single owner enforcement that Rust has. Whereas somebody with less experience will simultaneously accept restrictions as just the way it is, and not seek out other, more performant constructs that can be much harder to understand or implement. Rust has a curse. It has many, but this one is critical. Inefficient code is generally visible. Experienced developers hate to notice that their code is inefficient. They will recoil at seeing arc of ref cell of t, but they won't bat an eye at using Python. I know because I have the same instinct. This makes it much harder to learn Rust for experienced developers because they start with simple Rust code that will work but is slightly inefficient, and in an effort to improve it, they land squarely in parts of the language that they haven't yet developed a mental model for. To summarize, when creating a learnable language, copy from others, deviate from them only if you're convinced you have a very good reason to do so. To do otherwise is to avoid success at all costs. If you have been on the internet for as long as I have, you must have already encountered this old joke. It represents the learning curves for some popular editors people would use back in the 90s. People have done quite a few of these graphs for programming languages too. I would say that Rust probably lands somewhere between C++ and Haskell in there. But if you go looking around for the perception of Rust's learning curve, it's not very encouraging. Part of the problem is the objectives we've set ourselves. We prioritize being able to produce fast binaries for constrained environments. And anything that can be done towards ergonomics and compilation speed while not affecting that objective is already being done. Having said that, the experience of learning and using a language goes beyond the language itself. The available libraries, documentation, tooling, platform support, and the surrounding community all affect how easy it is to learn a language, and as importantly, how likely people are to stick around. Going back to my original analogy, moving to a new place is not a single decision in time. In fact, every day you reaffirm your decision to stay, even if passively. If you had infinite resources, you could improve the learnability of your language, change the slope of its learning curve by providing every single newcomer with a personalized tutor. This, needless to say, doesn't scale. You may have noticed that I included a nebulous tooling item in that prior slide. This includes things like code formatters, linters, debuggers, package managers, and IDEs. For a while last century and up to the 90s, there was this fad in our industry dubbed expert systems. It was posited that you could take a handful of really experienced people, pick their brains and encode their thinking, mental model, and decision-making process, and use that as the basis of software used by other, less experienced people. This way, you could get the benefits of an expert at a fraction of the cost to train one. We are still trying to apply this idea, only now we call it machine learning, and we use it to figure out how many teaspoons there are in a measuring cup. This idea has been used in our industry in an effort to increase productivity in the shape of IDEs, integrated development environments. These programs, with a text editor, debugger, code navigation utilities, autocompletion, and other goodies, have everything you may need when writing software. If you look at most ecosystems, IDEs are an optional, separate tool from the compiler. In Javaland, you have a plethora of options to choose from good to pretty amazing. In the Microsoft.NET ecosystem, talking about the IDE Visual Studio and the compiler as separate entities is making a distinction without a difference. The compiler is so deeply embedded in the IDE that they are one and the same. But as I said earlier, IDEs are focused on productivity, not learnability. We could create a new tool to act as a tutor, apply the idea of expert systems to the teaching of a language. But when you introduce a new tool, you have the problem of discoverability. The people that may need it the most will never find out about it. You could introduce it into an IDE, but if your ecosystem isn't self-contained, making this IDE the de facto tool that all newcomers use, you're not helping everyone you could. However, there is one mandatory tool that people are forced to use: the compiler. A lot of people have this idea that the primary function of a compiler is to take well-formed code and spit out a runnable binary. My steaming hot take is that the primary function of a compiler is to take malformed code and emit diagnostics to help the programmer turn it into well-formed code. A compiler is an error reporting tool with a code generation sidekick. I know a lot of people will give me pushback on that comment, and I am being slightly flippant, but what the user of the compiler uses it for the vast majority of the time is to get feedback on whether they have missed something. The vast majority of the code in the Rust compiler is dedicated to error reporting. Yeah, I don't have good statistics, but anyone that has contributed to RustC can attest that it certainly feels that way. Efficiency of generated code is important, but it is a well-explored space with decades of research and applied techniques. At the same time, emitting good diagnostics is hard because it requires a lot of foresight and effort. Diagnostic errors touch upon every single part of the language, from how easy it is to write typos that look like well-formed but nonsensical code, to parsing errors that are carried forward to later stages of the compiler, compounding as they go along. Unless you make it a priority, the developer experience will always be subpar. Communicating with a user to get them to that generated binary is at least as important, and in my eyes, it is more important than any other task the compiler is asked to do. And when we are emitting diagnostic errors, it's the perfect place and moment to teach people. They have made a mistake, and we can explain to them why they've made it. Think about what I'm talking about, what the possibilities we have here. Consider the kind of errors that people see. You have parse errors that are caused by malformed code that is close to correct, but that has a few typos. There is quite a bit of research on how to detect these errors automatically and identify what the user's original intent was. But if you have enough users reporting bugs and enough developers, you can get quite far with simply identifying common and problematic errors and handling them proactively in the parser. We can detect small incorrect usages. An example I always come back to is type ascription. It doesn't matter what it does, but I'll give you a short overview regardless. It is nightly only. It lets you annotate any expression with a type and uses the colon character in order to mimic let bindings with types, function argument bindings, and struct field bindings. but it has one extra characteristic. It is extremely easy to make a typo that looks like it's a naive Rust parser. It's been the bane of my existence, but I am quite happy with how well we can detect it nowadays and recover relatively well, although as you can see at the bottom there, we are still not quite there in silencing knockdown errors caused by it. Other more pervasive errors are what I call negative space boundary errors. I've taken to interpreting the negative space of a language as the area outside of a language valid its grammar. Consider a Cartesian area. Everything inside of that boundary is valid Rust. Everything outside of that boundary is all possible permutations of text. That's how the Rust grammar sees the world. But we aren't like that. We deal in shades of gray. There is code that lies right on the wrong side of that boundary that would look to a human as correct. It could be code that Rust explicitly doesn't support for some specific reason. A reasonable person may be extrapolating from rules they have already internalized, if not fully learned, or relying on rules from other languages that don't apply to Rust and land there. But the interesting thing is that we can proactively search for these cases, or at least watch people land in those places. This is not an original idea. Other types of software products conduct user research all the time, looking at how people fail to use their products. And once they have identified things reasonable people may do, we can make the compiler handle them, even when they are features that can't be included in the language. Because we can make the compiler infer intent, we can make the compiler understand the superset of the language and guide people towards a valid, supported solution, while explaining why what they have tried to do isn't supported. This can include things that are possible in other languages, but that are not possible in Rust. One problem you may envision with that approach is that a tutor needs to have some knowledge of their tutee to give them short, relevant explanations. As you can imagine, writing a compiler with that level of knowledge of the user would be difficult for a non-Google entity, and even then. But the compiler has context of what the error was. For problems off the beaten path, but with a high degree of intent, we can assume that the user knows what they are trying to accomplish. They just don't know how to do it in Rust. You need to have a lot of confidence when guiding the user, though, because misleading users can have dire consequences. For example, people with less experience may treat the compiler as an all-knowing oracle. When the oracle is wrong, they get very confused. For common problems like typos, we don't need to give too much of an explanation. Consider explaining the distinction between string slices and heap allocated strings to a newcomer. Rust has 2.5 types here to represent a concept that, depending on the language you're coming from, is either one or maybe two. A string is a contiguous piece of memory holding valid UTF-8 sequence of code points. A string slice is a fat pointer to a string and that length. A heap allocated string is almost the same, but this fat pointer is owned and the sequence is in the heap and can be reallocated. We need to explain that string slices can point to either a string or inside a heap allocated string. We have to explain the ownership mode, auto-referencing, the distinction between the heap and the stack, Unicode code points. And we haven't even mentioned null-terminated strings, oath string, path, back of U8, back of char, UTF-8, UTF-16, UTF-32, sizelessness, or lifetime yet. If you knew where the user is coming from, we could explain to a C developer that the string is like a non-null terminated string in their binary. To a C++ developer, that string slice is like a string view. And to a Java developer, that a heap allocated string is analogous to a string buffer. But we can't know where they are coming from. And you just saw how much time I needed to explain this one thing that you encounter really early on and that you're likely to encounter often after that. So instead, we give out enough information to immediately unblock you. Consider borrowing, call to owned. We provide a strong description of the problem that gives you just enough information to tell you there is a reason for the supplied code not to be accepted. In other cases, we would even weave a bunch of jargon in the description on purpose to feed you words that you can search for. This way, people are slowly learning some of the rules, sometimes by inference, and sometimes being outright told about them. An example of teaching when relevant can be when wanting to return something that implements a trait without caring about the actual underlying type. A Rust newcomer's first instinct could be to directly return it and just set the return type to the trait. Currently, doing so currently inundates the output with a bunch of different errors. Some are stylistic warnings that can be easily fixed, and we explain how to do so. Other are note down errors that we should be hiding already. They will be fixed if you fix other parts of the code. But then we get to the meat of the output. We introduce people to a potentially new feature for them, and even include a link to the documentation they can read up on. The compiler actually checks that the suggestion would actually work. It checks that the involved types could work with a new return type. With slightly different output, where impl trait wouldn't work directly, we still give a bunch of unnecessary errors, but we also explain why impl trait won't work and provide the user a bunch of alternatives. In this case, using a box trait object or an enum, along with some example code that they can directly use. All of this lets us get around the lack of support in the language for unsized return types, while unblocking the user without forcing them to visit a forum to ask for help. Of course, someone that already knows they can't return an unboxed trait directly may try to avoid the heap allocation cost and try to return a borrow, but not know or forget that the lifetime has to be related somewhere. Another example can be when people get bitten by implicit static lifetime requirements of trait objects or type parameters. In all of these cases, the compiler tries to interpret what the user is trying to accomplish and gives as short an explanation as it can to get them on their way. You can consider the objective to minimize how much people have to ask for help. I showed that my coworkers asked me for help for a given problem once, and then I run and encode the explanation in the compiler. If the compiler has been helpful to you in the past, feel free to thank my coworkers. But once you have gone this direction of providing suggestions, you can go wild. I mean, if you're already parsing a meta language, let's call it Rust++. Why not go all the way in? You can start parsing things from other languages and start translating them. You don't have to go too deep down that route, just enough to catch people that have a momentary mental lapse. I'm also convinced that this approach has an extra benefit that is incredibly important. It lets Rust remain simple. It reduces how many rules people need to keep in mind and makes the behavior of the code directly related to the code itself. There is no need for advanced behavior in the compiler that decides whether to use static or dynamic dispatch on a method call, depending on some internal heuristics. The behavior is laid bare in the code, and its performance characteristics will not change from under you due to some unrelated code changes crossing some threshold. I also believe strongly that dedicating manpower to improving the user experience of developer tools is of paramount importance. It is quite amazing to me what we have come to expect from our tools' user experience. It seems like our entire industry has had Stockholm Syndrome for so long that we don't even notice anymore. I want to ask of all of you today two things. Demand better from your tools and be mindful of your users. Thank you for your time. Stay safe.
Hey everyone, my name is Mika and my pronouns are she and her. Today, I'm going to talk about my beginnings with game development using the Amethyst game engine. When I first decided to do this talk, I had intended to share a full 2D roguelike game, but I found that my focus was in other areas of game development that I found more interesting to explore. Learning game development and Rust has always been an on and off learning endeavor of mine, and I'm excited to share some of those learnings with you today. I'm just a developer looking to talk about one of her many in-progress projects. So, when I decided to learn a new programming language, I tried to identify criteria outlining some of the things I'd like to get out of it. And since my development experience was primarily in front end web development, I wanted to try picking up another language that was considered low level or whose use cases were designed to work closer to the hardware. Another was documentation. I think most people will appreciate that in any area of software development. And being someone who likes to do independent reading and research on a topic at my own pace, it really helps to have accessible documentation to refer to. And finally, having a welcome community helps lower the barrier to learning. This was actually one of the biggest reasons that got me interested in Rust, since the community surrounding it is dedicated to making it a fun and safe place to be. So, in general, I was looking to learn a new language that presented not only a challenge, but also a history that emphasized open collaboration, and that's how I arrived at Rust. And it also helps that the language's mascot is pretty cute. So, I think like most people who are getting it started with Rust, one of the first things I did to jumpstart my learning was a combination of reading the Rust programming language and trying out some of the concepts in the Rust playground. And this was a good way for me to get a bit of a foundation before jumping into actual Rust projects. And once I felt like I had some of the basics of Rust, I decided to contribute to a few open source projects. One of the first things I did was update the standard library documentation for the string slice type. And later on, I made some contributions to the Servo web browser engine project, where I implemented a few of the missing attributes on the mouse event interface. And unfortunately, I haven't been able to contribute to other open source projects this year, but hopefully I can find some time in the future. But of course, there's just so much to know about Rust and so much to learn about it, and it's hard to keep track of what I've learned. And while I was writing this talk, it was actually already difficult to get a grasp of where I wanted to begin and eventually lead into what I've learned about game development. The amount of things to do can get pretty overwhelming. So, to help with this, I had to choose an area I was interested in, and so I began my search. And to no one's surprise, I arrived at game development. Video games have always been an important part of my life, and it felt natural to choose this area of software development to sink my teeth into. I wasn't looking to create the next big indie title, but rather just create a few projects that I could lightly work on. And some experimentation had me interested in developing a roguelike. There's a couple good tutorials on how to create your own, and while I was working on my first game, I found that I was actually more interested in creating a 2D rendered game. And I wanted to do this in Rust. And so one of the first places I went to get some information was checking out the Are We Game Yet website. I thought this was a good place to get some ideas of what I might need to build a 2D game using Rust. I was also interested in drawing some 2D sprites to the screen more so, and so I needed a library that would do most of the heavy lifting for me. And luckily, that is what game engines are for. So when looking for a game engine to use, I was more concerned about finding one that provided accessible documentation and hands-on learning and some examples to help demonstrate certain concepts. And from the Are We Game Yet website, I was able to find the Amethyst game engine. This is a screenshot of the project's landing page at amethyst.rs. As I researched the project, I found that it checked off everything I was looking for in a game development written in Rust, and the documentation for Amethyst was easily available through the project's website. I never really felt the resources they provided were scattered, which is a huge plus for me. And some of the things I found really nice is that Amethyst provides a book that entails not only how to use the engine, but also talks a little bit about ECS, which is a topic I will talk about later. It also provides links to its communities, online API reference, and also to their examples. And the book also has a section where you can build a Pong clone using Amethyst. This was a really nice hands-on project to help understand the basics of using the engine, and I also felt that it was enough to start experimenting with my own projects once I was finished with it. And finally, there were many implementation examples showing what Amethyst can do, and these examples were readily compilable and were easy to experiment with. Another nice thing about this project was that there are a few games available on its blog that showcase the game engine's features. And after doing some learning and experimentation with Rust, I decided to take what I learned and apply it to what I wanted to make in the first place, which was simply drawing 2D sprites to the screen. I wanted to break down this section into 3 parts, explaining what ECS is, showing how I went about implementing a 2D sprite animation using this framework, and finally, I'll extend on this by explaining how I went about implementing a camera follow system for the player. So, what exactly is ECS? ECS stands for Entity Component System, where an entity in your game represents a single object. An entity, often represented with a single ID, can be composed of a number of components, where a component acts like a container for data that can describe an aspect of an object. And finally, a system is a piece of logic that can operate on one or more entities in the game. ECS is a common pattern used in game development, and it makes it easy to compose objects since components can be arbitrarily added to entities. And so there's that piece of theory. When I first read about ECS, I needed some time to build a simple mental model of what it could look like in practice. And so let's shift into something that's more fun to talk about while also trying to build on this mental model. Let's talk about Animal Crossing New Horizons on the Switch. Animal Crossing is a cute laid-back game where you get to build an island society of cute anthropomorphic animals. And in this image, and the game in general, we can probably apply some of the ideas of ECS to help build our understanding of it. And there's a lot of things on the island that we can identify as objects, which are represented by entities in the world of Animal Crossing New Horizons. For example, the player character is an entity, Isabella is an entity, Timmy and Tommy are entities, and even this tree is an entity. You get the point. But it feels wrong to describe our island residents as just entities. After all, an entity is usually represented by a single ID that has a number of components associated with it. We need to be able to associate some data with them. And to keep things simple, I wanted to focus on describing data for the villagers in Animal Crossing. For some context, villagers are non-playable characters that can move to your island by either randomly moving there or finding them on another island the player is exploring. And they become residents of the little town you've created. They can also do activities similar to the player, such as fishing, gardening, and exploring. And the player can interact with these villagers and even develop friendships with them. And this being my first Animal Crossing game, I thought what made a villager special is that they added more characters to the island by, well, being cute. And though I've learned recently that each villager shares attributes that are unique to each of them that actually influence how they interact with other villagers on the island. And so here's one of the first villagers that moved to my island. Her name is Flurry, and she's a hamster. And the moment I found her while exploring another island, I just had to take her home with me. I just love how she has those cute little blue eyebrows and paws and red t-shirt, and she's just the cutest thing ever. Anyway, there are specific attributes villagers have, and I didn't list all of them here since I wanted to keep this simple. Attributes that specifically describe a villager will be its species, personality, and hobby. These attributes will be contained by what I will call a villager component. And you'll notice that the name and birthday attributes weren't included because I think these attributes should be included in a separate component, which we will talk about later. So with Amethyst, declaring components requires us to define the data being described. And in this example, we declare a villager struct, which contains information about that component's species, personality, and hobby types. And once the underlying data for the component is defined, we then have to implement the component trait for the villager. The storage type determines how the component will be stored, and in this example, the dense vector storage type, which is where elements are stored in a contiguous vector, it allows for lower memory usage, and it also for also dealing with larger components. And this diagram is to help visualize how the villager component is added to an entity in the game. In Amethyst, whenever a new component is created, it's added to a storage, responsible for storing components of a specific type. And in this diagram, we can create a number of villager components and add them to specific entities. Here, we can see that the entity 0 is associated with the villager component that describes Flurry. And this is similarly done for the other entities representing villagers. And so to do this with Amethyst, we have to get a reference to the world, which acts as a container for resources in your game. To create a new entity in the game, we first need to import the builder trait, which allows us to create the entity builder using create entity. Using the entity builder, we can add components to that entity. And in this example, we add the villager component we defined earlier. Finally, we can finish building and get the actual entity by calling build. Now, we can extend this by using the name and birthday attributes in another component. I decided to call it the resident component since it generically describes any character on the island. And in this example, I've added another entity, entity 3, meant to represent the player character. And since villagers also have names and birthdays, the resident component can also be reused and attached to entities with the villager component. So now let's move into the section on getting a simple sprite sheet animation working using Amethyst. But before we get started, I wanted to explain that a sprite sheet animation is simply taking a sprite sheet and changing what sprite image or frame is drawn to the screen in rapid succession. This gives the illusion of movement, much like how one would see with a flipbook. So the first thing we should do is describe the relevant components for the sprite sheet animation. The first is the animation component, which has attributes frames, frame duration, and index. Frames describe the number of sprite images for one animation cycle. Frame duration describes how long each image should be shown for. And index indicates where in the sprite sheet the first image of the animation is. And the second component is provided by Amethyst. It's responsible for containing data about the sprite sheet and which image from the sheet to draw to the screen. The data used to describe this is sprite sheet. And this is a reference to the sprite sheet asset. And in Amethyst, these reference to texture assets are known as handles, and sprite number is the location of the sprite image in the sprite sheet. Now, associating a component with an entity doesn't do much on its own. Our animation needs a way to manipulate what sprite image is drawn to the screen during each game cycle. And this is where implementation of an animation system comes in. In this diagram, we implement an animation system with Amethyst by having that system read or write data for different component storages during each iteration of the game loop. This example shows that the animation system being implemented will read from the time resource. Resources in Amethyst are containers of data that are not associated with an entity. And then the animation system reads from the animation component storage. And finally, the animation system will write to an entity's sprite render component. In particular, the sprite render sprite number value will be modified to tell Amethyst to draw the next image in the animation sequence to the screen. And this is what the animation system would look like using Amethyst. Implementing a system involves implementing the system trait on a struct, and this system is then executed during each iteration of the game loop. And when we define the system, Amethyst requires us to define a type called system data, which tells the system what data from the engine it should expect to get and how it should be interacting with it. Some of the system data types Amethyst provides are read storage, which gives the system an immutable reference to the entire storage containing the animation components. On the flip side, there is also the write storage data type, which gives us a mutable reference to the entire storage containing the sprite render components. And then there's the read data type, and this gives us an immutable reference to the time resource. And now the next step is to implement the system's run method. In our animation system's run method, we get all entities with an associated animation and sprite render component. This is done using join, and this allows for the joining of components for iteration over entities with specific components. And now that we have that entity, we need to find which frame to use for the sprite render's number value, depending on the game's elapsed time. And finally, we can modify the entity's sprite render to draw the new sprite image. And here's the final result of an idle animation for the wizard sprite. However, it would be much more interesting if the player could move around some sort of environment. To do this, we can design another system that is responsible for moving the player around. And for this system, our game will read from the input handler resource provided by Amethyst and will also be writing to an entity's transform component storage. The transform component storage is available through Amethyst, and it's a common component to use. This is because transform can describe an entity's position, rotation, scale, and much more. And for this game, we're really only concerned about modifying an entity's position and rotation in response to user input. And now that a system is in place for the player to move around, it might be nice to have another system that consists of a camera that tracks the player's movement within the environment. And at the time of writing this, I found that simply attaching subject tags to particular entities made implementing the system straightforward. In particular, I created a player subject component that I associated with an entity designated as the player. The camera subject component is also associated with an entity designed as the camera view. And the camera follow system would then modify the associated transform components for both the player and camera entities. And the result would then look something like this. Here, I have the same wizard sprite moving through the game's environment with a camera following their movements. And there's also a few things I wanted to say about this demo. Earlier in this talk, I mentioned how I dabbled a bit developing a simple roguelike. And one thing that I became particularly interested in is being able to generate a random tile map that would act as the environment the player could move around in. And so as another mini side project that was separate from my project that used Amethyst, I played around with developing a tile map generator that I could use potentially in my game. And the image I have here is a generated background image used in the demo. And for this small project, I used a crate called image to extract pixel data from a source sprite sheet and had it put into an image buffer. And this image buffer would then be outputted as a PNG image local to the project directory. The generated map images aren't perfect, but it was a fun way to learn and see different layouts for the game environment. And since these are only images, I'd have to still extend my game and develop some sort of collision system so that the player cannot move through tiles that are considered walls. So as you can see, I wasn't able to complete a full game yet, but being able to complete a small project like this has made the process much more enjoyable. And the biggest takeaway from my learnings was that it's okay to iterate on project ideas. do it at your own pace, and also have fun. And besides coding, another way to keep myself motivated was to document some of what I learned. I did this by writing a blog post as soon as I finished one section of my project. And not only did it help retain my knowledge over time, but it also challenged me to think about how I can communicate what I learned in a way that was helpful not only for myself, but also others. Prior to this talk, I actually wrote a blog post documenting how I implemented 2D sprite animations using Amethyst. And one of the things I really appreciated my past self for doing was taking the time to establish context and also outline her thought process throughout. And this was the most difficult part and also the most time-consuming part of writing this otherwise short blog post, because I really wanted to find a perfect balance between providing enough context while also being forthright in my content. And if anyone's interested, the link to this specific blog post is available at mtigley.dev. And I wanted to touch on writing with the intent to teach someone. Like, it's very useful, even if it's just for yourself, because it will help really ease doubts you have about your knowledge. And one way to do this is to keep a series of blog posts. And over time, you'll have created your own repository of knowledge. And who knows, maybe someone will find what you wrote about really useful. And so that's the end of my talk. I wanted to thank everyone who came to listen, and thank you everyone who made this talk possible. And hopefully anyone who is interested in either Rust or game development will be inspired to build something.
If you could fix the internet, what would you change? Things got a lot better. And then it got a bit weird.
Fake news is becoming more advanced and threatening societies around the world. Not protecting users' private information.
Mozilla Builders is an incubator funding people anywhere in the world to build companies for a new internet where people are driving positive change. Neutral is a company that measures your carbon footprint from Amazon purchases, because apparently free shipping is actually pretty costly for the planet. Emilio lets loved ones or lawyers send free letters and soon calls and videos to prisoners.
We're working on a startup that would make prison communication free.
And Onunu is for music producers to share audio files and collaborate.
We're building the future of music collaboration.
Hit them up if you've got any ideas about how to fix the internet, because if we've learned one thing from COVID-19, it's that building a better society might actually start online, because right now the internet is broken and only we can fix it.
Hello again. I'd like to introduce you to my third buddy, Mr. Noah. He's getting ready for the last bit of kids content very soon. So if you are a parent, get ready to grab your kids and put them in front of the screen in about 30 minutes right after this next session. And all they'll want to bring along for this one is their stuffed animals again. See you soon.
Hello everyone, this is the Controlling Telescope Hardware with Rust talk. We're going to be talking about telescope hardware and controlling that hardware with Rust from a desktop and interacting with our hardware and how to do that. So, who am I? I'm Ashley, pronouns are she, her. All of the code in this talk is going to be on GitHub at the project name Scopy. It's a project name that I've been using for this code. And on the right here is me in Seattle last winter taking an image of the Elephant's Trunk Nebula. And the result of that session was this image. So on the left, you have a very bright star that is blowing lots of solar radiation and whatnot at the gas cloud on the right. More dense parts of that cloud are more resistant to being pushed, so you get these globs of dust remaining behind. And if you really squint, then those globs of dust sort of look like an elephant's trunk, hence the name Elephant's Trunk Nebula. Cool. So we're going to be talking a little bit about how astronomy and astrophotography works, in particular my setup, so we have some context of some technical words and an understanding of what's going on before we jump into the code. This is a Newtonian telescope, which is what I have. Light comes in on the left, bounces off a parabolic mirror on the right. Then in the middle, or on the left here, is a secondary mirror that redirects the light up top. Then, normally, if you're looking through this telescope with your own eyes, you would have a lens here, but instead we have an image sensor that sits directly on the focal point and collects the data directly, and then we can pull the data off this camera. What that actually looks like in real life is like this. So light goes in on the left, the mirror is on the right. Then buried in the middle here is that second mirror, which redirects the light up top to that camera. Below that is the mount system. So we have two motorized mounts. The top one is called the declination axis. Then below that is the right ascension axis. And these two motors combined let us look anywhere in the sky. So what actually are right ascension declination? So the sky needs a coordinate system to be able to uniquely identify any point in the sky. We start off with using the Earth's latitude and longitude as a base. Latitude is easy. We just say that anything over the North Pole, directly over the North Pole, is 90 degrees north. Anything over the equator is 0 degrees. Anything over the South Pole is negative 90 degrees. But the equivalent of longitude is a little bit more complicated since the Earth obviously spins and we can't have our coordinate system spinning throughout the sky. So instead, the Earth uses the 0 degrees longitude is defined as being at Greenwich in the UK. Instead, we define 0 degrees of right ascension, as it's called, as being the direction of the sun at the spring equinox. It's kind of a weird definition, but that's what it is. So cool. Now we're able to uniquely identify any point in the sky and have that coordinate system. Importantly, right ascension and declination are aligned with the Earth's rotation axis. So our own motors need to be aligned with that Earth's rotation axis, which means that we need to tilt our motors equivalent to the latitude that we're currently at. So Seattle is 47 degrees north, and so I've configured my telescope here to be used at Seattle to tilt those axes to be 47 degrees. Cool. So now we're able to point our telescope anywhere in the sky and image whatever we want to. Now let's actually start getting into code. We're going to look into the motors first to see how we want to control those motors. So we do a Google search, figure out the hardware that we have, and we dig out the specification manual that our hardware provider provided. So it's a serial communication protocol. That means it's a tube that you send bytes down and you get bytes back. And it's all serial, and it's very, very simple. And it's pretty great. So in this document are things like 9600 bits a second, no parity, etc. There's various serial communication parameters. If we scroll down in this document, we have various commands that we can send to the motors. So go-to is the term in astronomy to say, hey, telescope, point to this point in the sky. And the way we do this is to send down the serial pipe the letter R, and then a right ascension encoded in hexadecimal, followed by a comma, and then the declination encoded in hexadecimal. Then in response, the hand controller sends back a hash symbol to say, hey, everything's okay, things succeeded. If we scroll down some more, retrieving data from the mount is a very similar system. We send the letter E, and we get back a right ascension declination in hexadecimal again that says where the telescope is currently pointing in the sky. So that's really useful if things are drifting or whatever. Cool. So we have a serial API, and we want to write this in Rust. And so we look online, and we find the serial port crate, which is a fantastic crate. It's super fun to use. Lets us use serial ports from Rust. So what that looks like is if we want to open our connection to the mount, we give it a path and we get back our serial port. Then we're allowed to do some configurations, for example, set that bit rate, set the parity, and here we're setting the timeout. So if the serial port doesn't respond for 3 seconds, then we kill the connection. Cool. How do we actually send bytes down this serial port? It's pretty simple. There's this write all method, and we just dump the bytes in this buffer down the pipe. Cool. Reading is a little more complicated. So the trouble is that if we want to read something, we can't just read up until we get a hash, because the data that we're getting might accidentally include a hash symbol, or rather the ASCII value of a hash in the data that we're receiving. And that's no good. And so instead, we need to get the length of the data that we expect to receive up front. And the way we do that is that we pass in a buffer, and then we use that buffer's length as the amount of data that we're expecting to read. So first, we read the buffer here. So that reads n number of bytes. Then after that, we read the hash that is at the end of every single command. The mount always responds with a hash after doing whatever to make sure that everything's okay. Cool. So connecting those all together, we go back to our PDF document and we go look up the goto command. So that is sending an R followed by the right ascension declination in hexadecimal. And here we're doing that. So we format a string with the letter R followed by the right ascension with comma and declination. So then we write that, send that to the mount, and then we read back that single hash. So remember, a read method then would read 0 bytes and then read that hash for us. So cool. Getting data from the mount is a very similar system. We send an E, and then the buffer size that we expect is 17 bytes. So that's the 8 bytes of the hexadecimal followed by comma followed by the 8 bytes of the right ascension declination. Cool. Then the rest of this method is just parsing to grab those 2 hexadecimal numbers out of that blob of bytes. Awesome. So now we're able to point the telescope wherever we want it to do. That's awesome. So the next step is to look at the camera. And so again, we look up our camera's manufacturer, look up some specification PDFs, and we stumble upon this PDF, and we start reading through it. And turns out the way that we interact with this camera is a C API. So the vendor of this camera provides this PDF as well as a C library that we link to with our Rust program. This function opens up the camera, so initializes the USB ports and everything. And then it returns a handle. And what that handle is we then later give this handle back to the API and says, oh, you meant that camera that you previously opened up. So we're able to interact with a single camera based on this handle. Then how we actually get data off of this camera is this function. So it gives us the width, height, bit depth, etc. And then the final parameter is the actual bytes data that we want to get. And so the C API fills in those bytes, and then we have our image. So fantastic. Now we want to write this in Rust. Thankfully, the vendors also provide a C header. And so what we could do is use something like bindgen to convert the C header into Rust. But instead, I've opted to just hand write all these functions because there's only a dozen or so of them. And it was easier to hand write these functions. So for example, you can see that open function that we mentioned earlier. At the top here, we're linking the library that was provided to us. And so that pulls in that code that was provided. So how do we actually use this? So C obviously expects null terminated strings. So we use the C string type to be able to pass in the string to this function. And then we get back our handle. And so then we do some error check of if that handle is null. And then we have our camera open. So that's great. So now we want to get some data off of that camera. And so we get the width, height, etc. And then we have a buffer for that C API to be able to fill in that data. Something that I found really useful when working with C libraries is I have this check function, because C libraries usually return integers as error codes. And so I have this check function that takes that integer, compares it against error code, see if it's a success or not, and then returns a Rust result. And that allows us to use that question mark operator. And that's really, really nice and ergonomic to be able to interact with these C libraries. Cool. So now we're able to point the telescope wherever we want to. We're able to get image data off of our camera. And that means we all have all that we need to create beautiful images. So this is an image that I took of the Eagle Nebula, M16. At the center, you can see 3 little newts. those are the pillars of creation, the very famous Hubble image. And I was really, really excited to say that like I actually captured this with my own amateur telescope, and I like saw a thing that Hubble saw. It was like super exciting for me. So yay. So cool. The trouble is that just interacting with the hardware isn't enough. We also have to slap a UI on top of this. So this is a pretty garbage UI. I just slapped it together. But whatever, it has all the data that I need. Unfortunately, this isn't actually a live data. This is just a simulation that I was running with my program. And that's because at midnight, Stockholm looks like this, because the sun is so like doesn't get below the horizon at all. So I can't actually do any astronomy right now to get any live data screenshots, but whatever. So the fact that we're putting a UI on top of these hardware functions is kind of problematic because, for example, downloading the data off of the camera can take a couple seconds. And we don't want to lock up our UI thread for a couple seconds because that would be really bad at user experience, even if it's just me using the program. So we want to have a thread dedicated to doing the camera work or doing the mount interaction work. And then we have our UI thread. And so I want to share some experience that I had working with hardware and what patterns worked really well when working with like blocking hardware and stuff like that. So this is a pattern that I really like. So we have our dedicated mount thread here that's just spinning in a loop. And then we have a MPSC channel that instead of sending data over, we send lambdas or delegates. And then we call that delegate with our local mount. And so that means that this mount can only be accessed by this thread. But the fact that we're sending over lambdas means that we can write really nice shim layers like this. That if we want to slew the, or go to the mount to wherever we want to, we just need to write that shim. Then the UI thread can call this method. It just sends this lambda over the MPSC channel, which doesn't block at all, and returns immediately, freeing up the UI thread to do whatever it wants. Then, when the mount thread can get around to it, then it actually does that slew operation, calls this lambda with the mount that is a thread local. And Rust guarantees that this mount will never escape that thread. And it's really, really nice to be able to have those guarantees in this Rust world. Unfortunately, the camera is a little bit more complicated, and I do have an enum instead of sending over lambdas. This is because the camera is a little bit more complicated. So here we're setting a control, and control in this sense means something like the camera's gain or the exposure or stuff like that. And it turns out that the camera hardware really doesn't like it when you set the gain in the middle of an exposure, like things crash and stuff. And I just figured this out by using the camera, being in the field, doing some testing. And I figured out that you want to cancel the camera before setting any control. So cancel the current exposure. And so now we have this method, we have to make it a little more complicated. And so now we don't use a lambda anymore, we use an enum. So cool. So now we have all this flexibility to do whatever we want. So that was some threading talk, and now I wanted to talk about some of Rust's performance, because it's really important. So if you see in this image, you can barely see the Elephant's Trunk Nebula that I was imaging here. It's a little faint, but hopefully you can see that. But this image isn't actually what's coming off the camera. What's coming off the camera looks like this. No idea if you can actually see what's going on in this image, but it's basically a black screen with a few tiny bright white dots. And the reason for this is the camera has a 16-bit depth, 12 bits actually, but it returns it in the data of 16 bits. So that means it has a very high dynamic range. And if we want to remap that to 8 bits of what our displays actually display, then we're only going to see the very, very brightest things, which in this case are tiny little dots of stars that are showing up, and we can't see the nebula at all. So that means we have no idea if the nebula is in frame or not. We have no idea how good of quality it is. So what we want to do is when we're previewing this image in the app, we save all of the raw data itself, but when we're previewing, We want to remap this data to be able to see all the interesting parts of the image and not just have a black screen with a few white dots. So we do that by computing some statistics about the image first. And so here we compute the mean and standard deviation of the image. These look like really, really simple functions. You just loop through the data, add them all up, and then computing standard deviation is really, really simple. The trouble is that these images are not small. They're 32 megabytes big. And when I implemented this in C#, it took like a couple seconds to churn through all this data. And that's a problem when you're doing things like planetary astronomy, because in planetary, your frame rate is like 10 millisecond exposure, and you want to collect as many exposures as you can. So you want to have these previews come in immediately. You want to process as quickly as you can. And so Rust absolutely blazes through these functions, and it's really a joy to be able to have these previews just snap in as soon as they're available. So cool. So what that processing actually is doing is saying, okay, so we're assuming that the brightness distribution of our image is Gaussian, which it isn't, but whatever, close enough. And so we want to say like, okay, let's make -1 sigma on this image to be black and +1 sigma to be white, and clip everything outside of it and just see the interesting data that's in the middle of this bell curve. But we also want to be able to shift it a little bit because maybe the interesting data is on like slightly high side of the bell curve or whatever. So we have these two parameters of our sigma level of how big we want our gap to be, and then an offset of saying like, hey, we want the mean to be 20% bright instead of 50% bright or something like that. So we have this hunk of math because I want to have these shifts to be a straight remap that's a linear equation that's just y = mx plus b, and that's really, really fast to do. So on the top, we convert our sigma and our mean offset to be a mx plus b equation. So we have a scale and an offset. Then at the bottom, we just do a multiply and an add, which is really, really fast. So that's really cool. So then when we want to adjust our, for example, sigma or mean location parameters to adjust our view, we don't actually have to modify the image at all. It's still in GPU memory, and we just adjust this uniform to be able to display it however we like. So that means we have real-time adjustments of saying like, oh, I want to see the bright parts of this image, or I want to see all the dark parts of this image. And it's super snappy and great. And the reason that we don't have to modify it is apparently OpenGL supports 16-bit grayscale textures, which is awesome. So we can just upload the raw data to the GPU and have that all work. So that's super fantastic. So now you have a great application that can preview all of our astronomy images and save them all and image whatever we would like to in the sky. Great. So yeah, that's my presentation. All of the code that I talked about is all on Scopy on GitHub. There's my Twitter. My email is just wildcard@capuria.com, whatever creative stuff you want to put in there. And then if you want to see more space pics that I've taken, capuria.com has all of my stuff. Thank you very much. All these links will be in Discord or YouTube, hopefully, wherever you're seeing this. So yeah, thank you.
Hi, everybody. We're back again for some music time. I'm really excited to make some music with you guys. Did you know I've been learning all day that some of these have more names, you guys, more names. So we know that this is Toothless now, right? We know that this is Arnie. Did I tell you that this is Arnie? This is Meow Meow. He's my son's stuffed cat. It's my daughter's stuffed armadillo. This is Roo. This is our teddy bear that we use in lots of our music classes. And I just spaced that we had named him Roo. So, and then this is our very special elephant from Sri Lanka, and her name is Lanka, okay? And poor Frog, his name is Frog, okay? So when we sing hello, we're gonna sing hello to all their names, okay? And Frog is gonna be Frog. Hello, everybody, so glad to see you. Hello, everybody, we're so glad to see you too. Hello, Roo, to Roo, so glad Lanka, to Lanka. So glad to see you too. Hello, meow meow, to meow meow. So glad to see you. Hello, frog to frog. So glad to see you too. Hello to all the babies. So glad to see you. Hello to all the toddlers. So glad to see you too. Hello to all the big kids. So glad to see you. Hello to all the grown-ups and Kayla. So glad to see you too. Hello, everybody. So glad to see you. Hello, everybody. We're so glad to see you. I'm really glad to see you guys today and to make music together. I want to teach you a couple more new songs. Is that okay? Today, you don't need anything else from your house, okay? Unless you want your stuffed animals, okay? Sing hello to them real fast. And we're going to use a book a little bit later on, okay? But other than that, I think we're good to go, okay? Here's our first song. Jack, be nimble, Jack, be quick. Jack, jump over the candlestick. Jack jumped high, Jack jumped low. Jack jumped low and stubbed his toe. Oh, Jack, be nimble, Jack, be quick. Jack, jump over the candlestick. Jack jumped high, Jack jumped low. Jack jumped low and stubbed his other toe. Oh, Jack, be nimble, Jack, be quick. Jack, jump over the candlestick. Jack jumped high, Jack jumped low. Jack jumped low and stubbed his knee. Oh, Jack, be nimble, Jack, be quick. Jack jumped over the candlestick. Jack jumped high, Jack jumped low. What's he gonna stub next? Jack jumped low and stubbed his toes, all of them. Oh, Jack, be nimble, Jack, be quick. Jack jumped over the candlestick. Jack jumped high, Jack jumped low. What did he stub? Jack jumped low and stubbed his ear. Oh, Jack, be nimble, Jack, be quick. Jack jumped over the candlestick. Jack jumped high, Jack jumped low. Jack jumped low and stubbed his elbow. Oh, Jack, be nimble, Jack, be quick. Jack jumped over the candlestick. Jack jumped high, Jack jumped low. Let's do one more. Jack jumped low and stubbed his nose. Oh, Jack, be nimble, Jack, be quick. Jack jumped over the candlestick. Jack jumped high and he made it. Phew. Oh, so that's another fun song that you can just keep going and going and going. Jack jumped high, Jack jumped low, and stubbed all sorts of things, okay? If you have your kazoo nearby, I know I told you that we weren't going to need it, but you can use it. If not, you can use your imaginary trumpet, okay? We're going to use a lot of instruments in this song, okay? I'm going to use my kazoo on the first verse, okay? You can use your trumpet or you can just use your voice, okay? You can sing la 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 la. Du, 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 du. All right, if you know this one, will you sing it with me? Do, 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 do. 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 Oh, when the saints go marching in. Oh, when the saints go marching in. Oh, how I want to be in that number. When the saints go marching in. Everyone get your violins out. We're going to play lots of instruments. Here's our first one. Nya, 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 nya. Nya, 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 nya. Nya, 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 nya. Nice playing. Nya, 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 nya. Nya, 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 nya. Nya, 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 yeah. How about a flute? Do 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 do. How about some drums? Bum 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 bum. What instrument should we do now? I hear guitar, piano, banjo, cello. Okay, you choose one. I think I'm gonna play my guitar, okay? Strum, 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 strum. All right, everybody, get your own instrument to play. We're gonna play them at the same time. We're gonna be a band, okay? I might change different instruments as we go, okay? So feel free to play as many or as few as you want, okay? Ready? Go. Strum, strum, strum. Strum, 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 strum. Strum, 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 strum. Strum, 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 strum. So I'm switching. La, 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 la. La, 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 la. Ding, 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 ding. Let's sing it with our voices. Oh, when the saints go marching in. Oh, when the saints go marching in. Oh, how I want to be in that number. When the saints go marching in. Yeah. Cool. Your family can become a band, okay? You can each choose your own instrument to play. If you have actual instruments at home you can play, that would be even great. I want to read you guys a book, okay? You might know this. It's an old nursery rhyme, Hey Diddle Diddle. We put in some notes to it, okay? Hey Diddle Diddle. Illustrated by Deborah Melman. There's a couple intro pages here that we need to get past. Hey diddle diddle, the cat and the fiddle, the cow jumped over the moon, yeah. The little dog laughed to see such sport, and the dish ran away with the spoon. Yeah, the dish ran away with the spoon. Yeah, the dish ran away with the spoon. Yeah, the dish ran away with the spoon. Do you guys see the dish? Oh man, he's running away. Hey diddle diddle, the cat and the fiddle, the cow jumped over the moon, yeah. The little dog laughed to see such sport, and the dish ran away with the spoon. Yeah, the dish ran away with the spoon. Yeah, the dish ran away with the spoon. What is happening? The cow keeps jumping over the moon, and the dish keeps running away with the spoon. What happens next? Hey diddle diddle, the cat and the fiddle, the cow jumped over the moon, yeah. The little dog laughed to see such sport, and the dish ran away with the spoon. Yeah, the dish ran away with the spoon. Yeah, the dish ran away with the spoon. I think the cow actually jumped over the moon on that last one. How fun. So another way to make music at home, grown-ups, is through books, okay? Not all books lend themselves to be musical, but some do, okay? If you know, if you have a book of nursery rhymes, you can put some tunes to it. You can just speak them in a rhythmic way too. And we have some of these books too at musictogether.com that lend themselves to being sung. Actually, it comes with a song download card too. So if you happen to get one of those, you can download the song as well, and you can sing with it as you read through the book. All right. Thank you all for making music together with me today. I think this is going to be our last video, okay? So we're going to sing our goodbye song that we sing in our Music Together classes. If you're interested in music together and, hey, what is this thing called Music Together? You can go to musictogether.com. You can find a class. There's classes all over the world, you guys, and you can see if there's one near you. Okay, here's our song. Goodbye, so long, farewell, my friends. Goodbye, so long, farewell. We'll see you soon again, my friends. So goodbye, so long, farewell. Goodbye to the babies, goodbye to the toddlers, goodbye, so long, farewell. Goodbye to all the big kids, goodbye to all our friends, and goodbye, so long, farewell. We'll see you soon again, and then we'll make music together again. Thanks for spending some time with me today, you guys, and we'll see you soon. Bye.
Hey, so this is macros for a more productive Rust. Just a little bit about me before we get started. My name is Jam. I use he, him pronouns. Professionally, I do security research. However, in my free time, I mostly focus on modding, general open source stuff. So, macros. Here's the simplest macro. It's composed of only a few parts. You have the declaration, which just sets what the name of the macro is. You have the pattern, which essentially handles parsing the input to the macro. So you might have different types of syntax fragments. So you might have expressions, you might have names of types, you might have identifiers. You can basically pass arbitrary Rust into it, and you can set what different things you want to match against. And so then you have the expansion, which the expansion is what the macro becomes after you call it. So as the name implies, it is what it expands into. And then you also have, here's an example of calling the macro. So in this case, just passing in a simple 3, which is a valid expression. And if we want to see what it looks like when this expands, we just basically take the expansion and we template in the variable that we're passing in. So in this case, it's just num, which is going to be prefixed by $. And so then it expands to this. If you want to expand things on your own, there's 2 really great resources for it. There's cargo expand, which is a cargo subcommand made by David Tolnay, which just allows you to see, okay, what happens when my macro expands? What does it expand into? And you also have the ability to, under the Rust playground, at the bottom of the tools section, you have the ability to expand your macros. And so highly recommend going on Rust Playground in order to play around with that. So another feature of macros is that you can have it match against something multiple times. So kind of like regex, where you have star plus and question mark to control the amount of times you match against something. It's exactly the same here in Rust. You define a capture group and then you say, okay, how many times do I want this to repeat? So you use like star if you want 0 or more. You have question mark if you want it to be once or no times. And then the last big feature of macro rules macros is that you can have multiple different patterns that you're matching against, and the different patterns can have different expansions, and so that allows you to essentially encode parsing logic in order to figure out how you actually want to handle your expansion. So in this case, it's just a simple macro which expands differently based off of whether or not you pass a 2 or a 3 into it. Simple enough. So when we put those all together, we can do a lot cooler things with macro rules macros. So for example, we have this trait called as bytes. It's a simple trait. All it does is takes whatever structure that implements as bytes, and then it converts it into a vector of bytes. So for example, if we want to implement it for U16, we might use the associated functions for converting U16s into bytes. Simple enough. But the thing is that if you have to type this in for every different integer type, it's going to be a lot of repetitive code, and it's not going to be easy to manage it after you've written it. And it's going to be harder to, not necessarily harder to read, but it's just going to be a lot to read. And anytime you have to go in and make a change, you're going to have to change all of them. But we can remove that if we use repetition from before in order to implement the trait for all of the integer types at once. And so the way we can do that is first we just wrap our example implementation in a macro. We set it to repeat. We then make it so that we have our pattern be matching against repeated comma separated type names. And then we replace every instance of U16 with our type name. And so that allows it to, it says, okay, generate this code in multiple repetitions of it for whatever given types we pass in. And so then if we call it with all of the types, it'll generate implementations for all of those types. And then we only have one implementation that we have to maintain, and it's the templated one. And so some intermediate techniques for macro rules, macros is you can use internal rules, which basically in this example, we have two macros. We have macro 1, and we have macro 2. And macro 1 calls onto macro 2, and that might be necessary because, like I said earlier, the only way to really encode parsing logic is if you have multiple patterns or rules that you are matching against in order to encode that logic. And so if we have to have multiple steps of parsing logic, then we end up having to have essentially multiple macros to handle each layer of logic. And so in this case, this actually causes a problem because if we import macro 1 into scope but not macro 2, then macro 1 tries to use macro 2 after it expands, but it's not in scope. So how do we fix this? So basically what we're going to do is we're going to collapse the two into a single macro. And so the way we do that is with internal rules. And internal rules are basically, you have a pattern that starts with at, which that's just by convention, but it's highly recommended because at isn't really used very often in Rust syntax, so it's not likely to cause any collisions with the things you're actually trying to match against. And so in this case, since our previous macro was called macro 2, we instead have a rule that matches against at macro 2. And so basically what that allows us to do is we can have macro 1 recursively call itself, but then passing at macro 2 at the start of the inputs to macro 1 in order to call the internal rule. And so another important technique is called a TT muncher. And so TT stands for token tree. And basically what's happening here is that everything in Rust is going to be split up into tokens basically in a tree format, because if you have like brackets, everything inside of the brackets is going to be a child of the bracket tokens in your token tree. And so if you match against repeated token trees, then you match against everything that gets passed into the macro. And so if you match against something and then the rest of the token trees, then you can essentially say, okay, I'm only matching against the first token, and then I can pass the rest of those token trees back into the macro. And so I can handle parsing one set of tokens at a time. So in this example, we have matching against either up or down, and each time it's followed by the rest of the token trees. And so if we actually look at what happens when we try to handle that, is we have up, up, down, down, and then it matches against that first up for the first branch of it. And then it captures the up, down, down as the rest of the token trees. And then it passes that back in to the macro. So then it's just another call of up, down, down. And then those recursive calls allow us to handle it one at a time, going down, down, and then down. And then we hit our base case, which is just when nothing gets passed in, we then just do nothing. And so after that, it expands into nothing. And then we have all of our code, and we've been able to handle it one set of tokens at a time. So we can have multiple repeating tokens, but each one has parsing logic for handling, okay, I match against up or I match against down. And so one really useful crate for when you're writing macro rules macros is called paste. And so one of the limitations of macro rules macros is that you can't create new identifiers. But what paste allows you to do to circumvent that is it allows you to concatenate different identifiers in order to create a new identifier. So in this example, it has the 4 identifiers Q, R, S, and T, and it concatenates all of those to form QRST. And so absolutely great crate. If you wanted to find this crate or other crates like it, David Tolnay, the person who actually made Paste, actually has a site that allows you to look at a lot of useful stuff related to macros. It's actually his GitHub. So proc macros, the other type of macro, different from macro rules. So proc macros, the general idea is that you're writing another Rust program, which then takes in a series of tokens, and then it returns a series of tokens. And so, for example, we have function-like macros, which are basically the same thing as macro rules macros, except they're a little bit more powerful because they're proc macros. And you can have arbitrary Rust logic for determining how you modify your stream of tokens. So in this example, it's a JSON macro from Rocket, and it allows you to essentially just straight up write JSON within your code and even use Rust expressions as values or keys within your JSON. And that's great for like if you're writing a web server and you want a quick ergonomic way to build a JSON response, a wonderful way to do it. And so then we also have attribute macros. So attributes are just those little things that go before functions or static variables or anything like that. And so what this allows us to do is essentially associate data or some action or something with the function or static or whatever itself. And so in this example from Rocket, it's the get attribute macro. And so what that allows you to do is you can mark a function as a HTTP GET handler. And so in the example, we have the path /hello/name/age. And basically what it does is it takes whatever URL path you're going to. So like it might be /hello/jam/whatever. And then it handles the name and age and actually passes it into those functions. And so that allows you to remove a lot of boilerplate that would otherwise be required for either handling the different routes or actually pulling the information out of the routes. And it makes it a little bit more robust as you don't actually have to have the error prone nature of trying to pull that information out yourself. And so lastly, we have derive macros. And essentially, if you're familiar with Rust, you're probably familiar with the concept of deriving things like clone or debug or copy. And so what derive macros allow you to do is it allows you to have your own derive handler for implementing a trait automatically. And so here's an example from Serday in which you can, and what Serday allows you to do is allows you to derive serialize and deserialize for arbitrary structs or enums. And then you can actually serialize it or deserialize it to and from whatever format supports Serday. So for example, Serday JSON is a crate for converting to and from JSON strings, and it's absolutely great. You should definitely check it out. And so proc macros, if you want to create one yourself, all you have to do is create a new library, throw proc macro equals true in your toml, and then you just have to make a function which takes in a token stream and outputs a token stream. So here's an example of how we can make a proc macro. And so what this does is this is a attribute macro, which you put it at the top of a function. And what it'll do is it'll insert a print statement at the beginning of the function so that it prints out, okay, I'm entering this function, which allows you to trace things. So basically, the way this macro works is first up, we have a line that uses syn parse macro input. And so what syn is, SYN, is it allows you to parse arbitrary Rust source from tokens. So like in this situation, it's parsing the input to our proc macro as a function. And it also handles the error handling for you. So it'll give you a pretty error if someone tries to pass in something other than a function. And so then we take the name of the function and convert it to a string. And so here's syn parse quote. And so what that allows you to do is quote is a crate which allows you to essentially pseudo quote your code and convert it to tokens. So in this situation, we have this macro parse quote, and essentially we can just write whatever code we want in there, kind of like when we're doing macro rules macros, and we can template different tokens into it. So in this case, I take the function name and I template it into my code. And then in this case, since it's parse quote instead of just quote, it then parses it into a statement in this situation. And then we insert that statement at the beginning of our function block. And then we use quote to convert the function back into tokens and return it. And that's all it takes. So, but let's see some things that show how powerful proc macros are. So here's an example called treeflection. And if you're at all familiar with C# or Java or other object-oriented languages that have the feature of reflection, essentially what it allows you to do is it allows you to, at runtime, take a look at what are the actual names of fields within like a structure or a class or whatever, and what's the layout of them. And that essentially allows you to just kind of have programming related to the layout of your struct. And so in game dev, you might use that to allow your developer console to modify arbitrary structures at runtime. And that's a very useful tool. And so what derive macros in this situation allow you to do is you can actually kind of replicate reflection, but instead of handling it all at runtime and incurring those costs, you can instead have it at compile time, because you can derive it for each of your structures that you're using. And first off, you're not paying for it for any of the structures that you don't want accessible, but also you can generate efficient code for each different type. And that allows you to essentially have it so you have compile time reflection where you're generating unique functions for each type that handle it as efficiently as possible for that specific type. And so here's another example. This is a macro I wrote called binRead. I definitely recommend you check it out if you are doing any binary parsing. But essentially the idea of it is, instead of writing a bunch of code for handling your parsing logic, instead use your struct declaration and use the ordering of your field and some metadata in attributes in order to actually encode the parsing logic, so that you don't actually have to write your parsing code. You have your parsing code generated for you. And so that allows you to have kind of declarative programming for your parsing. And I think that was a pretty successful experiment. But one cool thing you can kind of learn from this is basically when you're implementing a derive macro, what you want to do is you want to offload as much of the actual like code out of the proc macro itself and into, for example, like a trait. So in this case, I have like binRead, the trait in question, implemented for all of the like integer types and all the other primitives. and then some more helper types. And then my derive macro, all it does is it generates some code that uses the attributes involved with it in order to generate some code, but also B, to handle just kind of recursively calling the trait on the types used in the struct. And that's basically how all derived macros are going to work. And so here's one of the really coolest examples of how you can use function-like macros. And for function-like proc macros, since you can just write arbitrary tokens in there because it's inside of a separator and therefore doesn't actually have to be valid Rust, like an attribute macro, if you attach it to a function, it still has to be a valid function, but within it, you can it has to like parse properly. But with function-like macros, since all of your tokens are like in parentheses, you can essentially have arbitrary tokens and you can encode your own syntax. So like maybe something that's domain specific, like on the top left, I'm encoding some information about, okay, this is just a arbitrary language that allows you to encode moveset information for a game. So like, okay, wait 16 frames and then create a hitbox and then do this and that. But an even cooler example of using that is this crate called inline Python. And so you might think, inline Python, that doesn't make any sense. Rust has like, it doesn't care about white space. It's completely ignores it. It just parses the tokens between the white space. So how can you encode Python? Like Python is dependent on the white space. You have to have your tabbing correct and everything. But the thing is what inline Python does is it looks at your tokens. So for example, in the bottom right, we have like the 4, and then we have the print on the next line. And we can look at the line numbers of those tokens, and we can look at the column numbers of those tokens, and we can figure out, okay, there is a tab in here, and we can recreate the white space from the positions of the tokens. And this allows you to essentially write arbitrary inline languages for your specific domain. So if you want to write Python that pulls Rust variables, you can use inline Python, or you can write your own. And that's insanely powerful. And so here's an example of an attribute macro, also one I wrote. It's called Skyline Hook. And essentially what it does is it allows you to replace a function in another binary with your Rust function. So in this case, you just provide it like a program counter, and then you provide it your function, and then it allows you to replace that by doing a bunch of nonsense in the background to actually handle like the code patching and everything like that. And it even allows you to call the original function in case you actually just want to like modify some of the input variables and then defer to the original. And one great example of how someone used that is somebody made a Pokemon randomizer. And so it really just takes one like 50-line function where it just randomizes some values in some function it's overriding. And that's all it takes. And the attribute macro actually handles all of the inserting your code patching and everything like that. But can we take macros even further? So in an earlier talk, Esteban started talking a lot about Rust++, and it got me thinking, like Rust, great language. I love it. It's my favorite language, but like, it still needs a lot of features. Like if you think about it, like it can't interop with C++ at all. Like what's up with that? And like, also I don't have the ability to do inheritance. Like, is Rust not even an object-oriented programming language? Like, I don't understand. So like the conclusion I came to is Rust must be a bad language. Like, a good language like C++ has these features. Kidding, obviously. But still, this got me thinking about like, what if we actually introduce inheritance and C++ interoperability with a macro? And so I made this crate called CPP inherit. And what it allows you to do is it allows you to inherit Rust types from C++ types and even like override virtual functions. And in the background, it, calls out to GCC and it says, compile this header file and give me the dwarf information for it and show me what the vtable layout is so that I can recreate it within Rust. And it generates a bunch of code in the background for handling that all for you, so that you can inherit from C++ classes using Rust structs. And so that's all I got. Thank you for watching. It was a great time.
Hey folks, my name is Rebecca Turner. I use she, her pronouns, and I'm going to be talking about Rust for non-systems programmers. Don't worry about taking notes. All the code I'm going to be showing you, as well as these slides and a rough transcript, are available online. And I'm going to wait a little bit so people can copy down these links. So I'm a non-systems programmer. Before learning Rust, I mostly wrote Python, and now Rust is pretty much my favorite language. But if you looked at the rustlang.org website before 2019, that might not make a lot of sense to you. Here's the rustlang.org website at the end of 2018, right before they rolled out the new site. The headline emphasizes systems programming, speed, and memory safety, all things I don't directly care about that much. And here's the new website today in mid-2020. Now Rust is about empowering everyone to build reliable and efficient software, and the website focuses on reliability and productivity. But a lot of the documentation is lagged behind and still assumes that new Rust programmers already know C++ or something similar. That made it really hard for me to learn Rust. I've never really understood memory management, so a lot of the documentation was pretty inaccessible for me. I want to talk about how we can use Rust as non-systems programmers without getting too bogged down into the details of optimization and memory management. Before we start writing code, let's take a quick look at some of the things Rust makes strikingly easy. And don't worry if I go through these quickly, we'll come back to these features soon. Rust can do command line argument parsing generated from a type definition with automatic typo correction while generating tab completion scripts and man pages at compile time. Rust can give great error reports for complex errors while automatically deserializing JSON to a custom type. And Rust can output fancy test diffs with a one-line import that integrates with the default test framework. Rust can do a whole lot more too, but I don't want to just list random Rust features for 30 minutes. When I was learning Rust, a process that had 3 or 4 false starts since about 2016, I kept getting halfway through writing a program before I'd get stuck on a compiler error I couldn't figure out. So we're going to write a non-trivial Rust program together and see how we can solve a lot of common problems in a Rusty way without worrying about the finer details that I have a hard time understanding. There's a lot of Rust features and tools that aren't important to me as a Python programmer, and I'm going to pretty much skip over those entirely. We're not going to optimize anything because the totally naive program we're going to write takes 1/10 of a second to run, and almost all that time is spent waiting on some network requests. We're not going to talk about macros or a lot of the fancy type system features Rust has, or pointers. I'm not even going to say the words heap or stack or allocate. If it wouldn't matter in Python or JavaScript or Ruby, it wouldn't matter here. I have ADHD, and it varies from person to person, but one area I really struggle with is working memory, which is roughly how much information you can hold in your head at once. And as an engineer, that means that I can't hold much of the program concept in my mind while I work. It's really important that I have a powerful compiler, linters, and tests, because otherwise I have no way of knowing that the program's correct. Type annotations and autocompletion aren't optional niceties for me. It's essential that my tools tell me which operations are supported on which variables, because otherwise I have to look them up nearly every time. Rust really shines in all these areas. I work with my compiler to check my work, and it helps me feel a lot more confident that my programs do what I think they do. Before we start looking at code, I want to point out a few of the tools that make writing Rust easy and fun. We have RustDoc, which compiles doc comments written in Markdown to web pages, complete with search, links, and more. We also have MDBook for writing longer form narrative style documentation. MDBook was created to write the Rust book, the main source of Rust documentation. We have 2 very good language servers for auto-completion, definition jumping, quick fixes, and more. RLS is distributed with Rust itself, and Rust Analyzer is a community project. And we also have Cargo, a package manager and build system integrating with the crates.io package repository that handles everything from dependency resolution to building documentation, running tests, and benchmarking. Here's the generated documentation for the RAND crate, which you can find at docs.rs/rand. When we open it up, we can see the overview they wrote, and we can even search the crate's items with keyboard shortcuts. If we click on the thread RNG function, we get to this definition. If we click on that return type there, we can check out the documentation for thread RNG. We see a description, and if we scroll down a bit, we can see the traits thread RNG implements, and we'll come back to what a trait is soon. RNG core looks interesting, so let's find out about that one. We see a description at first, and then if we scroll down, we can see the required methods and their documentation. Having a uniform style and interface for documentation is really helpful when exploring the library's API and when jumping between multiple libraries. Here's a pretty simple Rust program, just to show off a bit of syntax. The use statement imports names from libraries. : is used as a path separator and namespacing operator. Next, we define a function with the fn keyword. The function named main is the entry point. We call the var function in the env module and assign the value it returns to user. Rust figures out the type for us. And var is a result, or returns a result, so we have to unwrap it, which will crash if there's an error. We'll talk about what all that means in a minute. And next we have an if statement, which has braces but no parentheses. Note that we're comparing strings with equals equals, so we have operator overloading. And then we have this print line macro. The exclamation mark at the end of the name means it's a macro, and the string literal there is actually turned into a series of formatting instructions at compile time. And the compiler checks that we have enough arguments and that they're the right type. We can run cargo build to compile the program. And then we can run it, and it does what we expect. Although if the user environment variable is empty, it might be a bit confusing. And if user contains invalid UTF-8, it'll crash the whole program. So this type that var and var returns is result, which is an enum, which means it's a type that can be one of a number of different things. It's also a generic type, so we can pick any 2 types, T and E, and use a result type, which can either be an OK variant containing a T value or an error variant containing an E value. One way we can deal with that error is by matching on it, which is a bit like an is-instance check. Here we'll just handle an error by printing a simple message. So if we have an OK value, we take that and run our logic from before. If we have an error value, we throw it away using the underscore as a placeholder or wildcard and just print that little message. So now when we run our program with invalid data, we print an error message instead of crashing. We'll talk about some other ways to handle errors as we go, but for the definitive rundown, check out Jane Ludsby's talk, Error Handling Isn't All About Errors. But this talk is about Rust value as a practical programming language, which means doing a lot more than writing hello worlds. So let's write a program in Rust and explore some of the ways the language helps us out. I have this receipt printer hooked up to my computer, and it's super fun to play with. There's no ink, so paper is incredibly cheap, and they're designed for restaurants and retail, so they're incredibly durable. I always forget to check the weather in the morning, so I want to write a program I can set to run before I wake up that tells me the weather and how it'll feel compared to the previous day. Weather APIs come and go, but right now OpenWeather is providing decent data for free, even if the default units are kelvins. Here's a simple call of their API in Python. First, we load the API key from a JSON file, then we make a request, and finally we print out the response text. When we run it, we get a minified JSON blob as output. So let's work on recreating this in Rust. Here's a start at a line-by-line conversion of that program. First, we're using the include stir macro, which actually reads a file as UTF-8 at compile time. We'll work on opening files in a bit, but this works well enough for now. Next, we're going to use the sturdy JSON crate to parse that string into a JSON value. And then we get the API key out of the object as a string. Each time we assert something about the type of a value in this object, we need to unwrap it because we might not have a value of the type we want. So we need to deal with that somehow. Note that this isn't entirely unique to Rust, though. Our Python program would also crash if API key object wasn't a JSON object, or if it didn't have a key named API key, or if the value of that key wasn't a string. But Rust makes us be explicit about all these assumptions that we're making. That's not necessarily a bad thing. It helps us figure out where errors could happen, but it is awfully verbose and painful to write like this. But we do have a better way. Here we're declaring a struct, which is roughly a class in the sense of a blob of data with named fields and methods, and then we're deriving some traits for it. So what's a trait? A trait is a set of method signatures that specify some interface. Here, the from trait lets us convert from one type to another. We can implement a trait for a type with an impl block. Note the self keyword there that indicates the impl block's type. That makes refactoring a lot easier and lets us talk about things like a function that returns the same type as the value it's called on. Rust lets us do a lot of funky things with traits, and particularly traits with generic types like these. Here's the into trait, which is from in the other direction. We can implement into u for all types t as long as u implements from of t. The implementation is pretty simple if you can wrap your head around that. We call use from method. And that's pretty magical. We only have to implement one of into or from, and we get the other trait for free. So if we have this implementation from string for open weather config, we can use the into method on the string type to convert to an open weather config object. But about that toOwned call there, what's the deal? Shouldn't a string literal already be a string without calling another method? Well, in Rust, string literals get baked into the compiled binary directly. Because that data is always sitting at a fixed location in the library, we can't change it without copying it into memory first, because if we changed it there, it would change it for everyone else using the string literal. So if we want to have a string that belongs to us, rather than one referencing some data elsewhere in the program, we have to call the toOwned method to convert it, which creates a new string object and copies the data we need into it. Back to our open weather config struct. We don't have to implement every trait by hand like we were doing with into and from. The other option is to use a derive macro, which is a function written in Rust that reads the type's definition as a syntax tree and automatically generates an impl block for us. There's usually a few requirements for deriving traits. In particular, for traits like debug, clone, and deserialize, we need all the types the struct is composed of, which here is just string, to implement the same trait. Debug lets us pretty print the struct's data, clone lets us deeply copy it, and sturdy's deserialize trait lets us deserialize it from JSON or with other sturdy libraries, XML, YAML, TOML, protobufs, and more. Here's what deserializing to a value looks like. Note that we don't need to explicitly construct our open weather config object. That, along with parsing the JSON, matching up keys to fields, and recursively constructing other deserializable values, is handled by sturdy and sturdy JSON. Now, when we run this, we get some nice pretty printed debug output by default. That's not my actual API key, by the way, don't worry. The next change I want to make is adding struct_opt, which generates a command line interface from a struct definition. Instead of declaring all our arguments as strings and pulling them out of an untyped hash map, we just declare them as struct fields, which means we get things like autocompletion for our command line options, along with bonuses like detecting that option fields aren't mandatory and vec fields can have multiple values. We get a lot of perks from struct_opt, including this great generated help message. And we even get help with typos by default. The next thing I want to do is add some error reporting so we don't have to unwrap everything and cause panics when something fails. The error crate by Jane Ledsby gives us the beautifully formatted error messages I showed off at the beginning of the talk, and has a lot of other functionality we won't explore here. Now, we can handle errors with the question mark operator, which is a pretty simple but important bit of syntax sugar. The question marks are transformed into roughly these match statements. If we have an OK value, we take that value and use it. Otherwise, we return the error value from the whole function. We just bubble up the error to the caller. It's a little bit like throwing an exception, but we don't quit an arbitrary series of functions. We only go up one layer, and the type system doesn't let us ignore it. Using the question mark operator again, we're going to use the wrap error methods from error's wrap error trait to more accurately describe what went wrong. We just write a bit about what we were doing that might have caused an error, and then that string will get displayed if the error report is printed. It's a pretty simple step, provided you do it from the start, and it makes debugging a lot easier. Here we can try to use a non-existent file or an invalid one as our config, and we can see the error messages we get. These are pretty simple on their own, but they're especially useful when we have a bunch of layers of error context to figure out what we did wrong. And unlike exceptions in a lot of languages, we don't just get an enormous unreadable stack trace by default. Now we're going to use the request library to make a simple call to the OpenWeather API. We create an HTTP client object called the get method with the endpoint URL, add some query parameters, and send the request off. We can see when we pretty print the response object, we get all the fields we might expect, headers, a status code, and so on. And we can also print the response text, which is this big minified JSON blob. We're going to deserialize that too, but first let's clean up our interface to the OpenWeather API. So let's unify our config file with the API client. Instead of passing an API key into every function call, we can keep it in the same struct that holds the request client. And because the client has a default value, we can tell Sturdy to use that instead of expecting it in our config file. Now, we can just read our config object from the same JSON file we were using before without even a constructor method. Now, to make our API a bit cleaner, let's start implementing methods. This gives us something that looks a lot like the classes we may have used in other languages. And although Rust doesn't have inheritance or subtyping, generic functions and traits can get us pretty close. An impl block lets us put methods on types. Like Python, Rust doesn't have an implicit this object you can reference. You need to write it explicitly as self. We also have angle brackets after the function to indicate that the function is generic. Here we have one generic parameter named response, and the colon indicates a trait bound, which means that response needs to be a type with an implementation of deserialize owned, which is exactly what dirag deserialize gives us. Essentially, we've copied a type parameter from the Sturdy JSON from reader function so that we can deserialize to any type we define. We can define structs for the API responses. These are pretty much copied from the OpenWeather API docs. And then we can define a helper method to make that request directly. Note that we don't need to annotate the generic types for the self.get call, although we can if we want. The compiler is smart enough to figure out what the type parameter needs to be from the return type of self.get on its own. And then after, we can use the new method in our main function to get the forecast data as a richly typed struct. One thing I want from my forecast is to tell me if today is going to be warmer or colder than yesterday. So I'll create a temp difference enum and then a helper method to get the appropriate temp difference for two floats. Here's that constructor function, which takes two floats, calculates their difference, and matches them to the correct temp difference variant. We're also adding conditional statements to the match patterns, which helps make it a bit clearer that we're determining which range the delta is in. I'm really bad at arithmetic stuff, so I want to write a few tests to make sure I got the subtraction order and everything right. First, we have this config test attribute, which means the entire test module is conditionally compiled, so our tests don't get lumped into our other builds. We have to import the functions and values from the parent module, that is the rest of the file, explicitly. And then a test is just a function annotated with the test attribute. And finally, we can write asserts with the assert and assertEq macros. We can run our tests to make sure that we've written everything correctly. And another little thing I like about Rust, the type system lets me describe and check a lot of my code before it compiles correctly, so I end up writing tests that crash and fail immediately a lot less often than I do in other languages, which is a big boost to my self-esteem. I also want to be able to state various things about a collection of temperatures, like their range and their average. So I'll have a stats struct that'll handle that computation, storing the minimum, maximum, average, and number of values. Let's implement the default trait for stats, which gives us a way to construct a default value for a type. It's like Go's concept of a zero value, but Rust doesn't require that every type implement default, because that's not always meaningful. For example, types like file handles don't have a reasonable default. We're picking infinity for the starting minimum value because every float is less than infinity, and negative infinity for max from the same reason. Note that we have associated constants for even our primitive types. In Rust, primitive types are treated just like any other type, as opposed with like Java, where we have to treat reference types and primitive types really differently. Now we can construct a stats object from an iterator of floats. We can start by initializing a mutable return value and a sum of the iterator's elements. They need to be mutable so that we can change their properties and values as we go on through this computation. Next, we take each value in the iterator and update the return value's minimum and maximum values, if applicable, as well as the element count and running total. And finally, we compute the average value and return. Then we can gather the temperatures for yesterday into a stats object. Note that because we're using lazy iterators, mapping each data point to the temperature it felt like doesn't require writing a whole new array. We just generate the data as we go, and there's no storage overhead. We can do the same thing with our forecast, making sure to limit the forecast to 24 hourly data points. And then we can get a temperature difference between the 2 days. To finish up, let's print out the data we've gathered. First, I want to print a smiley face for good weather, so I'll check if the average temperature today is between 60 and 80 degrees. Then we'll print the first line, truncating today's average temperature to 2 decimal places. And then we're going to print the rest of it. There's a bunch to break down here, so let's break it down. First, because println is a macro, we can do weird things with the syntax, like this keyword argument syntax that's only used for the printing and formatting macros. Next, we have a match statement. Rust's if, else, and match statements return a value, so we can use them inline like this for argument values. And then we're going to finish with a smiley face if today's going to be warm and nice weather, or a period otherwise. And after printing all that information out, our program is done. So building and running it, we can see what the final output looks like after I fix several issues with missing or superfluous white space. So now all we have left to do is print it out. We pipe our program's output to LP to print it. And here we go. And there's the same receipt, a little bit bigger. And before I go, let me leave you with one last piece of advice. If you're writing a Rust program and you're trying to work with references and it's just not working, clone your data. Cloning can fix a lot of annoying problems, and it's rarely a performance issue when writing scripts or command line interfaces, particularly when compared with dynamic languages. But if you end up in those circumstances, you can always ask another Rust programmer for help. Our community is full of kind and helpful people willing to share a few minutes of their time to help fix errors you don't understand. I certainly couldn't have learned Rust on my own, and as long as you're respectful of your peers, we're all glad to help. Everything I talked about is just a tiny portion of what you can do with Rust and what Rust can do for you. There's so many features and tools I wanted to talk about that I didn't have time for. Things like adding methods to foreign types, type-safe numbers, unit conversions, and more. Thanks so much for listening, and I hope you do some amazing things with Rust. I'm Rebecca Turner, and this has been Rust for Non-Systems Programmers. Have a good one.
Oh, hi there. I didn't see you. I want to tell you a story. 20 years ago, in the year 2000, a game came out for the Nintendo 64 called Hey You Pikachu. For Christmas that year, I was hoping to get the special Pikachu edition N64, but my mom told me that in a few years, I wouldn't even still be into Pokemon. Here I am 20 years later, still playing Pokemon, and today I want to share that love with you. And Mom, this talk is for you. Hey everybody, my name is Sean Griffin. Text encoding is hard, so sometimes it's spelled like that. My pronouns are they, them. Let's talk about Pokemon. The first Pokemon game was made by a small team for Japanese audiences. The game was made on a tiny budget and the programming team was only 4 people. In 1996, Pokemon Red and Green were released and sales vastly exceeded expectations. Later that year, an updated version was released in Japan with improved graphics and more polish. After it was clear that this game was far more popular than anybody expected, there was a mad rush to localize it for international audiences. 2 years later, in 1998, Pokemon Red and Blue were released to the rest of the world and would go on to be the highest grossing media franchise of all time, eclipsing even Mickey Mouse and Hello Kitty. In fact, it became so popular that even if you've never played Pokemon, I'll wager you've seen this one before. This is an actual picture of Ryan Reynolds from 1998. Okay, not really. This is Pikachu. By far the most famous Pokemon, but there was a close second. This is Missing No. Missing No is a glitch Pokemon, and you could only encounter it through a glitch. But the thing is, everybody knew about this. One of the things I find so fascinating about Missing No is just how widespread it was. In a survey I ran, 87% of people who owned the game knew about the glitch when it was relevant, and 80% of those people heard about it through word of mouth, not the internet. And there was good reason. Missing No could duplicate items. Now, this glitch had a lot of names, the Missing No glitch or the item dupe glitch. At my school, it was called the Rare Candy glitch, since most people used it to duplicate an item with that name. It made your Pokemon more powerful whenever you used it, so it was a really desirable item to duplicate. Let's take a look at how you performed the glitch first. We're going to start off in Viridian City, one of the earliest areas in the game. And we talk to this old man. He's going to ask if we're in a hurry, and we're going to tell him no. In response to that, he's going to say, oh, cool, well, why don't I show you a tutorial about how to catch Pokemon? And he's going to go into this battle and find a Weedle, and he's going to attempt to catch the Weedle. We actually are in a little bit of a hurry, so we're not going to sit through and watch this. Next, we need to fast travel to an area called Cinnabar Island. Now, this being the Generation 1 Pokemon games, the way fast travel worked is we transform into a bird and just fly away. Once we get there, we want to go onto this water. So we're going to do that by opening up the menu, and this being the Generation 1 Pokemon games, we're going to transform into a giant seal thing. I don't really know. We go up and down this coast, and eventually we'll get a wild encounter. If you played these games, you might notice this pause right here is way longer than it's supposed to be, and we're going to go into why that is a little later on. So here we see our friend Missing No. It's level 168, which is higher than you're supposed to be able to encounter in the game. The maximum level is 100. We're going to immediately run away from Missing No, open up our inventory, and when we go down to the 6th slot in our inventory, which is where I had the rare candies, we'll see that I now have Flower 2. I had 4 rare candies in my inventory before this started, and this clearly was not meant to render numbers larger than 99, so I guess the way it renders 13 is Flower, because 4 plus 128 is 132. If you've never seen this glitch before, this probably seems like an extremely random sequence of events for such a specific outcome. And it is. But let's break down each piece of this. As with most major glitches, there's no single bug that's responsible here. This happens because of a bunch of different bugs. And in most cases, you can't even really call them bugs, just properties of the code being used in unexpected ways. Now, I want to state up front, I did not work on this game, nor have I interviewed the programmers who did. I have spent a lot of time looking at disassemblies of the game, and I think we can infer a lot about what was intended from reading the code and knowing about the constraints that they worked under. But I want to make it clear that a lot of this is speculation. With that out of the way, let's start going through each of the pieces of this glitch. I'm going to go through them in the order that I think they were initially discovered. So the first thing you might be wondering is, what's up with those coast tiles? Why do we go to that spot specifically and go up and down the coast? In the Pokemon games, there's sort of a grid system that the player occupies. This is one tile that the player is standing on, and they can move one tile up, down, left, right, etc. This is that same tile when we remove the player from it. Now, even though from a gameplay point of view, this grid system occupies single tiles, the code actually sees the game a little more fine-grained than that. It sees this tile as 4 subtiles. And for the tile the player is standing on, these are the coordinates. The upper left subtile of where the player is standing is coordinate 8, 8, and the bottom right is coordinate 9, 9. Now, whenever you're moving along these tiles in the game, it's going to continuously be checking to see if you can encounter a wild Pokemon. There's 2 main ways that you could encounter Pokemon in the first generation of games. You could be surfing on water, or you could be walking through tall grass. There was also fishing, but it worked completely differently and is unrelated to this glitch, so we're just going to pretend it doesn't exist. This is what the code for that looked like. First thing we're going to do is load up the tile at 9, 9, so the bottom right subtile where the player was standing. Then we're going to check to see what kind of tile it is. We need to figure out how likely we are to run into a wild Pokemon. If the tile's grass, we're going to use the grass encounter rate for the current area. If the tile's water, we're going to use the water encounter rate for the current area. And if it's neither, then the player cannot have an encounter with the wild Pokemon here, so we just exit out. Then we actually need to compare this to a random number generator, which isn't actually random, but we're not going to get into that today, to determine if we actually get an encounter. I've left that code commented out here because it's not actually relevant to why this bug occurs. Next, they're going to load up the tile the player is standing on again, but this time they're loading the bottom left subtile. And then we're going to determine which kind of Pokemon they can encounter. So if the tile is water, we're going to select one from the list of water Pokemon for the area. Otherwise, we're going to select one from the list of grass Pokemon for the area. And so because they load up the tile the player is standing on twice, and the second time they use a different subtile, whenever we're on a tile that looks like this, where the right side is water and the left side is land, every time it's doing one of these checks, it thinks we can do an encounter because we're on water, but because the bottom left subtile is not water, it's going to load up the grass Pokemon. Now, when we look at this bug in Rust, I think this is the easiest bug that we're going to look at today to scoff at, say, this should have been caught in code review, or I wouldn't have written this. And it really does stand out in Rust. You're assigning the same variable twice, and there it's on the same screen, and it's different numbers. Like, this just sticks out like a sore thumb to me. But they didn't write this program in Rust. They wrote it in assembly. And Rust loses some of the nuance of what happened here. You wouldn't have written this code in Rust in the first place. There's absolutely no reason that you would have assigned tile a second time. But in assembly, you don't just have however many local variables you want. When you write a program in Rust, the compiler is going to determine where to store every variable that you write. It's either going to assign it to a register, sort of like a global variable that your CPU uses, or it's going to put it on the stack. Now, in the Pokemon games, they did have a stack, but it was really tiny, only 207 bytes. So they basically never used it unless it was absolutely necessary. The main place it was used was for audio playback. Now, in this bit of code that I commented out, this is where a lot of the context gets lost. First of all, these two lines just don't appear on the same screen. In the assembly version of this, they're actually about 50 lines apart, so you wouldn't see them both at the same time. That alone, to me, makes it much more reasonable that this would have just slipped through code review. If I can't see both of these at the same time, I'm much more likely to just not spot that. Now, the Game Boy used a variant of what's called Z80 assembly. And we're not going to go too much into the minutia of what that means. What's important about the differences between various assemblies is different types of assemblies have a different number of general purpose registers, the sort of global variables that your CPU can use for literally anything. And on the Z80, they only had 4 registers that were truly general purpose. And in this code that I commented out, they used all of them. So they had to load up the tile again. They could have stuck it on the stack, maybe, but you don't want this to be the one place where, oops, we don't have enough stack anymore. So they just reloaded it. And that seems perfectly reasonable to me. Frankly, if you had to work on this constraint, could you write your whole program with only 4 global mutable variables and nothing else and avoid bugs like this? I sure as hell couldn't. Okay, so the end result of all of this is on these tiles specifically, the game tries to have us encounter a wild Pokemon because it's water, but we instead encounter grass Pokemon. But that's not by itself particularly useful. So let's move on to the second piece of this. Whenever you enter a new area, the game has to load up the encounter tables for the area that you're currently in. There's one spot in memory that's just, this is the current area's grass encounter information. So the first thing it's going to do is grab how likely you are to encounter grass Pokemon in the current area. It's going to grab that from just some global section of ROM. I've made that a constant here in the Rust translation. And that's going to check if that number is greater than 0. And if it is, it's going to copy the encounter table over. And that does the same thing for water. What's important here, though, is what happens when the grass encounter rate is 0. When it's 0, we just don't do anything. It doesn't zero out the table, doesn't replace it with some dummy data. It just leaves whatever was there before. So this means that in these areas with these coast tiles, as long as that area doesn't itself have grass Pokemon, we can use this to encounter grass Pokemon from other areas. And that's why we specifically do this glitch on Cinnabar Island, as opposed to anywhere else in the game that has these coast tiles with the land on the left side. Because we can fast travel to any town, and Cinnabar Island is a town, it's easy for us to fast travel there and get to this coast in particular without ever passing through an area with grass Pokemon. So that means as long as we can use the game's fast travel system, we can use this glitch to encounter the grass Pokemon from any other area. Now, that by itself isn't necessarily the most useful thing in the world. It was used for something very specific. There's a place in the game called the Safari Zone, where there's a bunch of really rare Pokemon that you kind of want to get, but it uses its own special encounter mechanic that was really annoying and everybody hated. But with this glitch, you could just go into the Safari Zone, travel to Cinnabar Island, and go on these coasts, and then you would be able to encounter the Pokemon from the Safari Zone with the normal wild Pokemon encounter mechanics. And this was really useful, and this wasn't as widespread as Missing No, but a lot of people did know about it, and this was called the Fight Safari Pokemon glitch. We don't just want to catch Safari Zone Pokemon. Like, that's cool and all. We want more. We want 128 rare candies. If we're going to do that, we need to do this glitch when the grass encounter table contains information that isn't a real Pokemon encounter table. Now, when this glitch was originally discovered, it actually wasn't done the way I demonstrated it to you. It was done by trading with an NPC in the lab on Cinnabar Island. NPC stands for non-player character. The Pokemon games have a system where you can send a Pokemon to another trainer and get one back in return. And there are a few NPC characters who will do this without you having to have any friends in real life. Now, this game was really constrained on memory, and everything had a very specific spot in memory where it was stored, and oftentimes those addresses were reused. And this is one of those cases. Whenever you traded with another player or NPC, that person's name was stored in the same spot as the grass encounter table. So to see why this is useful to us, let's look at how encounter tables are actually stored in memory. So like I said, everything in this game just has a very specific address, and the address for the grass encounter table for the current area the player is in is D887. That 0x means it's hex notation. Now, this is a table with 10 entries. The first byte is the encounter rate, how likely you are to run into a wild Pokemon. The lower this number is, the more likely you are to have an encounter. Then we have, for each of these 10 slots, a pair of 2 bytes. The first byte is the level of the Pokemon in that slot, and the second byte is the ID of the Pokemon in that slot. And each of these slots have a fixed percentage chance of running into them. So the first 2 are about 20%, the next one's about 15%, and then about 10%, and so on and so forth. So let's take a look at what a real encounter table looked like. Address CFA3, you'll find the encounter table for an early game area called Mount Moon. So we copy over the encounter rate. 10 is really low, so we're likely to run into a lot of Pokemon. And then the 3 most common Pokemon that you'll run into is the Pokemon Zubat. And then after that, that looks like a rocky Zubat to me. I don't know. So then we finish this. Once we copy over this whole encounter table, actually for this one in particular, something might stand out to you. It's all Zubat. I don't know. I guess the game developers were like, hey, should we maybe put some Pokemon here? And they're like, oops, nope. All we've got is Zubat. It's all we got. Sorry. And so kids would go through this area, and every 2 steps, they would see another fucking Zubat. And they would go to sleep, and in their dreams, all they could see is these hordes of Zubat. And they would hear. Actually, I'm sorry, y'all. Can you hold on one second? Hey, have you not seen the news? There's a pandemic going on outside. Come on. Thank you. Sorry about that. Zubats, I swear. All right, so as I said, once we've got the encounter table copied over, this is what it looks like for Mount Moon. But of course, we don't want to run into a lot of Zubats because, well, that would just make me sad. So let's look at what happens when we copy over this trainer's name. Now, all NPCs that can trade with you in the game are, for some reason, just named trainer and nothing else. So we're going to look at what happens when you copy over the string trainer. Now, Pokemon Blue used its own custom text encoding. So trainer's actually only a single byte. There's a control character that is print the word trainer. And then the end of name marker control character is 80 in decimal. So we copy this over. We copy over trainer, which is the first byte, and that just gets ignored because we're using the water encounter rate anyway. And then 80 happens to be the ID of missing no. And so this is a really great way to do the glitch because you get an encounter table that's just all missing no, all level 80 missing no specifically. And it's great, but the problem with doing it this way is that when you trade with an NPC, you can only do it once. And once you've traded with that NPC, you can never do it again. So you can encounter a lot of missing no's this way, but as soon as you go to an area with grass Pokemon, you're not going to be able to do the glitch this way again. So we want something that we can actually repeat because we don't just want 128 rare candies. We want 128 rare candies as many times as we want because rare candies are delicious. So that's where the old man glitch comes into play. Now it's called the old man glitch because, well, his name is Old Man. And it's really what his name specifically isn't that important. What's important here is that he has a name. Because this game was optimized for code size, they didn't want to have the code be too large on the cartridge, or they might have to double the size of the ROM available to them on the cartridge. And given the budget they were working under, they just couldn't afford to do that. So everything was optimized for code size. So this tutorial could have been implemented as go to a completely separate piece of code that goes through this tutorial, or you could do what they did, which is have it go through the normal battle code. and just add like 3 or 4 conditionals to the battle code of, hey, is this the tutorial? If so, don't accept player input here. Now, the problem with doing that is there's code in there that does things like print the player's name. But since the player's not in control here, we don't want to print the player's name, we want to print old man. So they need to copy over old man to where the player's name is stored, which means they need to store the player's name somewhere. And where do they decide to do it? You guessed it, the grass encounter table. So for this demonstration, I set my name to Hi Sean, and let's take a look at what happens when we interpret that as an encounter table. So the H is going to get copied over into the rate, and that just doesn't matter again, because that's just ignored. And then I is 168, and A is, hey, that's a missing no. And then another 168, and hey, another missing no. And then we got level 174, and wouldn't you know it, they're all missing no. It's almost like I specifically picked a name that only had missing no characters in it to make it easier to demonstrate this glitch to y'all. What a coincidence. Now, of course, each of these missing no came from a different letter in my name, which is weird because those are different IDs, and so therefore they should be different Pokemon. They shouldn't just all be missing no. Let's talk about what even is a missing no. Contrary to what you might think, it's not a single Pokemon. There are actually 39 distinct Pokemon which are called missing no. And it's not just reading garbage data. Even though its sprite is clearly garbage data, it has a well-defined name. It's printing missing no there, not just random garbage. And it's not like in the code they could say, hey, is this garbage? If so, print missing no. You can't really detect what garbage data is at runtime. So this is clearly in a table somewhere that it's expecting to print this word out. And a lot of other attributes that it has are well-defined as well. To understand why some of its attributes are garbage, but others aren't, we need to see how Pokemon are stored in the code. When most people think of a list of Pokemon, they think of the order that they appear in the Pokedex, the in-game encyclopedia. Every Pokemon has a number associated with it, and they're loosely ordered in the order that you would encounter them in the game. But that's not how they're stored in the game. When most people think of Pokemon number 1, they think of Bulbasaur because that's the first in the Pokedex. But actually, the Pokemon with the ID of 1 is called Rhydon. In the code, most of the data related to the Pokemon is stored in the order they were originally created. The game was supposed to ship with 190 Pokemon at one point in development. 40 of those got either cut or saved for another generation, and then 1 got added at the very last second. And so missing no is what's stored in the slots where the cut Pokemon were supposed to be. Now, for the most part, those entries where missing no's data is just zeroed out. It's all zeros. There's some exceptions, like its name. But for example, its Pokedex ID is 0. Its cry, the sound that it makes when you encounter it, is almost always zeroed out. So for anything that's ordered by internal ID, we're going to get well-defined but zeroed data. But for anything that's stored in Pokedex order, we're going to get garbage. And let's look at why that is. One of the things that's stored in Pokedex order is the Pokemon base stats table. This includes things like its attack and defense and HP, what it can evolve into, what moves it can learn, and importantly, it also contains the pointer to the sprite. So the first thing the game is going to do is look up the Pokemon's Pokedex number from its internal ID, and for missing no, that's 0. Now, because Pokedex numbers start at 1, they subtract 1 from that to turn it into an index into an array. This is an unsigned 8-bit integer, so this is going to underflow, and we're going to get 255. Or you could think about this like we're trying to get the Pokedex entry for a hypothetical 256th Pokemon. Now, the array that we're indexing into only has 151 elements in it, so we read way past the end of the array. And in the case of missing no's sprite, where it ends up reading is the middle of some data for NPC trainer parties in an area called Route 17. And when you interpret that as a pointer, it points to some code related to the Safari Zone. And so missing no's glitched out sprite is what you see when you interpret that code as if it were an image. But most data in the game isn't stored in Pokedex order. That's the exception, not the rule. Ironically, the Pokedex itself is one of the things that isn't stored in Pokedex order. So missing no even has a valid Pokedex entry. Well, almost. You can see it's got a name and a description and a height that looks like a placeholder, but then the weight is just sort of a random number. Its entry wasn't localized, and the structure of Pokedex entries in the Japanese version of the game was a little bit different than the English version. If we look at the Japanese version, though, we can see, oh yes, no, there's clearly valid data here for this version of the game. It's the question mark, question mark, question mark Pokemon. Its weight is 10. Its height is also 10 because height was in decimeters for some reason. And then that description translates to comment to be written. There are some differences between the different missing no's, though. In fact, a lot of them have unique data. The cry that a Pokemon has, the sound it makes when you first encounter it, is stored as 3 bytes. One that's just sort of the base sound, and these are shared between multiple Pokemon. And then another byte for a pitch adjustment, and then another byte for speed adjustment. And 9 of the missing no's have cries that aren't zeros. And a few of those actually have base sounds that aren't heard anywhere else in the game. And this supports that some of these missing no's are, in fact, Pokemon that were just cut during development. There's also a few places in the game where they needed to display a sprite as if it were a Pokemon, but the sprite they want to display isn't associated with any real Pokemon. And so some of the missing no entries are where they stored those sprites. These would only show up if you had a lowercase w, x, or y in your name, though, so most folks never saw these. And this is really important. Which version of missing no you saw was based on your name. And this is also why, if you did this glitch, in addition to missing no, you would see some high-level real Pokemon. Printable characters in Pokemon Blue's text encoding start at 128, sort of the opposite of ASCII. So no matter what your name was, the characters that would end up in the level spots for the encounter table would be higher than you're supposed to be able to reach in the game. They would always be higher than 100. You could also get some glitched trainer battles this way, but those would only appear if you had punctuation in your name. So most people were unaware of that. I certainly had no clue that that was a thing until I started doing research for this talk. Now you might be asking, if the encounter table is based on your name, why could everybody do this glitch? Surely it would be possible to have a name that didn't map to missing no at all. This is sort of true. It's possible to have a name that didn't include missing no. But even if that was the case, you could still get 128 rare candies. And it was pretty unlikely that you would have a name that didn't include missing no for a few reasons. The control character used for the end of your name was stored as 80 in decimal, which is one of the IDs of missing no. So if your name was an even number of characters, you could always encounter a missing no. And a lot of players didn't even pick their own name. They just used one of the preset ones the game offered you. By pure luck, every single one of these names has the right characters for a missing no encounter. Except it wasn't even luck, because the missing no characters were really common. They included uppercase S, H, and M, and most lowercase vowels. So the odds of you having one of these in the right place were really high. But even then, there was a catch-all. Every custom name could at least encounter missing no's sister Pokemon, Tick-M. And we call it Tick-M because those are the only characters in its name that you can actually say. Now, even though they have the same sprite, Tick-M is different. As you can probably tell from the weird characters in its name and its decision not to wear a mask, everything about Tick-M is garbage. The graphics that appear in its name are going to be based on things like your party's stats or your position on the map. Tick-M is what you get for internal ID 0, so you're going to get garbage even for data that isn't in Pokedex order. Even when it's looking up by internal ID, it's going to underflow and read past the end of whatever data it's trying to read. Now, Tick-M had some interesting differences from missing no. Its cry, being garbage data, would randomly change based on what screen you're on. It could evolve into Kangaskhan. So, I guess this is what a baby Kangaskhan looks like. You could also lock up your game by catching it. But if your goal was to just get 128 rare candies, it didn't matter if you saw a missing no or Tick-M. So now let's talk about why the 6th item in your inventory gets duplicated. This has to do with what happens after you encounter a Pokemon. This all comes back to that Pokedex that we mentioned earlier. Its function in the game is to keep track of every Pokemon you've seen or caught. Any Pokemon that appears on this list is one that you've seen before, and the little ball icon next to its name means it's been caught. Now, this is stored in memory as a bitmap, 1 bit per Pokemon. It's sort of like an array of Booleans, but instead of each entry in the array taking up 1 byte, it takes up 1 bit. So 1 byte represents 8 entries in the array. Now, as you might have guessed, this array is stored in Pokedex order. So when you encounter Missing No, it tries to mark that you've encountered a hypothetical 256th Pokemon. But since there are only 151 Pokemon in the game, this ends up writing way past the space used for this. The bitmap has to be rounded up to a number that's divisible by 8 since it has to fit in a byte. So what ends up happening here is there's 152 bits for real Pokemon, and where it ends up trying to write is the high bit of the 13th byte after the end of your Pokedex. Now, the inventory is what's stored immediately after your Pokedex in RAM. The inventory is stored as 1 byte for the number of items that you have. And then for each item, there's 1 byte for its ID, and then 1 byte for its quantity. So that means the byte that it tries to write to corresponds with the quantity of the 6th item in your inventory. And another way of saying it sets the high bit of the quantity of the 6th item in your inventory is it adds 128 of that item as long as you had less than 128 before. Now, one other side effect of encountering Missing No is if you had beaten the game when you perform the glitch, you'd notice that the place where it stored the team that you used to beat the game was now corrupted. And this is caused by Missing No's sprite. Remember when I pointed out that the pause at the start of the fight was abnormally long? This corruption is why that happens. Due to the amount of space they needed to decompress these sprites, they can't do it on the console's RAM. So instead, they do it on the cartridge's persistent storage. The space they use for this is large enough for a 7x7 sprite, which is the largest that appears in the game. But the data that represents Missing No's sprite says that it's 13x13. So they write way past the end of that buffer, and the next thing on the cartridge's storage is the Hall of Fame. But because Missing No's sprite was read from ROM, not RAM, that means that the sprite data never changed, and so everybody who did this glitch would see the same corrupted Hall of Fame. Although you wouldn't know it immediately because some of the names of the Pokemon would include things like the control character for printing your rival's name. So a lot of people would see an Ammonite named Gary because Gary was a really common rival name, but it would change a little bit. Now, this bug would have been avoided if there was some bounds checking in the sprite decompression code. But like I mentioned before, everything in this game was optimized for code size. And if you're only dealing with a known set of trusted inputs, omitting these checks seems perfectly reasonable. When the code received real sprites, it always behaved perfectly. The only reason this code misbehaved was because of a completely unrelated bug that caused it to get garbage data. Now, those are the only two abnormal effects of encountering a Missing No compared to encountering any other Pokemon. Remember that the main way this glitch spread was through word of mouth. That means that there were a lot of untrue or half-true rumors that spread around, and I'd like to debunk a few of those. The biggest piece of misinformation you might have heard is don't catch Missing No or it'll corrupt your save. And this is just straight up false. There's no ill effects of catching Missing No, and there's really nothing about it that can't be saved normally. I think the source of this misinformation was a very specific problem that can arise with TickM. In the games, you can bring up to 6 Pokemon with you in your party. And if you catch another one when your party is full, it gets sent to a storage system. And when you open up this storage system later, the game has to recompute the stats for all of those stored Pokemon. And there's a bug in this calculation where if it tries to compute them for a level 0 Pokemon, it gets into an infinite loop. Now, you're never supposed to be able to encounter a level 0 Pokemon. But if you did this glitch with a custom name, you could always encounter a level 0 TickM. It would always occupy the bottom 2 spots in that encounter table. And since at the point you did this glitch, you probably had 6 Pokemon in your party, that means it probably went to storage. So I think this was the source of that rumor. Another thing you might have heard is that catching Missing No would cause all sorts of graphical glitches. Nintendo even put out a statement saying to try releasing it to fix the scrambled graphics. And if that doesn't work, you need to restart your game. And just all of this is nonsense. There's a specific mirroring effect you can cause if you view the stats screen from Missing No. What happens here is on the stats screen, the sprite for the Pokemon is displayed mirrored, and there's a byte that says just render this sprite mirrored. And for whatever reason, when you view this screen for Missing No, it doesn't set that byte back to 0 afterwards. But only front-facing sprites are supposed to be rendered mirrored. So anytime it's a sprite that represents something's back, it gets this weird jagged effect. But this would go away if you viewed the stats screen for any other Pokemon, because it would set that byte back to 0 correctly. There were some bigger glitches if you had Missing No in the follow-up game Pokemon Yellow. But in that game, they also fixed the bug that let you encounter Missing No in the first place, so I don't think that's the source of this. Finally, encountering Missing No wouldn't save your game. This is a really weird rumor, and I'm surprised it even got started because it's so easy to verify as false. You just do a Missing No encounter and reset without saving and see, yeah, no, that did not save. I think the source of this one is an N64 game called Pokemon Stadium. It included an emulator and let you play the first 2 generations of Pokemon games. And whenever the cartridge's storage was written to in that emulator, it would display the word saved on screen. So when that buffer overrun happened, that corrupted the Hall of Fame, that would cause the N64's emulator to display saved on screen. And I think that's where this one came from. So now we've seen every piece of this glitch. We can see that it was just a bunch of small, seemingly benign interactions between unrelated bits of code. No individual piece of this glitch stands out to me as insane or something that obviously would have been stopped in code review. When you combine all this together, you get one of the most famous glitches of all time. But it's not the result of some horrendously bad coding or lack of QA or any of the other things you might hear people say about this game. Every piece of this glitch by itself was relatively benign, or just due to completely unrelated parts of the code interacting in ways that nobody would have expected. And this was handwritten in assembly under massive space constraints. Every instruction mattered. I certainly don't think I would have done any better than they did, and I don't think anybody watching this would have either. A phrase that I've heard from folks making fun of the glitches in this game is completely broken. I think we should just remove that from our vocabularies entirely. In this case, and many others where you would try and use that terminology, it's more likely the software is developed under some constraints that you weren't aware of, and you wouldn't do better in the same circumstances. Sure, these days they're less likely to be technological constraints, but every single one of us has worked on a project where 2 days before the deadline, the requirements change out from underneath you. Or your company suddenly pivots and now you do medical services and you have to figure out how to make a bunch of code relevant for that. To me, though, a lot of this glitch just boiled down to because assembly. It's really easy for us to take the technologies we have at our disposal today for granted. Today, code size is rarely a hard constraint. You're unlikely to ever work on a project where this binary has to be 27K or smaller or we can't ship at all. When code size matters today, it's usually because of CPU caches, and it's a thing we find while optimizing our code. And we run our code on machines powerful enough to just include all sorts of safety checks and never give it a second thought. But in 1996, just use Rust wasn't an option. And even using C wasn't an option. I'm really glad that we don't live in that world anymore. There's a really high quality disassembly of the game available, which I used to research this talk, called PokerRed. It doesn't have the comments in it that the real source code would have, but this team took the machine code from the game, disassembled it, and went from there and figured out where all of the labels would have been and where they would have used macros and turned it into something that resembles real source code somebody would have written. It's an amazing project, and it was invaluable for preparing this talk. So a huge shout out to the team who worked on that. I also want to shout out the organizers. This has been a great conference, and doing a virtual conference like this is a lot of work. I want to give a special shout out to Nell Shamrell, who led the program committee and made it a point to do multiple run-throughs of every talk with the speakers before they presented them. That means that you got a much higher quality conference than you would have otherwise. So thank you so much. Finally, this talk was co-authored with my partner Tess, and she also helped me with a ton of the slides. Tess, I love you. Thank you so much for working on this talk with me. It was a blast. If you have any questions, I will be in the Discord immediately after this. If you're watching this in Europe live, go to bed. It's like 3 a.m. What are you doing? If you're watching a recording and you want to ask me a question, here's my contact info. Feel free to reach out, and I'm happy to answer any questions you might have. Thank you so much for watching, and bye.
Thank you so much, everyone, for making it this far. I've enjoyed getting to know many of you in Discord and the companion app today. It's been a great opportunity to feel a little less isolated and alone. Again, the best thing about the Rust community is that we are a community where empathy and personal maturity are as important, if not more important, than technical excellence. And I've certainly seen that today. If you take a look at the companion app, you will now see a link to a post-conference survey where you can leave constructive feedback on the conference, as well as constructive feedback for specific speakers. The speaker feedback will first be seen by the conference organizers, who will then pass along constructive comments to the speakers anonymously. As for the conference feedback, we would love to know what you enjoyed the most and what changes you might like to see in the future. The full live stream recording of today will stay up on YouTube for now. Sometimes big files like these do get taken down on YouTube, but fear not, individual videos of each session will be available within the next couple of days. I want to thank our sponsors one more time. None of this would be possible without them. Thank you to Mozilla, Google, Solana, Informal, OneSignal, Chef, Microsoft, Jolocom, Integer32, and YWorks. Thank you again to all of our attendees, and I will see you on the Discord.